We'll be starting off with our topic, geometry. Geometry is basically divided into 5 sections, which I'll be talking about. But first, I wanted to help you understand what is the essence of geometry. Okay. Particularly, geometry is made up of two words, first being geo and second being metry. Geo means the earth and metry means measurements. So, when geometry was evolving and when scientists were finding it difficult to predict the daytime or the nighttime, it was difficult for them to navigate through the oceans, and it was difficult for them to tell at what time the sun would rise on the next day, because the seasons were changing. The summers came, the winters came. So in those times they could see that the sun and the earth are playing with each other. Okay, that time I'm using a very layman language to help you understand what I'm actually talking about. The sun and the earth were playing with each other, that in the winters the sun never used to like come at the same time, did not used to set at the same time. Similarly, the moon did not come at the same time, and multiple geometrical evidences they were trying to prove, which was getting very very difficult. So geometry evolved as the measurements of the earth. Okay, the measurements of the earth. So I have already split it into two parts, geo and metry. Now geometry is divided into 5 different sections. First one being lines and angles, second one being triangles, third one being quadrilateral, fourth one being regular polygons, and fifth one being circles. What is line and angles? Line and angle. Line is basically nothing but a locus of a straight lined or a straight pattern of points. What do we mean by each and every word that I have written down in this definition of a line? Okay, locus means the joining or the collection. Okay, locus means the joining or the connections, the connection of straight pattern points. Okay, let's assume for one point is there, second being there, third, fourth, fifth, and sixth, and seventh. Okay, so we have 7 points over here, and if I start joining two of them at a time, I would see that they are joining in a symmetrical pattern. They are joining in a symmetrical or a straight pattern. Symmetrical pattern means if I cut it from here in the middle, the left one would be the same image or the replica of the right one. So they were getting cut, or they were forming a symmetrical pattern when they were getting joined. So locus of straight pattern points can be called a line. What does an angle mean? An angle means the deviation, the deviation deviation of an object from a straight path. Let's assume that this was the motion of the object and suddenly it took a left turn. Okay, we are going here and suddenly it took a left turn. So if I need to navigate and reach the same object, and let's assume that this was a ball over here. Okay, so this was a ball and it got deflected and now it is over here. Now if I wish to prove mathematically where the ball has actually gone, then mathematically I will have to draw a perpendicular over here and a perpendicular over here, which is the straight line of the ball and the 90-degree or the perpendicular to the ball. Then I will have to calculate the angle. I will have to calculate this angle with which it deviated. So let's assume 60 degrees. 60 degrees is basically deviation from the normal. But if I talk about deviation from the path of motion, this is my path of motion. This is my path of motion and this is my normal. This is my normal. So as you can see, the ball moved 30 degrees away from the path of motion and 60 degrees from the normal. Okay, so lines and angles is pretty clear. What are triangles? Triangles are nothing but three distinct points in the same plane which join together to form an enclosed figure. It takes a minimum of 3 points and a maximum of 3 points as well. It takes 3 points to create a triangle. What about quadrilateral? Similarly, when I say triangle, it has 3 angles or 3 points in it. A quadrilateral would have 4 points or 4 vertices or 4 angles in it. What about regular polygon? A regular polygon is nothing but a closed figure. Okay, it's nothing but a closed figure with multiple vertices. Multiple vertices. Closed figure with multiple vertices is a polygon. And what about a circle? A circle has infinite vertices. Okay, it has infinite vertices because you cannot point out at one place where you can see that this is the point where the circle has one vertex. It has infinite number of vertices. That is how a collection of those infinite vertices together, which are equidistant from the same point. Okay, a collection of infinite vertices which is equidistant from the same point makes a circle. Okay, also a definition of circle would be it is okay, the definition of a point against a circle. Okay, so this is the point which I've made over here. This is a point, and this is a circle. Okay, this is a circle. What is a point and what is a circle? I've already introduced you to circle. Circle is basically one center point being there and infinite number of vertices surrounding it at an equal distance. Now, what is the definition of a point in terms of a circle? In terms of a circle, a point is nothing but a circle with zero radius. It is a circle with zero radius. When I'm making a point, when I'm making a circle over here, see, this is the center, which is usually represented by O. So all the vertices or all the edges of the circle are always equidistant from the center. And the distance between the corner or the edge of the circle to the center of the circle makes it my radius. Makes it my radius. So I've pretty much explained all the points which are involved in geometry. Now we will be digging deeper in them and I'll help you understand most of the concepts in more clarity. First off, we'll be working with lines and angles, which is our standard and starting concept. What is a line? A line is defined is basically a straight one-dimensional figure that extends infinitely in both the sides and directions. Okay. When A or B does not have any origin or does not have any end, that is basically called a line. Okay. It is infinitely moving in both the directions. Okay. Infinitely moving in both the directions. It is also sometimes called the shortest distance between 2 points. Okay, these are theories. These might not be very useful, but for somebody who like doesn't know anything, who's just starting off, it will be very useful for them to learn these things. What is a straight line? A straight line is a line which doesn't change its direction. Okay, it's a line which doesn't change its direction. What about a curved line? A curved line is something which changes its direction very smoothly. It changes its direction very smoothly. It is not going into different directions very abruptly. It is going in different directions very smoothly. Okay? Smoothly. So there is a smooth transition between the 2 points when a line is moving. Finally, what a line segment is? A line segment usually has two end points. Okay, this is very important for you to know that a line segment has two endpoints, and a line is sometimes straight away replaced to be called a line segment. They can be used interchangeably. Okay, you cannot demand like from the examiner or from the test taker that you've written line over here and you've written line segment over there. These standard definitions are of use only for understanding purposes. In any question, if you find line and line segment being written, do not think of them as two different entities. They are almost the same thing. Okay. Moving further, what is a ray? Okay. What is a ray? Um, a ray is basically a line which has only one point defined. Okay, which has only one endpoint, and that endpoint is defined and the other end is moving towards infinity. The other point is moving towards infinity. That does not mean that I will use up all the pages of my notebook and try to send it out towards infinity. By stretching a point from here to the other direction can easily define as this geometric figure to be a ray. Okay, you need not use your entire notebook to display a ray. Further, what is a point? A point is a fundamental concept that represents a location in space. I've already talked to you about it. It is nothing but a circle with zero radius, or it is also called a zero dimensional object. You cannot measure its length, width, or height. There is no length, no width, or no height of a circle. Okay, I hope I've made myself pretty clear about it. So, moving ahead. All right. So, we'll be talking about the type of points that we have. Number one being the collinear point. Okay. In collinear point, what happens is that there is a particular line, and we found all the points in question to be on the same line. Okay. Let's assume this is A, this is B, this is C, this is D. When we talk about collinear points, we find out all the points in question to be on the same line in a two-dimensional figure. It is also applicable to be in a three-dimensional figure, but here we are restricting ourselves to two-dimensional figures. That is why collinear points are those points which are situated on a straight line. Okay, moving ahead. Non-collinear points. Non-collinear points are nothing but the opposite of collinear points. Okay, they would lie in the same plane. This is very, very important. They would lie in the same plane. When I talk about lying in the same plane, what I mean is they would lie on the same sheet of paper. They would lie on the same sheet of paper, but they are not collinear because they are at different spaces. Okay, on the same sheet of paper but different spaces. So over here, as we can see that A, B, and C do not form a straight line together. That is why they are called non-collinear in nature. Moving ahead, what is an angle? I think spoken about it in the first slide itself. Let me go back. I'll just show it to you. Uh, yeah, when I was talking about a ball deviating away from its path, at that moment I told you about angles. Okay, at that moment I told you about angles. So this over here is 30 degrees, this over here is 60 degrees. Yep. So an angle is a geometric figure which is formed by a set of two rays. Okay, this is something very important. It is formed by a set of two rays which share a common endpoint. Okay, so the origin of this angle is called the common point for both of them, which is ray B and ray A. Ray B and ray A. This is the common point, and both of them are diverging. Both of them are digressing, or both of them are diversing in two different areas. Okay, that that and only that will create an angle between them. Okay, the rays that form an angle are basically called the sides of the angle. Okay, this is side OA and this is side OB, and the measure is typically given in degree radians. Okay, there is a very beautiful concept which which hasn't been mentioned over here, but this question has been asked multiple times by different examinations. To complete one circle, the perimeter is 2 pi r. I am assuming that this circle has unit radius. When I talk about unit radius, it means it has 1 unit radius. When I put this value of 1 unit radius in the perimeter, it calls for 2 pi. When I talk about the angle which is being formed at the center by the center of the circle itself, that is nothing but a complete angle which is 360 degrees, because it is starting from 0, moving towards 90, then 180, then 270, and then coming back to 0, which completes 4 times 90, which completes 4 times 90, and that is also a quadrant. One quadrant is 90 degrees. So we have 4 quadrants. That means 4 times 90 is nothing but 360 degrees. Okay, it's nothing but 360 degrees. So the value of 360 degrees can be given as 2 pi. So when I talk about 360, I will call it 360 degrees. When I talk about radians, I will call it 2 pi radians. Okay, you'll find it in multiple exams that it has been asked that convert, let's say 270 degrees to radians, to radians. So when 360 degrees is called 2 pi, when 360 degrees is called 2 pi, then 270 degrees would be called 2 pi divided by 360 multiplied by 270. Cut with cut. 3 9s are 27, 3 12s are, 3 4s are, 3 3s are. So it is called 6 pi by 4 or 2 pi by 3. Okay, I hope I'm not wrong at all. Okay, 9 3s are 27, 9 4s are this, 2 1s are, 2 2s are. No, it's basically 3 by 2 pi, not 2 by 3 pi. It's 3 by 2 pi. Okay, it's 3 by 2 pi radians when I'm talking about 270 degrees in radians. So this standard formula, this standard point, you need to remember all the time. I'm just highlighting it for you. Okay, that 360 degrees is nothing but 2 pi radians. Okay, I have highlighted it all for you. 360 degrees is equal to 2 pi radians. Okay, moving on. Now we'll be talking about types of angles. In types of angles, I've already talked about it in the past. Like I've already talked about what an angle is. So let's assume that this is a straight line that we have. This is a straight line that we have, and it is a nothing but a line segment. And then I say again from the same origin, I produce a line which goes, I produce a ray which goes in the direction of AC. Okay, this is the direction of AC, and let's assume that this is also a ray, and this has been given the name B. So this is going in the direction of AB. So if the value of the angle or the deviation from the normal is less than 90 degrees, if it is less than 90 degrees, then this particular thing is called an acute angle. This particular thing is called an acute angle. Okay, here this angle is denoted by the one which I have created. This angle is denoted by angle BAC. The angle is called angle BAC, and let's assume the measurement of this angle is 30 degrees. So angle BAC is equal to 30 degrees, which is less than 90 degrees. And I will call BAC with the name that angle BAC is an acute angle. Okay, moving ahead, trying to explain you different angles as well. When the deviation is on an angle which is completely tangent to the direction where we were going. Or let's assume that we were going in the straight direction and we took a very sharp left turn. So it will directly go straight. So the angle produced over here is 90 degrees. The angle produced over here is 90 degrees. Here we call it angle AOB. This angle can also be called angle BOA. There is no such rule that AOB is different from BOA. Both of them are the same angles till the time the numbers are matching. Okay, till the time the numbers are matching. Moving on, obtuse angles. Obtuse angles. So in obtuse angles, what happens is that the measurement of the angle is no more 90 degrees. Had 19 degrees stopped over here, let's assume over here, till here it was 90 degrees. Till here it was 90 degrees. Anything ahead of that is 30 degrees more, which is 90 plus 30 equal to 120. So here we'll say that angle AOB is an obtuse angle. Angle AOB is an obtuse angle. 90, 180. This is where it lies. Okay, moving on. What is a straight angle? I was walking in the same direction, in this direction, and my mother called me back home. Okay, so let's assume that this was my home. This was my home where I started off from, and my mother called me back. So instead of going straight, I will take a U turn, come back, and start moving towards my own direction. If somebody will ask me, what angle did you cover when you took the decision of coming back home? What angle did you cover? So I would say that I took the 90-degree turn twice in the same direction. First in the left direction, then another one also in the left direction. Okay, you could have also taken a 90-degree turn, first in the right direction, then the other one also in the right direction. This is how 180 degrees is reduced, which is nothing but a U turn. Okay, this is nothing but a U turn. Moving on, reflex angle. See, reflex, when I talk about reflex angles are always mirror images. Okay, you have to define one angle first in order to get a reflex of it. Okay, the standard thing what people say that all reflex angles are more than 180 degrees. This looks good in definition, but in practicality, if there is an angle which is of 150 degrees and the question says that tell me the reflex of AOB, of angle AOB, then I would say that the reflex of angle AOB is 360 degrees minus 150 degrees, which is equal to 210 degrees, which is equal to 210 degrees, which is equal to the reflex angle. Okay, I hope you've understood my point. Moving on, adjacent angles. Adjacent angles, okay, these are two adjacent angles. What happens in adjacent angles is that one ray was going here, the other ray was going up, so you formed one angle of it. Let's assume another ray was originated from this point and it started going in the upward direction. Okay, let's assume this was ray A, this was ray B, and this was ray C. Okay, this is O. This, the origin of all the rays is O. So from A, one went in A direction, one went in B direction, and the third one went in C direction. So the angles that are produced between the two rays A and B would be called adjacent. Adjacent angles are nothing but neighbor angles. Okay, they are nothing but neighbor angles to each other. So the angle between ray A and B would be called adjacent to the angle between ray A and C. Okay, these are nothing but adjacent angles. These are adjacent angles. So here angle BOC is the first angle and angle AOB is the second angle. So the angle 1 and angle 2 are adjacent. Also, one very like standard thing to say is that ray OA or side OA is common. Okay, side OA is common over here. Similarly here, side OB is a common side. So this is a standard point for adjacent angles, that whenever there is an adjacent angle, there would be a side which is common to both of them. Okay, because if you wish to call somebody a neighbor, you should have a dividing line between the two of you, then only you can call somebody a neighbor. Okay, moving on. Complementary angles. Complementary angles are angles which complete each other. Which complete each other to what extent? Which complete each other to the extent of 90 degrees. Okay, when two angles complete each other to the extent of 90 degrees, or their sum is equal to 90 degrees, then those angles are called complementary angles. Okay, complementary. Here theta 1 and theta 2, when they are added up, they form 90 degrees, or a square angle, which is nothing but a set of complementary angles. Okay, this is nothing but a set of complementary angles. Moving on, there is something called supplementary angles. Complementary angles complete each other, supplementary angles supplement each other. When I talk about completing each other, it means that one angle cannot survive without the other angle. Okay, I'm talking about this in raw terms, completely raw terms. That one angle cannot be standalone, it is needs a completion with a couple. But when I talk about supplementary angles by way of definition is that two angles when they are part of a straight line. Okay, two angles when they are part of a straight line, they become supplementary angles. Let's assume this is a line in front of me. This is a line in front of me, and I have one ray which is going in this direction. So the angle between the first and the second line, and the angle between the third and the baseline, would create supplementary angles. They supplement each other. Okay, which is one level above complementary, which is one level above completion. That is called supplementary angles. Okay, so theta 1 and theta 2, as they are lying on the same line, they are supplementary to each other. Okay, remember, do not say all the time that they lie on one line. No, this is not a complete definition. What does the complete definition say? A complete definition say that angle 1 plus angle 2 is equal to 180 degrees. Okay, line 1 plus line 2, or like both of them say staying on the same line, is an output. When I say that both the angles are lying on a same line, it is one step ahead. I'm overstepping. I'm giving you an output, but I wish to stay on the basics, and the basics says that angle 1 plus angle 2 is equal to 180 degrees. Got it? Moving on. Vertically opposite angles. Okay, vertically opposite angles. When two angles form two pairs of opposite rays, it means one ray was going in this direction, another ray is going in this direction. So this basically gave out one origin point O and four different angles A, B, C, and D. If you will help me identify the angles, I'll tell you it's angle AOB, angle BOC, angle COD, and angle DOA. There are four different angles. So the angles which lie opposite to each other, they are called vertically opposite angles. Okay, the angles which lie opposite to each other are called vertically opposite angles, and that can be easily depicted from here. And these angles are nothing but equal to each other. So vertically opposite angle A and this angle A are equal, and vertically opposite angle B and angle B are equal. Okay, remember this. The vertically opposite angles are equal in nature. Why? Because we started off from this angle, and a mirror image of it was formed on the other side. So this angle is not going to discount itself to create a mirror image of itself. This angle shall remain the same if you even if you look at from here or you look at from the other side. Okay, I hope you're able to understand what I'm talking about. Angle AOD and BOD are vertically opposite. Also, there is this thing which I have very clearly said. Then angle AOC is equal to angle BOD. They are opposite to each other. That is why they are equal. Similarly, angle BOC and angle AOD are opposite to each other. That is why they are the same. Corresponding angles. Now there is something called these two. Like to create corresponding sides or to create corresponding angles. There are two very important elements which are required. Okay, two very important elements which are required. The first one being two parallel rays, two parallel rays or two parallel lines, and then there is one common transversal, one common transversal. Okay, two angles are complementary. Just a second. So these are corresponding angles. Okay, I'll just tell you about it. Just a second. 1 and 5. Two angles are complementary. See, actually, the definition from the previous angle has come down. Okay, the definition from previous angle from the previous slide has come down. So this is not required. The only point here is corresponding angles are, there are supposed to be two parallel lines and one common transversal. The two parallel lines that we have are X and Y. These are parallel. When I say X is parallel to Y, I draw these two parallel lines in between to represent it. Okay, X is parallel to Y, and Z or Z here is the transversal. Okay, Z over here is the transversal. Now it says that this angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. Okay, angle 3 is equal to angle 7. This angle 1 is on the same side of X and Z as angle 5 is on the same side of Y and Z. When it comes to parallel lines, X and Y can be used interchangeably. That is why the same transversal, will make the same angle with two parallel lines. Okay, so that is the concept of corresponding angles of the same transversal. Okay, I hope that is clear to you. Now, talking about alternate angles. When two parallel lines, which are X and Y, are intersected by a transversal, they form a pair of alternate angles. Okay, they form a pair of alternate angles, and those alternate angles come out to be called as alternate interior angles. Okay, here angle 3 and angle 5 are equal. Similarly, angle 8 and angle 2 is equal. Okay, if I go one property ahead, and I talk about, and I use the blue pen to help you explain about it, I'm just skipping one part. What I'm doing is I'm proving that angle 1 is equal to angle 3. Where did we learn this? We learned this in vertically opposite angles. Using the properties of vertically opposite angles, I can say that angle 1 is equal to angle 3. This is used by the property of vertically opposite. Further, angle 3 is equal to angle 7. Angle 3 is equal to angle 7. When I say that angle 3 is equal to angle 7, the property I am using over here is corresponding angles. But if I use the first equation and the second equation, I can easily say that angle 1 is equal to angle 3 is equal to angle 7, or simply angle 1 is equal to angle 7. This very far off relationship, the very far off brotherhood, which was separated by I don't know what forces, when it has come back in the light of angle 1 being equal to angle 7. Okay, angle 1 being equal to angle 7, and this, my friends, forms the concept of alternate exterior angles. This forms the alternate exterior angles. By the help of these two identities, angle 3 being equal to angle 5 and angle 2 being equal to angle 8, they were cocooned, or they were hidden by the parallel lines x and y. But talking about angle 1 and angle 7, these are lying on the exteriors of the parallels. Angle 1 is lying completely outside, and angle 7 is also lying completely outside. So these two angles are lying completely outside. That is why the word exterior has been used over here. Okay, this class is particularly for the basics, and you must go back and learn each and every concept twice if you find any difficulty in learning this. Moving on, the consecutive interior angles, which are lying in the same shed or which are housed in the same area, they are also supplementary in nature. They are also supplementary in nature. So here angle 2 plus angle 5 is equal to 180 degrees. Angle 2 plus angle 5 is equal to 180 degrees. Similarly, angle 3 plus angle 8 is also equal to 180 degrees, because they are basically living in the same house opposite to each other. Okay, living in the same house opposite to each other. They're also called pairs of consecutive interior angles. Okay, consecutive interior angles. So this was pretty much about all the basics and all the concepts which are involved in lines and angles. Okay, I'll just walk you through them in maybe 2 minutes. Just give me a moment about it. We talked about geometry being divided into 5 sections. I've talked about geometry, geo and metry, earth and measurements. Then about a line, which is a locus of straight points, straight pattern of points. Okay, when they are collected, then they form a line. About angle, forming a deviation from the straight path. Triangle, 3 points. Quadrilateral, 4 points. Regular polygon, multiple points. And circle, infinite number of points or infinite number of vertices. Similarly, all definitions: line, straight line, curved line, line segment. Ray, ray starts from one point and does not have an end. It ends at infinity. Typically, talking about the type of points we have are collinear points, non-collinear points. Collinear points being on the same line, non-collinear points being away, like being on different, being in the same plane, but not being in a straight line. They are non-collinear. Angle, again talking about the deviation. The very standard and the very main point which I wanted to discuss was 360 degrees is equal to 2 pi radians. Very, very important for the examination point of view. Types of angle: acute angle, any angle less than 90 degrees is acute. Right angle, this is a right angle. Okay, the L shape which is formed is a right angle, this being 90 degrees as the angle. Obtuse angle, this was, if this was the right angle, then if I open it a little bit more, this would form an obtuse. Okay, this is acute, this is acute, this is right, this is obtuse. Straight line, sorry, straight line being a straight line and a 180-degree angle is formed. For the reflex angle are always mirrors of a smaller angle. Okay, mirrors of the smaller angle means if you subtract 360 from the smaller angle, or the smaller angle is taken away from 360, that will give you a reflex angle of that particular angle. Okay, or any angle in a standard definition above 180 degrees but less than 360 degrees can be called a reflex angle. Adjacent angles, neighboring angles, complementary angles completing 90 degrees, supplementary angles completing 180 degrees, vertically opposite angles, if there is an x forming, the above x and the above x and the left right of x would be equal. Corresponding angles, if there are two parallel lines and one common transversal, then the angles which are 1 and 5 are going to be corresponding to each other, because X and Y can be used, or the parallel lines can be used interchangeably. Okay. Alternate angles, I've already talked about alternate angles. Alternate exterior angle is something which is very important. Alternate angles are 1 are 3 and 5 over here. I hope you can see 3 and 5. When I talk about external alternate angles, they are 1 and 7. Consecutive interior angles, they are supplementary in nature. So that's pretty much about the basics. Now we'll be moving on towards the concept. Now, in concept one, there are two basic questions for lines and angles, which I would really want you to understand pretty properly, okay? Because these look very easy, but once in the exam, if you don't know, if you can't remember what supplementary angle is, what complementary angle is, then you're gone, okay? These are very, very low hanging fruits, and you must learn how to attempt these questions. These low hanging fruits are really, really necessary to help you get a good score, okay? So, the first question is, if two supplementary angles differ by 74 degrees, then one of the angles is. Now, probably there were options available in the questions too, in the question two, which I have removed. So I'll just talk about it. When I talk about supplementary angles, let's assume the first angle being A and the second angle being B. So if two supplementary angles are there, then the sum of supplementary angles would be 180 degrees. Okay. Sum is 180 degrees. The difference according to the question has been written as A minus B equal to 74 degrees. Now, if I add up both the equations, the B would get cancelled and twice of A would be equal to 254. So 1A would be 127 degrees. And the value of angle B accordingly would be 50 plus 3, 53 degrees. Okay. So I have found out the value of both the angles. So either one of them was asked in the question. The only catch over here was, remember that supplementary angles are 180 degree in sum and complementary angles. Complementary angles are 90 degrees. The sum of complementary angles is 90 degrees. Okay. Moving on to the second question, and this is basically the last question of concept one when it comes to basic lines and their angles. Okay. So there is a triangle ABC. I'll just quickly draw a rough figure of triangle ABC. This is triangle A, B, and C. It says that AC is equal to BC. This AC is equal to BC. Angle ABC is equal to 50 degrees. This angle has been given as 50 degrees. 50. Okay, I'll just write 50 and a dot over here. Angle BC is produced to D. When it says BC, it means that you have to move from B towards C. Okay, this is very important. From B towards C and produce it to the point D, such that BC is equal to CD. Now this BC is equal to CD. If let's assume this is line A, this is line B, this is line C, and this is line D. If A is equal to B and B has been and A is also equal to D, then I can easily say that A is equal to B is equal to D. All these lines are equal. Now there is a very beautiful property which I would want to introduce to you. If the opposite sides are equal, then the opposite angles would also become equal. Okay, opposite sides of opposite angles are equal. Or if you have opposite angles which are equal, then I can assume that the sides which are opposite to them would be equal. So I'm firstly extending this point till here. We have angle 50 over here. These two, line A and line B, are equal. So 150 is over here. So one angle 50 is over here. So this angle would also be called angle 50. It's asking me the value of angle BAD. So we already have this 50 over here. According to the external angle theorem, this means that this external angle, angle ACD, this external angle would be equal to the sum of the interior angles. The interior angles in this case would be 50 plus 50, which is equal to 100 degrees. Okay. Now talking about only this bigger triangle on the outside, and this is the imaginary line which we created, which is AD. Okay. If I have 100 degrees over here, and I'm supposed to check what this angle is, this particular angle, angle CAD. So what I'll do is, these two lines, line B and line D, are equal according to the question. According to the question, line B and line D are equal. So these two angles, let's assume this is angle X and this is also equal to angle X. So these two angles would be equal. In a triangle, the sum of all the angles is 180 degrees. 180 degrees is equal to 100, this being the first angle over here, plus 2 times of X angles, which is X angle here and X angle here. So when 100 goes here, 80 degrees is equal to twice of X, or X is equal to 40 degrees. When I have the value of X equal to 40 degrees, I'll plug it in over here, and the full angle BAD would become 50 plus 40, which is equal to 90 degrees. Okay, so this is 90 degrees, which is my final answer. We'll now be moving towards the concepts of triangles. Before that, I'll give you a very a good foundation for triangles. I'll tell you the definition, I'll tell you their types, and then we'll be moving on. So yes, we've now reached triangles. Okay, anything like a figure which is a closed figure, a figure which is a closed figure with 3 points in the same plane, which when joined form a closed figure with 3 vertices and 3 sides. Okay, it's basically a combination of 3 vertices and 3 sides. When they are joined, they form a triangle. There are a few basic features of triangle which you must know. The first one being the angle sum property. Okay, this is called the angle sum property. The angle sum in the angle sum property says that in a triangle, the sum of all the angles is equal to 180 degrees. Okay, no matter how long the sides are, no matter how obtuse or acute the angles are, the sum of a closed figure with 3 vertices and 3 sides is always going to be 180 degrees. So that is the first and the very standard form which you'll see we will be using across all the questions of triangles. Okay, almost all the questions would be covered with this basic only, that the angles are all, when they are summed, they are all equal to 180 degrees. So we're done with the angle sum property. We're done with the angle sum property. Coming down to this point where the angles opposite to equal sides of a triangle are always equal. Okay, this type of triangle where 2 sides are equal, which in turn gives us the property that opposite angles to equal sides of a triangle are also equal. This kind of a triangle is known as isosceles triangle. Isosceles triangle. Isosceles because 2 sides are equal. So this basically helps us come to the deduction that angle B is equal to angle C. Okay, so these two concepts are again equal, again sorted. The first one being the angle sum property, the second one being the story of isosceles triangle, where angles which are opposite to equal sides of a triangle are also equal. Okay, moving on. If one angle of a triangle is the maximum as compared to the other two angles, okay, the second angle and the third angle, so the angle which is opposite, or the side which is opposite to this angle, would also be max or the longest. What can we deduce from this property? Let's assume that this is a right angled triangle, or this is an equilateral triangle which I have formed with my hand. If this angle, the top angle, exceeds itself and creates, let's assume the bottom line is a straight line, and this exceeds itself and opens itself up, and it is no longer an equilateral triangle. This has actually become an obtuse angle triangle. So the biggest angle at the top, the biggest angle, which is this angle at the top, so this biggest angle would also have the longest side opposite to it. Okay, it would always have the longest side opposite to it. Okay, here there is also one very smart or a very standard thing which is done, that this is angle A, this is angle B, this is angle C. So the side which is opposite to angle A would be called A, small a, denoted by small a, which is opposite to side, or which is opposite to angle B would be called small b, and something which is opposite to angle C would be called small c. Okay, so A, B and C. I hope you are able to understand where I'm coming from. All right. So three properties. The first one being the angle sum property, that the sum of all the angles of a triangle is equal to 180 degrees. The second one being the isosceles properties, which is the angles opposite to equal sides of a triangle are equal. And the third one being that the angle which is the greatest would always have the opposite side to be greatest as well. Okay. Moving on, we'll be looking at a few questions. Okay. It is basically saying angle P and Q and R are in the ratio of 3:5:10. So, what would be the series in which the sides would be proportional, or the sides? It's basically asking you, give me the series, give the descending order, give the descending order of the sides. Okay, because we've just just read the third property over there in the last question or in the last concept. Okay, so the greatest angle would house the longest side, then the smaller one, and then the smallest one. Okay, so here in the ratio 10:5:3, this is nothing but the angle ratio. This is nothing but the angle ratio. Now, if I wish to have the absolute values or the absolute degree values of angles, what I'll be doing is I would be considering that 10 plus 5 plus 3, which is equal to 18, this is equal to 180 degrees. Okay, 18 is equal to 180 degrees. If this means that 1 unit is equal to 10 degrees. 1 unit is equal to 10 degrees. So this is going to be 100, this is going to be 50, and this is going to be 30. 100, 50 and 30. Okay, 100, 50 and 30. So this is the standard form of it, and this has now given me the degrees of each and every angle. I could have solved it with the help of ratios as well, but I deliberately went on one step further, provided that, let's assume that a question comes up of a similar manner, so you're able to solve it better. Okay, so 100, 50 and 30. So the side which is opposite to angle 100, let's assume that side is angle A, and let's assume no, we have this option over here. Okay, I'll just create the angle for you. Okay, this is triangle PQR. Triangle P is said to be let me just see, angle P is corresponding to 3, so that means the value of angle P is equal to 30. Q corresponds to 5, so the value of angle Q is equal to 50, and the remaining angle, which is angle R, is this. So R being the greatest angle would have the symbol small r in front of it. Q would have the symbol small q opposite to it, and then small p would be the symbol opposite to angle P. Accordingly, over here, if I apply this rule, that 100 is greater than 50 is greater than 30. This would give me my final answer, which is also equal to PQ is greater than PR is greater than QR. Okay, PQ, PR, QR. And that was the solution to the example. Okay, I deliberately took the long path. I deliberately took you through a long method so that you learn. Okay, so that you learn each and every step that is involved in it. Moving on, concept number 2, equilateral triangle, and we need to find out the area, the perimeter, and the sides. Okay, the most basic concept behind equilateral triangles is that all three sides are equal. Okay, all three sides are equal. When I talk about the three sides being equal, this also gives me that all three angles are equal. Okay, this gives me the deduction that all three angles are equal. We need to find out the area and the perimeter. We'll be talking about the perimeter here straight away. The perimeter of any triangle is nothing but the sum of all the sides, sum of all sides. We have assumed that each and every side is denoted by small a, which is also equal to the length of the triangle, length of the sides of the triangle. So if each and every side is equal to small a, then the perimeter of the triangle would come out to be 3a. Okay, the perimeter of the triangle would come out to be 3a. Okay, I hope that is understood. Each interior angle of an equilateral triangle measures 60 degrees. I'll just prove it as quickly as possible. The perimeter is clear. The perimeter is clear to all of you. Now, in this particular triangle, I'm assuming this angle, like it's already written that this angle is angle A, angle B, and angle C. If angle A plus angle B plus angle C is equal to 180 degrees due to the angle sum property, and the second property which I use is that angles opposite to equal sides would be equal, then I would be able to come to the conclusion that angle A is equal to angle B is equal to angle C. Right? Angle A is equal to angle B is equal to angle C. Now, if I have come down to this conclusion that all these three angles are equal, then I can say that 3 times of angle A is equal to 180 degrees. 3 times of angle A is equal to 180 degrees. So the value of angle A is equal to 60 degrees, which is also equal to angle B, which is also equal to angle C. Okay, I hope you get it pretty well. Each and every angle would measure as 60 degrees, and I have proved it as well. Now, the perimeter, which I have already talked about on the last slide, we had assumed that each and every side was equal to small a. You can have any alphabet, you can have any variable taking the place of small a. The only main focus would be that it would be 3 times of the side that you assume. Okay, it would be equal to 3 times of the side that you assume, the length of the side that you assume. A is the length of one side, very clear. Okay, now there is a concept of finding out the area of a triangle. The area of the triangle is also called, is also like represented with the formula half into base into height. Let's assume we have an equilateral triangle over here. Okay, all the sides are 2a, not 1a, 2a. 2a has been taken for convenience, and I drop a perpendicular from the top to the bottom. This perpendicular would bisect the side into two equal parts. That would be equal to a and a. It being an equilateral triangle, each and every side would be equal to 2a. If the perpendicular has been dropped, then a and a are two portions of it. Okay. So if I wish to find out the height, the method would be 2a square, which is equal to like 2a whole square, that will be equal to 4a square is equal to height square plus a square. The value of h square would be equal to 3a square or root 3a. Now if I apply the same value back, half into base into height, half into the base being 2a and the height being, just a second, and the height being root 3a. This would give me my area of the triangle equal to, the 2 and the 2 get cancelled, root 3a square. Okay. There is one very common point which you might be feeling that I have done wrong. Here, a is the side of a triangle. In my concept, the side of the triangle was 2a. So if I put my value root 3 upon 4 multiplied by 2a multiplied by 2a, this is nothing but 2a square. So this 2 and this 2 would get cancelled, and my final answer would also come out to be root 3a square. So this is the same. Just for the convenience of not using anything in upon 2 or upon 4 form, I used this method. Okay. So this deduction or this output, you must remember that the area of any equilateral triangle is equal to root 3 by 4a square. There is also a formula called the Heron's formula. We will be using it somewhere in the future. This this output of root 3 by 4a square has come out using the Heron's formula. Heron's formula uses something called the semi-perimeter, which is equal to the sum of all the sides upon 2. As the name suggests, it is semi-perimeter. It means half of the perimeter. Further, the formula says that the final area, the area of the triangle, okay, area of the triangle would be equal to S multiplied by S minus A multiplied by S minus B multiplied by S minus C. Okay. Okay. So this is my outcome. A is the length of the side. We've already done it. And this was the Heron's formula, which I've explained to you over here. Okay. This is a very small derivation, which I've done on the right hand side. The derivation used that each and every side of the triangle would be A. Here I used that each and every side of the triangle would be 2A. So that is why we found a very small difference between the two areas. I could have directly come to the formula provided I had not used this convenience method of using the side 2A as my final side. Okay. If we need to find out the height of the equilateral triangle, we can equate both the kinds of formulas used for finding out the area of the triangle. So half into base, which is A, into height, which is h, this is equal to root 3 by 4 a square. This a gets cancelled with the square, the 2 gets cancelled with 4 and gives a 2. So the height of an equilateral triangle is nothing but root 3 by 2a. It's nothing but root 3 by 2a. So this is something which you must remember at all costs, that the height of an equilateral triangle is root 3 by 2a. Okay. Okay. I hope that is completely sorted. Now we have an equilateral triangle and the altitude of which has been given. We need to find out the length or the perimeter of the equilateral triangle. Okay. I'll just give you a quick 10-second break. and you can like try to find out the solution of it without looking at the solution. Okay. In the previous equation, or on the previous slide, we had learned that the height of an equilateral triangle is root 3 by 2a. The height has already been given as 6 root 3, and I need to find out the value of 3a. Why 3a? Because the perimeter of an equilateral triangle is nothing but 3 times the side. Okay, so 3a. I need to find out 3a. The value of 3a needs to be found out. If 6 root 3 is equal to root 3 by 2a, the root 3 would get cancelled with root 3. This 2 would go over there, and the value of a would come out to be 12. I need to find out the value of 3a, which would require me to multiply 3 on both sides, and it would give me the answer as 12 multiplied by 3, which is equal to 36. Okay, which is equal to 36. So this 36 over here is my final answer, which is equal to the perimeter of the equilateral triangle. Okay, this is the formula which was derived in the last equation. Here it is, here it is given. Okay, and this is the derivation of the formula which we've done. We've done nothing but equated the two areas, nothing else. Two ways of calculating the areas. Okay, 36 is fine. I hope it is clear to everybody. So moving on. In an isosceles triangle, the length of each equal sides is twice the length of the third side. The ratio of the areas of the isosceles triangle and an equilateral triangle with the same perimeter would be. Okay. This is a very, very interesting question. Okay. So first of all, there is an isosceles triangle. There is an isosceles triangle which is equal to this A, B, and C. Length of each equal side, let's assume that the left side is equal to the right side, or AB is equal to AC. The length of each equal side is twice the length of the third side. So if I assume that the third side BC, which is the unequal side, the value of it is x, then the value of AB and AC would be 2x and 2x. If I try to find out the area of the isosceles triangle with the help of the long method or with the help of the Heron's formula, I would get a certain answer. And similarly, if I assume that the perimeter of this triangle, which is an isosceles triangle, is equal to 5x, then I need to make a triangle. I need to make a triangle with the same perimeter being 5x. And now this perimeter 5x would be equal to 3 times all the sides of the equilateral triangle, because I've told you that the perimeters are same, and the perimeter of an equilateral triangle with side A is equal to 3a. So when 5x is equal to 3a, the value of a needs to be found out. That would be 5 by 3x. So this is one of the sides of an equilateral triangle. I need to check the area of the equilateral triangle. Root 3 by 4a square is the area of the equilateral triangle. So root 3 by 4 multiplied by 25 divided by 9 multiplied by x square. This is the area. This is the area of an equilateral triangle with sides a, which is equal to 5 by 3x. Got it? Got it? Pretty well? Pretty cool? 2x, 2x, x. We have three options of 2x, 2x, and x. If the perimeter is equal to 5x, I need to find out the area using Heron's formula. Okay. which says that semi-perimeter needs to be found out. If the perimeter is 5x, the semi-perimeter would be 5 by 2x. The formula for area is S into S multiplied by A into S minus B into S minus C. Okay. This entire would have a rooftop on it. The rooftop would be nothing but the root. Okay. So this is the Heron's formula which I would be applying. The three sides are 2x, 2x and x. So 5 by 2 would come as it is. 5 by 2 is nothing but 2.5. So 2.5 minus 2 is x by 2. Another x by 2 because it is 2x. Then 2.5 into 2.5x minus 1x would give me 1.5x, which is nothing but 3 by 2x. So I need to also have a under root over it. The power of x is 4 inside. When it comes outside the root, the power of x changes to x raised to the power 2. Further, the power of 2 is 4 inside. When it comes outside, it comes out as 4. The only root which remains inside is nothing but root 15. So, x square root 15 upon 4 is the area of the isosceles triangle. Further, root 3 by 4, 25 upon 9, x square is the area of the equilateral triangle. I'll just put them for comparison. X square into root 3 into root 5. I have deliberately split the root 3 and root 5 because I'm getting a chance to cut one of them off. Divided by root 3 by 4 multiplied by 25 upon 9. Okay, this gets cancelled. Root 3 gets cancelled. There is an x square also over here which gets cancelled. Okay, so it goes like 9 root 3 and 25 is the ratio which I was looking for. You will not find the answer directly. All the triangles or all the equilateral triangles have been given as given or have been computed in a manner that their area comes out to be 100. So I will have to multiply both sides with 4, which would give me 100 over here and 36 root 3 over here. Okay, 36 root 3 over here. So 36 root 3 or 36 root 5. Okay, I'm sorry. This is root 5, not root 3. This is 36 root 5 is 200. 36 root 5 is 200 is my final answer. Okay, this was a little long question, but when you do it more frequently, you'll get to understand that it is easy enough to solve. Okay, moving on. There is a concept of median or an altitude in an equilateral triangle. Assuming that ABC over here, is an equilateral triangle where all the three sides are equal. If I drop a perpendicular or a median from angle A, I would call it AD. Similarly, if I drop a perpendicular on AC, it would called BE. It will be called BE. Similarly, if I drop a perpendicular on AB from the vertex C, it is called CX. No matter if you drop a perpendicular or an altitude or a median or an angle bisector, it is all going to come out to be the same, which is the easiest form of a median. It will divide all the sides where it is falling into two equal parts. Okay, it would also split the angle into equal parts. Okay, would also split the angle into equal parts. So the median of an equilateral triangle is 15 root 3 centimeter. What is the side of this triangle? When the median meets here at the center, I'll use a different pen just to help you understand better. This is the point where it is meeting, and this is called a centroid. This is called a centroid. Okay. The median of an equilateral triangle is also called the altitude because it's an equilateral triangle. That is why it can very frequently be interchangeably used. Okay. Median is nothing but the altitude of the triangle. If I have and we've already found out an altitude of a triangle is also called the height. So we've already found out the formula for the equilateral triangle. Height is equal to root 3 by 2a. Okay. The value has been given as 15. Root 3 is equal to root 3 by 2a. Root 3 gets cancelled by root 3. This 2 when multiplied by 15 gives me a value of 30, and that is the value of a. 30 is equal to a. So my final answer is 30. Okay. I've told you a lot about equilateral triangle over here. So I hope you haven't gotten much confused. The same concept is going to repeat itself very, very frequently, and you'll be using it very often. Then coming down to the concept of inradius and circumradius. Here we are only talking about the lengths. Okay. Here we are only talking about the length. We are not talking about the angle or the kind of angle it subtends, be it at the center or at the corner. So beware of that. We'll just talk about the length of the sides. Okay, the length of the inradius or circumradius or the circumcenter, like inradius and circumradius. Now there is a point at the center of a triangle where all the medians meet. Okay, and the point where all the medians meet is basically called a centroid. Here at the centroid, there is a concept of inradius. Okay, there is a concept of inradius. Inradius is a point, or inradius is the length of is the length starting from the center of the triangle or the centroid of the triangle till the side of the triangle, such that a circle touching all sides of the triangle. A circle touching all the sides of a triangle. Further, there is a concept of circumradius. Okay. What happens in circumradius is there was a portion there was a portion of in radius there was a portion of in radius which was extended backwards to one of the vertices as well. Okay. If and this is also from the inside. Okay, this is also from the inside. Talking about the circumradius, what happens is when you draw a circle touching all the vertices of the triangle. Okay, when it is touching all the vertices of the triangle, that is when the point is called circumcenter, and the distance between the center of the circle to the circle, to the out circle, okay, or to the circumcircle, gives you circumradius. Okay, as we have multiple times seen that in an equilateral triangle ABC, we very frequently draw medians. Okay, we very frequently draw medians. My third median is always the worst median. Okay, AD, BE, CF. There is a particular ratio. There is a particular ratio which, when employed, excuse me, there is a particular ratio from the centroid which divides the altitude into two parts. And the ratio of those two parts is nothing but 2:1. And my case is also proved when the in center, this is the in center that we're talking about, the ratio of the in radius and the ratio of the out radius comes out to be 1:2. Okay. So the centroid divides the altitude in the ratio of 2:1. This one being the bigger side, let's assume this is A, this is O, this is B, this is C, and this is D. So AO would be bigger than OD. Also, AO would be equal to, like, the ratio between AO and OD would be equal to 2:1. Okay. AO is to OD would be equal to 2:1. If I wish to know, there was this formula which we used, the altitude of equilateral triangle. The altitude of equilateral triangle. The formula is pretty straight. √3/2a, which is the side of the triangle. Now, this √3/2a is consisting of three parts. Two parts of AO and one part of OD. So this entire scene is equal to 3 units. If I wish to find out the value of 1 unit, which is also equal to small r, or in radius, it would come out to be √3/2a divided by 1/3, because I need to find out the value of 1 unit. Okay, this √3 gets cancelled. It creates another √3 over here, which in turn gives me the value as a2/√3, which in turn gives me the value a2/√3, which is also the altitude of the equilateral triangle, or the in radius. Okay, in radius is a smaller part of the altitude. Similarly, I wish to find out the capital R. The value of 1 unit was equal to a/2√3. This capital R is nothing but twice of 2 times of small r, or a/2√3 multiplied by 2, which gives me my answer as a/√3. Okay, it gives me the answer as a/√3. I hope it's perfect. I hope it is understandable. I hope it is doable. Okay, I have deliberately repeated the slide in order for you to learn the importance of this question. Look here. This is the centroid of the triangle. We are still learning triangles. We haven't gone towards circles or anything. Okay, this is the centroid of the triangle. From the centroid, if I go towards one of the sides, or I hit a tangent towards one of the sides, at that point, if I touch all the sides of the triangle, I make a circle out of it, and this circle is called a incircle. And this circle, which is formed using all the vertices, is called an circumcircle. Okay, the medians being this long, the first one, and the second one being this long. I'll just put a dividing line in front of them so that you know that they are not connecting and they are different. This would give me capital R and this would give me small r. Okay. Small r is denoting the in circle, which is better or which is smaller. Further, capital R is denoting the out circle, which is greater or greater in size. Okay. So in radius is a by 2 root 3 and circumradius is nothing but a by root 3. Okay. I hope I am correctly and very clearly audible and visible, and the concept is also very clear. I'll give you 10 seconds with this slide and then we'll be moving on with our regular pace concepts. Check. Okay. Coming back and moving on. There is something called an orthocenter. Okay. Orthocenter. The meeting point, the meeting point of altitudes. The meeting point of altitudes is also called the orthocenter. Okay. Meeting point of all the heights of the triangle. As we are learning equilateral triangle, then orthocenter, orthoradius, in center, everything, everything can be like particularly the center. Okay, I'm not talking about the radius, but the center, orthocenter, circumcenter, in center, all lie at the same point, which is inside the circle, and it is equal to um inside the circle, and it is the point is also called a centroid. Okay, so this is a meeting point of all the components or all the exponents of equilateral triangle. All the medians, all the perpendicular bisectors, all the perpendiculars, okay, all of them meet there. There is an equation which helps to find out the distance between the circumcenter and the incenter in any triangle. Okay, the distance between the circumcenter and the incenter in any triangle. So here the formula is r square, which is the capital R square, minus 2 capital R small r. Circumcenter represents capital R and in center is represented by small r. You can anytime plug and play the values and find out the distance between the circumcenter and the incenter. In an equilateral triangle, I'll just go back. R square, which is capital R square, which is also equal to a square by 3 minus 2rr. Okay, 2rr means 2 multiplied by a root 3 multiplied by a root 3 multiplied by 1 by 2. Okay, this 3 becomes 3 at once. This 2 gets cancelled out. So a square by 3 minus a square by 3 would give me an answer of 0. That is why it could be deduced that the circumcenter and the incenter of an equilateral triangle, okay, of an equilateral triangle is nothing but the same. Okay, it's nothing but the same thing. There are like most of the terms in an equilateral triangle can be used interchangeably because of this property, because all the points or all the centers all lie at the same point. Okay, and this has already been established that a centroid divides the altitudes in the ratio of 2:1. Okay, we have already discussed this, so I'll be moving on. There is an example. The circumcenter of an equilateral triangle is at a distance of 3.2 centimeters from the base of the triangle. What is the length of each of its altitudes? What is the length of each of its altitudes? I have already discussed this, that the ratio between each of these altitudes would be 2:1. If the value of 1 is given as 3.2, then the length of entire altitude needs to be found out. So the value of 1 unit is 3.2, then the value of 3 units would be equal to 9.6 centimeters. So my final answer is 9.6 centimeters. You can always go back and try to learn the properties, but when you have very beautiful, very easily available visual cues in front of you, it gets much, much better. Okay, so need not worry, reread, rewrite, and relearn. Okay, moving on. A circle is inscribed in a right angled triangle. The length of two sides containing the right angles are 30 and 16. Find the radius of the circle. Okay, here we were only dealing with equilateral triangles. That is why the value of in radius was pretty clear and pretty cool and pretty easy, which was a by root 3. But in this question, we are not dealing with equilateral triangles anymore. We need to find out what is the radius using a different method. So, for any right angled triangle, the value of small r or the value of in radius, okay, in radius, or the value of in radius which is inscribed, okay, a circle which is inscribed, the value of in radius would be nothing but perpendicular plus base minus hypotenuse upon 2. Perpendicular plus base minus height a whole upon 2 is the hypotenuse. Okay, pretty much understood, pretty much sorted. Moving on. P plus B minus H upon 2. The formula is only valid for right angled triangle. This has also been given. Okay, this is the main point. If you don't have a right angle triangle, if you have an equilateral triangle, then we already have the formula over here, a upon 2 root 3, which is the in radius. Moving on to different questions, when we'll be moving towards different questions, you will see that there is a standard formula of r. The standard formula of r is equal to delta upon s. Delta being the area and s being the semi perimeter. S being the semi perimeter. Okay, area upon semi perimeter is also equal to r. I will try to find out r using that thing as well. Okay, using this formula as well. Firstly, I'll be applying this formula. The formula says that this is the perpendicular, or like this is the perpendicular, this is the base, this is the hypotenuse. 30 plus 16 minus 34 whole upon 2 would be equal to 12 upon 2 would be equal to 6. So 6 is the in radius. Okay, 6 is the in radius. Using half into, now I'll be applying it into this formula. Okay, the area of this triangle would be half into base into height. Half into 30 into 16 is equal to 30 multiplied by 8. This is the area of the triangle. Now talking about the semi perimeter. The perimeter of the entire triangle is 30 plus 34, which is 64. 64 plus 16 is equal to 80. 80 upon 2 is nothing but 40. 8 ones are 8 fives are 5 ones are 5 6 are. So through this formula as well, which I've just written over here, that the in radius is equal to the triangle's area divided by the semi perimeter. Divided by the semi perimeter, you would also land up at the same conclusion that the in radius is equal to 6 centimeters. Okay, the in radius is equal to 6 centimeters. I hope you find it correct. I hope you find it really well. So I'll be moving on. Take 10 seconds, read the question. It says PQR is an equilateral triangle. Okay, this is P, Q, and R, which is an equilateral triangle. Forget this extension over here. PQR. A is the centroid of the triangle. I need to know the length of PA. I need to know the length of PA. This is PA and this is the length. Now this is not the in center of the triangle. This is not the in center. Just let me check. What is it asking? The side of the triangle is 4. It's talking about PA. It is not talking about AD or something of that sort. Okay, it's talking about PA. So this solution which has been given over here is completely wrong. The solution which is supposed to be here is this. This PA is nothing but a part of the circumcircle, or PA is nothing but circumradius. PA is nothing but circumradius. What happens in the case of a circumradius? Just try to find out. In a circumradius, the formula comes out to be A by root 3. Okay, I'll just check the formula one more time. It is A by root 3. A being the side of the triangle, which is also equal to 12. So 12 upon root 3. There cannot be roots in the denominator. Hence, I would have to multiply and divide it by root 3. When I do that, it comes out to be root 3 multiplied by root 3, which is this. 3 is gone with 3. And this gives me a 3. 3 4 is a 12. My final answer is 4 root 3. Okay, my final answer is 4 root 3. My final answer is 4 root 3. Okay, this solution was bringing me to the correct answer, but it had done a major hiccup over here. It had written that 12 upon 2 root 3, if we convert it properly, 12 into root 3 upon 2 into root 3 multiplied by root 3. These two root 3's would become 3. 3 ones are, and like 3 ones are, 3 fours are, 2 ones are, 2 twos are. According to this, the output is supposed to be 2 root 3, and it has been deliberately written that the answer is 4 root 3. So this is a mismatch. The method which I used over here of employing simple formulas would be decent enough for you to do the question very quickly. Okay, moving on. The length of two sides forming the right angle triangle are 15 and 8 centimeter. What is the radius of the circle circumscribing it? Circumscribing it means that the circle is basically outside the triangle. Okay, the circle is basically outside the triangle. That is something which you must understand. Okay, so every time I'll just help you understand that what all concepts are hidden in this question. Here we have a right angle triangle. because the two sides were 15 and 8, and it has already said that it is a right angle triangle. Using this 15 and 8, I can find out the third side, which is nothing but 15 square plus 8 square, which is equal to 289. And if I root it down, it will give me 17 square. The square would be cancelled out and it would give me a 17 as the hypotenuse. In any particular question where you find a right angle sitting inside a circle, then you can very easily deduce that the longest side of the triangle is nothing but the diameter of the circle. Also, any angle subtended from the diameter of a circle would always be 90 degree. So this is nothing but a hand in glove principle. This is nothing but a hand in glove principle, that the diameter is subtending an angle on any side of the circle, and that is 90 degrees. Hence, this diameter, when turned to half, would also become the circumradius. Okay, would also become the circumradius. Here, the hypotenuse, which is 17, here the hypotenuse, which is 17, is acting as the diameter. Is acting as the diameter. If this 17 is divided by 2, instead of diameter, I would get the value of radius, which is also equal to circumradius, or 8.5 centimeters. 8.5 centimeters. Okay. So circumradius is half of the hypotenuse in a right angled triangle. Okay. So this is something which you must remember. We have discussed this very beautiful concept. The concept said that the circumcenter of any right angle triangle would lie on the hypotenuse. Also, the hypotenuse, when divided by 2, or when the hypotenuse is reduced to half, that is when we'll find out the circumradius. Okay, the circumradius. And there are multiple questions like, where does the centroid lie of an acute or an obtuse or any other sort of a triangle? We'll be getting those theories subsequently, but only orthocenter or a circumcenter is something which can lie outside the triangle. Okay, everything else can always and should always lie inside the triangle. Moving to the next question, it is based on, like, I'll read it out for you first. If the circumradius of a triangle is 10 and the inradius is 3, find the distance between the circumcenter and the incenter. Okay, the distance between the circumcenter and the incenter. Do not go for simple differences between, like, 10 minus 3 is equal to 7, because that won't work. Okay, the standard points that we're looking for is this formula. The distance between the circumcenter and the incenter is nothing but r square, capital R square, which is circumcenter square, minus 2 times circumradius multiplied by in radius. Okay, so it is r square. R square is nothing but 10 square, 100 square, minus 2 multiplied by 10 multiplied by 3. Okay, this is nothing but 100 minus 60 under the root, which is equal to root 40. And when I talk about root 40, this comes out to be 2 root 10. Okay, this comes out to be 2 root 10, which is my final answer. Okay, moving on. In an equilateral triangle, the circumradius has been given as 14. What is the length of the median of this triangle? I've already talked about an equilateral triangle. In an equilateral triangle or any sort of triangle, let's assume that A and D, AD is the median, and at this point we have the circumcenter or the centroid. Okay, both of them would be coinciding in an equilateral triangle, and the division by the centroid over the median would be 2:1. What has been given over here is the value of circumradius, which is longer than the in radius. Okay, so the value of 2 has been given as 14. The value of 3 has been asked. Okay, the value of 3 units. This is nothing but 2 units, and this is nothing but 1 unit. The whole value of AD, okay, the whole value of AD is my median. Okay, this is my median. This is my median, and it has been asked. If the value of 2 is 14, then the value of 3 would be 14 upon 2 multiplied by 3. 2 ones are 2 sevens are 14, and 7 threes are 21. Okay, 7 threes are 21, and that is pretty much my answer. Okay, 21 is my answer over here. Circumradius is clear, centroid is clear, circumcenter is clear. So this longer side was the circumradius. If I try to draw an equilateral triangle, this would be the figure. This is A, B, and C. This is the point. This is the centroid. This is the centroid, and this is the circle, which is going beyond. Okay, I hope it is pretty clear to you. Moving on, this is again an example. Okay, it is almost the similar example which we've already talked about. ABC is an equilateral triangle. Okay, if it's an equilateral triangle, then all the angles would be equal to 60 degrees and all the sides would be equal as well. With sides 18, D is a point on BC. This is not off BC, this is on BC, such that BD is equal to 1/3 of BC. If BD is equal to 1/3 of BC, the point which is left, or the line segment which is left, is DC. This total length is 18 centimeters according to the principle of equilateral triangle. Then the line which is left over here is nothing but 12. Then it is asking me to find out the length of AD. Okay, it is asking me to find out the length of AD. So what we'll do here is, whenever you have the length of two adjacent line segments of a triangle, or two adjacent sides of a triangle, and you have the value of the angle between them, you can always imply the cosine law. Okay, you can always apply the cosine law. What does the cosine law say? The cosine law says that adjacent side number 1, the square of it. Okay, adjacent side, I'll just rub it and write it a little more clearly, that it is much easier for you to understand. What does the cosine law say? The cosine law says that the value of the angle which is opposite to the unknown side can be found out with this law, such that adjacent side 1 square plus adjacent side 2 square minus opposite side square whole divided by 2 into adjacent 1 multiplied by adjacent 2 would be equal to the cos of the angle which is between the adjacent sides. Okay, cos of the angles which is between the adjacent sides. This needs to be remembered and learnt by you by heart. Okay, I'll try to tell you the formula again. Whenever you have a triangle where you know the two sides and you know the angle between the two sides, this is not a right angle triangle, so all your methods of Pythagoras theorem cannot be applied over here. This is a part this question is a part of an equilateral triangle. Still, you cannot deduce if it is like you cannot find out the third side without the use of sine law, without the use of cosine law. Okay, cosine law is meant to be used when you know only two sides and the angle between them, and the triangle is neither an equilateral triangle nor in nor an isosceles triangle, and neither a right angle triangle. Okay, okay. So the cosine law says that cos of the angle in the middle. Okay, I hope you can see this. Cos of the angle in the middle is equal to adjacent side 1 square plus adjacent sides 3 square, no, 2 square, adjacent side 1 square, adjacent side 2 square, minus opposite side square, whole divided by 2 multiplied by adjacent side 1 multiplied by adjacent side 2. Okay, that is my cosine law. I'll quickly apply the cosine law. The value of cos 60 is nothing but half. Adjacent side 1 square is 18, which is equal to 324. 18 square is 324. Plus 6 square is nothing but 36. Minus AD square, which is my point in question, the length in question which needs to be calculated, divided by 2 multiplied by 18 multiplied by 6. This 2 and this 2 are gone. 8 6 are 48 and 6 1 is 6, 108. Okay, 108 is equal to 24 plus 36. Okay, this gives me 360, and this is AD square. When 102, when 108 is subtracted from 360, it gives me a value of 52 over here, and then 252. 252's root is the value of AD, and hereby 6 root 7 would be the value of AD. Okay, this question over here is a previous year question. It has been asked maybe twice, not a very long, like not multiple times, but whenever such a question comes, people tend to forget that cosine law is always available to their rescue. Okay, people tend to forget that cosine law is available to their rescue when two sides of a triangle are available, when two sides of a triangle are available, and one angle which is common to both the adjacent sides is also available. Okay, the third side can be found out pretty easily using this formula. We have an equilateral triangle ABC. D is a point on BC such that the length of BD is equal to 1/3 of the length of entire BC. We need to prove that 9 AD square, which is the new dot, which was the new point on BC, is equal to 7 times AB square, which is one of the sides of the triangle ABC. So what's going on over here is, if you notice pretty well, we've learned everything mostly about the medians. Like AE is the median, that is why it is putting a 90-degree angle over here. It is also bisecting the side BC. Okay, it's also bisecting the side BC. It means the BC is being split into two equal halves. So BC is being split into three equal parts with the help of BD, and with the help of AE, with the help of AE, because it's a median, it is getting split into two equal parts. Okay, so from this place we would take a cue of what the length of BC should be, and it being an equilateral triangle, whatever length of BC we would assume, it would be transferred to all the other sides as well. Okay, the same length would be transferred to all the other sides of the triangle as well. So 1 by 3 and 1 by 2, the LCM is 1 by 6. So that tells me that I can assume my sides to be 6x, all my sides to be 6x. That is where I will find the easiest calculation possibilities. Okay, so the length of AB is 6x, the length of AC is also 6x, and the length of entire BC, this entire BC, I'll just clear it out for you. Okay, the length of entire BC is also 6x. Now what's going on over here is that this is 6x, okay? This is 6x. BD is 1/3 of 6x, which means that this is equal to 2x. DE, now EC is half of BC, which is equal to 3x. 3 plus 2, 5x, 1x is pending, so DE equals to 1. Okay, DE equals to 1. So this is how we started off. This is how we started off. Now what I'll be doing is I'll be using AD as one of the hypotenuses and AB as the second hypotenuse, and I'll be using the Pythagoras theorem using this angle 90. Okay, the angle on the right is 90, that is why the angle on the left is also 90. Using the angle AED as my 90-degree angle, I would be using two triangles, triangle AED and triangle AEB. So if I use triangle AED first, then AD square is equal to, let's assume that this value of AE is nothing but K. Okay, so AD square is equal to K square plus X square. Similarly, using the bigger triangle, I can say that AB square is equal to K square plus 9x square. Why did it become 9x square? The value of 2x plus x would make it 3x, and 3x whole square is equal to 9x square. Okay, from this equation, as we are pretty sure of what the value of AB is, we'll be substituting 6x in that place. So 6x means 36x square is equal to k square plus 9x square. Similarly, k square is equal to 27x square. Okay, so we have the value of AE available to us. I will be using this value in AB to find out the value of AD square. The value of AD square is equal to K square, which is 27x square, plus x square, which is already there. That means it becomes 28x square. Now, I have the value of AD square. The value of AD square, I'll rewrite it down over here. The value of AD square is equal to 28x square. The value of AB square, according to my question, is 6x square or 36x square. Okay, that is 36x square. Now I'll be using this 4 7s are 28, 4 9s are 36, and the x square would be cancelled out with x square. So AD square upon AB square is equal to 7 upon 9. I have reached my conclusion that 9 AD square is equal to 7 AB square. Okay, 9 AD square is equal to 7 AB square. I've reached this conclusion. Now I can use this conclusion in all of my other options. See, this has been a very peculiar and this has been a very important question. This has been asked multiple times in the exam. They just give you that BD is equal to 1/3 of BC, and then you have to use this output, this particular output, to your benefit. So what can be done is you can easily remember this, that AB square being one of the major sides of the triangle, it's always going to relate to 9. And see here AB square is going to relate to 9, and AD square being a part of, like, being a friend of the median, it would relate to 7. Okay, because the longest side in an equilateral triangle is one of the equal sides, so the median would always be shorter as compared to any of the sides. So AD square can hold the value of 7 and AB square can hold the value of 9. As simple as that. Okay, I'll be taking you to a question where this result was used. Here, triangle ABC is an equilateral triangle and D is a point on BC such that BD is to BC is 1/3. Okay, we are at the same juncture, the one which we saw in the last question. This is A, B, C. D is a point on BC such that this is 1 and the entire line is 3. Okay, BC is equal to 3. This is 1:3. If AD is equal to, AD is one of the points over here. This is AD. If the value of AD is equal to 5√7, then one of the sides of the triangle is, AB was one of the sides of the triangle. Using the last equation, going back to the last page, I will be using this output. Okay, this is the output which I have to mug up. Using this output, I will apply it over here. AD square upon AB square. AB being the largest side of the triangle would relate to 9, and AD being one of the friends of the median. This is not a median, this is just a friend of the median. Okay, it looks like a median, but it is not a median. because medians divide the opposite side into two equal parts. This is dividing it in 1 by 3 and 2 by 3. So they are definitely not equal. So this would relate to 7. Okay. The value of AD, we will be putting it from the question. 5 square is 25 and root 7 square is 7. This and AB square is something we are finding out. 7 upon 9. The 7 would get cancelled by 7. Now I have 25 multiplied by 9 is equal to AB square. So the value of AB would come out as 5 multiplied by 3, which is equal to 15. Okay. So I hope you've understood the importance of this output. This importance of this output would be applied here and the answer is 15. Okay. We've now come to concept number 6, which is the isosceles triangles, its area, its perimeter, its side of a right isosceles triangle. What happens in an isosceles triangle is this, that a triangle which has two sides which are equal. Okay. A triangle which has two of its sides are equal. Let's assume that AB and AC are equal. So when two sides of a triangle are equal and third is definitely the unequal side, okay, it doesn't have any relationship with the above two. So that time it is called a it is called an isosceles triangle. Okay, it's called an isosceles triangle. So AB is equal to AC but not equal to BC, which has been illustrated over here. Further, if we drop medians on equal sides of the triangle, here the equal sides of the triangle are AC and AB. So if I drop medians on equal sides of the triangle, see this median and the other median. So first of all, these medians are definitely going to become perpendiculars, or if we draw perpendiculars, they are going to become medians, because it is going to definitely divide it in two equal parts. Okay, so they would become 90 degree each. They would also be equal. That is the point I'm trying to make over here, that in an isosceles triangle, the medians which are dropped on equal sides are also equal. Medians dropped on equal sides of an isosceles triangle are also equal. Okay, as simple as that. Let's move on. Now we need to check the perimeter of an isosceles triangle. The definition has actually gone down. See, the definition is here, right isosceles triangle. This is a right isosceles triangle. In a right isosceles triangle, what is the most prominent thing is that this is a 90 degree angle, which is the right angle, and it being an isosceles triangle, the first side or the perpendicular is equal to the base. Okay, the perpendicular and the bases are the same thing. So the hypotenuse becomes a root 2, which is with the help of the Pythagoras theorem. So the perimeter of such a triangle would be a plus a plus a root 2, which would become 2a plus root 2a, or it would become root 2 multiplied by root 2a plus a, or root 2a is equal to, this is also not required, simply root 2a multiplied by root 2 plus 1. Okay, it is little, like, how should I say, it's not very necessary for you to remember all this, but the only thing important is that you must remember, in a right isosceles triangle, the base and the perpendicular are going to be equal. From there onwards, you can easily derive all the equations whichever are required. Further, the area of an isosceles triangle is half into base into height, the base being a and the height, the base being a and the height also being a. This would become a square. So a square upon 2 is the area of the isosceles right angled triangle. Okay, I've given you all the concepts. Now we'll be moving towards the question. So this is an example. It says that the perimeter of an isosceles right angle triangle is 16 root 2 plus 16 centimeter. Then what is the area of the right angle triangle of this isosceles right angle triangle? I'll quickly draw one over here. Every time you get a question in the exam, I'll request you to draw this very simple figure. It's pretty quick. In 10 seconds, you'll be through. Okay, A, and A root 2. You don't have to remember bulky formulas. If you know the figure, you won't have to remember the bulky formulas. The area of the triangle has been asked. So a square upon 2 is something which I need to find out. And currently what has been given is 2a plus a root 2, which is also equal to 16 plus 16 root 2. 16 plus 16 root 2. So from this, what we can gather is, let's assume that 16 has been taken common and root 2 plus 1 stays over here. Similarly, root 2a has been taken common and root 2 plus 1 stays here. So these two things are equal. This is the real value and this is the formula. This is the formula. So from this, I can gather that root 2a is equal to 16. Simple. Root 2a is equal to 16. So the value of a is equal to 16 upon root 2 or 8 root 2. Now if I have this, I can simply plug in my value over here. A square by 2. A square means 64 into 2 upon 2. The 2 gets cancelled and my final answer is 64, which has been mentioned here on the left hand side. I'll repeat the concept for you. The perimeter of an isosceles right angle triangle has been given and we need to find out the area. The perimeter should be derived at each and every point. Okay, need not go to the formula back and forth, back and forth. This is not something which is very prominent. That is why its derivation would hardly take you 10 or 15 seconds. Okay, it would take you 10 seconds to come to the conclusion that this is a root 2. Then the perimeter would be given by this formula. The area would be given by this formula. Once the perimeter is there, you match the formula and the real value. Then you get the value of a, you plug it in the area formula and you're through. Okay, so I'll be doing one more question. It says angle B is 90, angle C is 45. Once I know that angle C is 45, I can derive that angle A is also 45. This takes me to the conclusion that this is a right angle triangle which is isosceles in nature. So two of the sides are equal. Then the longest side or the hypotenuse has been given as 2 root 2. I'll quickly make my own right angle triangle which is isosceles in nature, A and root 2a. So from here, if 2 root 2 is equal to root 2a, the root 2 and root 2 gets cancelled, the value of a becomes 2. It's asking me the length of BC. BC is one of the sides, which is this one, and the value of the side is equal to a, and I've just found out the value equal to 2. So I can easily jump to my conclusion that this is root 2, that the answer is 2. Further, what this chap or this fellow has done, this is basically the data which we have over here. They've applied the concepts of trigonometry. Okay, they've applied the concepts of trigonometry to reach at this point. What do the concepts of trigonometry say? That as we have this formula, as we have this triangle which has 2 root 2 as its hypotenuse, and this being a and this being a, and this is 45 degrees. We will quickly use sine, okay, because we need the value of BC. Okay, we need the value of BC. So sine is opposite, that means BC upon hypotenuse 2 root 2, it is equal to sine 45 degrees. The ones who've read trigonometry, they know that sine 45 degrees is 1 upon root 2, which is also equal to BC upon 2 root 2. According to the question, root 2 gets cancelled with root 2 and the value of BC comes out to be 2. Okay, so this is another way. This is a little smart way without giving any due respect to geometry or trigonometry. This is the quick way. Okay, this entire thing is a quick way, and this is just a tad bit longer, but it is giving all due respect to geometry. Okay, this is giving all the respect to geometry. So I hope you are okay with both of them. Okay. Concept 7. Concept 7 particularly talks about isosceles triangle trying to merge itself with the concept of angles. So what happens in an isosceles triangle is that opposite to the equal sides, the angles are also equal. So if I say that AB is opposite to angle C and AC is opposite to angle B, given the fact that AC and AB are equal, the angle C would also be equal to, let's say this is alpha, this is also going to be alpha. Okay, So this is as simple as that, that angle B is equal to angle C, or angle alpha is going to be equal to angle alpha. Okay. It has very good real world applications. Multiple questions have been asked for this particular thought. Okay. ABC is an isosceles triangle such that AB is equal to AC. Angle ABC is equal to 55 degrees. Okay. We already have this angle ABC is equal to 55 degrees. AD is the median to the base BC. Find the measure of angle BAD. So what is happening over here is that AD is the median. Okay. So median is bisecting the base into two equal parts. Also, for an isosceles triangle, every time there is going to be a median, the angle is also going to be bisected. Okay. The angle is also going to be bisected. So if this is angle A, the other angle is also equal to angle A. Further, we need to find out the value of angle BAD. Okay, angle BAD. So I'll just find out the value of angle small a, and we'll get the value out of it. So 55 degrees. If this is 55, this line is equal to this line. AB is equal to AC. So this angle is also going to turn out to be 55 degrees. Now, using the angle sum property, I can say that 2 times of angle small a plus 55 degrees plus 55 degrees is going to be 180 degrees. It's going to be 180 degrees. This together makes up 110, and when 110 is removed from here, it becomes 70. The value of 70 is equal to 2a, and the value of a is 35 degrees. Okay, the value of a is 35 degrees. So that is also going to be the measure of angle BAD, which is 35 degrees, and I am done with the question. Okay, moving on. Triangle ABC is an equilateral triangle. The side BC is produced to DC. Okay, I'll just quickly make an isosceles, or sorry, an equilateral triangle. This is triangle A, B, and C. BC is produced to D. Okay, BC has been extended. It has been produced to meet point D. If A joins D, if A joins D, BC is equal to CD. BC is equal to, sorry, BC is equal to CD, this side. Okay, I am a little wrong over here. BC is equal to CD. The degree measure of angle CAD is equal to what? Okay, I need to find out this angle. I need to find out this angle. Okay, starting with the basics. In triangle ABC, all the sides are equal, and also in an equilateral triangle, all the angles are going to measure 60 degree each. Okay, all the angles are going to measure 60 degree each. After this being said and done, this particular angle is equal to 120 degrees. How did I find it out? Particularly with angle C. Angle C forms a linear pair, one of 60 degrees and one of angle X. When I talk about angle X, the angle X is nothing but angle ACD. Okay, this angle X, both of them are on a straight line. Once they are on a straight line, they would form a linear pair and form 180 degree as their sum. So 60 plus X is equal to 180 degrees. So the value of angle X is equal to 120 degrees, which I have already mentioned over here. I'll just change the color. Okay, so this particular angle is 120 degrees. This is my first finding. I need to find out what this angle is. Let's assume this angle to be angle Y. Now coming down to focusing on only triangle, I'll only focus on triangle ACD. Okay, I'll only focus on triangle ACD. In this triangle, side AC is equal to side CD. How did I land to that conclusion? Side BC was already given equal to CD. In triangle ABC, AB is equal to BC is equal to AC. So I can remove the BC from here and put any of the three sides I want. I can put any of the three sides I want. So I would write AC is equal to CD. Okay. So if the three sides are equal, one side on the outside is equal to one side on the inside. So all the sides from the inside are equal to one side on the outside. I'll repeat. One side from the outside is equal to one side of the inside. everybody who's inside is equal to everybody who's inside. So that is why anybody who's inside would be equal to the one who is outside. Okay? Okay? This is the outsider. This particular line CD is the outsider and it is friends with one of the insiders. So if all the insiders are equal, then it is friends with other insiders as well. So according to this, equal sides are opposite to equal angles. So angle Y, which we have to find out, is also equal to angle Y, which is given here. So forming a triangle, in triangle ACD, what we have is 2 times of angle Y plus 120 degrees is equal to 180 degrees. So this would go there. So 2 times of Y is equal to 60 degrees. So the value of Y is 30 degrees, which was my question all the way long. Okay. So the value of angle Y is equal to 30 degrees. Cool enough? See, we are lucky to have this option with us, that the median which falls on the opposite side or on the unequal side of an isosceles triangle bisects it. It gives a 90-degree angle over here and also bisects the angle. Okay, so it makes the median very universal in nature. When I say universal in nature, I mean that you can do almost anything with the help of the median. You can find out the area, you can find out the length of the other side, you can find out the length of the equal side. So everything is possible. So this is a very unique feature of the median in isosceles triangle, that it serves as a perpendicular bisector, it serves as an angle bisector, it serves as a median which splits the other side into two equal parts. So it's a very unique thing. So what we have over here as a property is, whenever you have to find out the side of the length of the median, what you can do is you can employ this formula. The formula says that under root 4a square minus b square whole upon 2 would give you the length of the median, which is AD. Okay, we've done nothing. We've just employed basic Pythagoras theorem. The basic Pythagoras theorem saying that this is A and this is nothing but B by 2. When we use Pythagoras theorem, this is how we would get the size. This is how we will get the length of the median. Okay, so without wasting much time, we'll directly hit the question. It says that the unequal side of an isosceles triangle is 2 centimeters long. The median drawn to the equal sides are perpendicular. Then what is the area of the triangle? So first of all, if A and B are the equal sides and BC is the unequal side, we have to consider one very sharp thing over here. The X that is being made over here, I'm redrawing the X over here. This is B, this is C. The X that is being made over here with the help of the medians is hitting each other at 90 degrees. Okay, this median which is hitting, it is hitting it at 90 degrees. This is very, very important. So what I'll be doing is I'll be plucking out the triangle BOC from it. If I look at triangle BOC, the shape of the triangle is such. And from the figure, from the question, it says that this is a 90 degree. It is asking me the area of the entire triangle. Using BOC only, I have done this in the past and I've done it with you as well. When the medians are getting connected at the centroid, okay, when the medians are getting connected at the centroid, then they are splitting the entire triangle into 3 equal parts. The bottom triangle, right, the bottom triangle, the left triangle, and the right triangle. Okay, the median, the bottom, the left triangle, the right triangle, and the bottom triangle. So this is one of the 3 triangles that we have. And luckily, we have one side of the triangle available to us. And furthermore, luckily, we have this triangle to be a right angle triangle. And one more luck is that BO is equal to OC. Why? The medians which are drawn to the equal sides of the triangles are equal in nature. So this line BO is equal to OC just because it is an isosceles triangle. Just because it's an isosceles triangle, the medians are also equal. So this is equal to this, assuming this to be A, assuming the other one also to be A. So we have A square plus A square is equal to 2. Okay. When a square plus a square is equal to 2, so 2a square is equal to 2, and the value of a is nothing but 1. Okay, the value of a is nothing but 1. Let me check it one more time. No, this is not 2. Okay, this is 4. A square plus a square, this is equal to 4, and the value of a square is nothing but root 2. Okay, the value of a is nothing but 2. I'll be reiterating whatever I wrote over here. I used the Pythagoras theorem for this particular triangle. I'll be changing the color of the pen as well. I have used Pythagoras theorem for this particular triangle over here, this one. Okay, so a square plus a square is equal to 4, and 2a square is equal to 4, so the value of a comes out to be root 2. Now as we have the value of a to be root 2, I can find out the area of this triangle. I'll be employing the simple formula of half into base into height, the base being a and the height also being a. This is half into root 2 into root 2. This entire thing gets cancelled out because 2 times root 2, like root 2 square is 2. So the area of the triangle is equal to 1. Now, as this portion of the triangle that I'm talking about, this entire portion of the triangle is equal to 1/3 full area. This is equal to 1/3 of the full area of the triangle. That is why this is 1/3. Now, if I multiply it by 3, this would become the full area of the triangle, which is equal to 3. Okay, 3 units. So the area of the triangle ABC is nothing but 3 centimeter square. Okay, I hope you've understood what I've taught over here. We found out the area of the smaller triangle using the hypotenuse. We found out the other two sides. The other two sides were medians and they were equal because this is an isosceles triangle. We found out the sides of the median, which gave us the area of the triangle using half into base into height. And once we had the area of one triangle, this was equal to the area of 1/3 of the entire figure. So I multiplied it by 3 and I got my final answer as 3 centimeters square. Okay, I hope you've gotten it. Moving ahead, there is an isosceles triangle ABC with BC being the unequal side of the triangle. AD is the median line drawn from the vertex A to the side BC. If the length of AC is 5 and the length of the median is 4, then what is the length of BC? Okay, I'll draw the triangle one more time. This is the triangle that we have. This is ABC. Please leave a comment for, drop a good appreciative comment for my beautiful drawing skills. This is D. This is the unequal side BC. The median is drawn. The length of the median is 4. The length of one of the sides, the length of the equal sides is 5. No, AC is 5. Okay, this AC that is given is 5. AD is equal to 4. The median that is dropping, from one of the vertices where the common sides originate from, like where the equal sides originates from. So these two are the basically AB and AC are equal sides. So that is going to drop. That is not only going to be a median, that is also going to be a perpendicular. Okay, that is also going to be a perpendicular. So when this is a perpendicular that we have, we can use Pythagoras theorem very easily on half the triangle. If I use Pythagoras theorem on the half the triangle, the value of AC square, the biggest side, would be equal to AD square plus DC square, and DC is nothing but a part of BC. DC is nothing but a part of BC, the entire length. So AC square is equal to AD square plus DC square. The value of AC square is 25 because the value of AC is 5. The value of AD square is equal to 16 because the value of AD is equal to 3 is equal to 4. Similarly, DC square is something that we need to find out. When this goes here, this leaves 9. The value of DC square or the value of DC is equal to 3. As we've gotten the value of DC equal to 3, there would be an answer which is equal to 3. And most of the people would commit a silly mistake by answering it as 3. So 3 is not going to be the answer. It has to be doubled. You'll ask me, why does it have to be doubled? Because we haven't reached the final answer yet. The final answer says that the entire length of BC has been asked. If BC was bisected using AD, if, I'll just change the pen color, if BC was bisected using the help of AD, it was split into two equal parts, BD and DC. If DC is equal to 3, then BD would also be 3. My final answer is nothing but 3 plus 3, which is equal to 6. And I'll tick point B as the correct one. I hope you understand how well we've used the Pythagoras theorem to our advantage in order to receive this, in order to receive the output, which is side BC, which is equal to 6. All right. See, what we have here right now in front of us is concept number 9. In concept number 9, we'll be focusing a lot on the perimeter of the isosceles triangle. As you already know that in an isosceles triangle, two of the sides are equal and one of the side is unequal. Okay, unequal means it's a random side. Two of the sides are definitely going to be the same. So I'm sorry. So the perimeter of the triangle, perimeter of a particular of an isosceles triangle would be 2a plus b. Moving on, we need to find out the area of the isosceles triangle. Area of any triangle is half into base into height, which has a 90-degree in it. Or any right angle triangle will have the area half into base into height. Our base, what we have over here, is constant, which is equal to b. So in the same formula, it's going to be half into b. The height is going to be variable, reason being that this is a median. The median of any isosceles triangle would automatically become the perpendicular or the altitude or also the height. So in one of the previous slides, I'll just show you, we found out the length of the median as this, 4a square minus b square in roots upon 2. Okay, so I'll be plugging in the same value over here and putting it as 4a square minus b square upon 2. So b by 4 multiplied by root of 4a square minus b square, and we have this formula with us. Okay, you can remember this as the standard formula. You won't have to deal with a Pythagoras theorem, which might be one step ahead, which might take one more step to solve. So it's better that you remember this formula, that when you have one of the medians and one of the equal sides, then you can easily find out the area of the triangle. Okay, often of particularly for an isosceles triangle, nothing less than that. Okay, so I'll be moving on to the next slide. It says that the perimeter of an isosceles triangle is 91 centimeters and its base is 1 by 4 times each of the other equal sides. Then what is the length of the base? As we have this triangle over here, the perimeter is 2a plus b, which is equal to 91. There is a relationship that has been established between the base and the other equal sides. The base is 5 by 4 times of a. From this particular equation, I need to find out the value of the base. So I will find out the value of a from this equation, which is equal to 4 by 5 times of base. I will replace a by 4 by 5. 2 multiplied by 4 by 5 times of b plus b is equal to 91. This makes 8 by 5 times of b plus, 8 by 5 times of b is equal to 91. There is a plus b as well. When this is solved, this makes 13b upon 5 is equal to 91. 13 ones are, 13 sevens are. So the value of b comes out to be 35. Okay, the value of b comes out to be 35. This is my final output. So what we've done over here is we've used the standard formula of the perimeter of the triangle, perimeter of an isosceles triangle, which is 2a plus b, b being the unequal side and a being the equal side. That is why there is a quotient, there is a coefficient of 2 along with a. Okay, similarly, then this was given in the question, 1 by 4 times. I made this into a regular fraction. Than it being a mixed fraction, I changed it to a regular fraction by 4 plus 1 upon 5. 4 plus 1 upon 4, which is equal to 5 by 4, and I used it over here. Then I brought out the value of a from this equation, which is equal to a is equal to 4 by 5. Then I plugged in this value in the same first equation, which we were using over here. This is the plugging in area. After solving it all, I got the value of b is equal to 35, which is my final answer. Moving on, the perimeter of an isosceles triangle is 91 centimeters. If one of the equal sides measures 28 centimeters, what is the value of the non-equal side? If one of the equal side is 28, then the second equal side is also going to be 28. One of the non-equal sides, let's assume it is to be x. The sum of all these three is supposed to be the perimeter of the triangle. The perimeter of the triangle has been given as 91 by default. So 28 plus 28 is equal to 56 plus x. 56 plus x is equal to 91. So x is equal to nothing but 56 removed from this. When you remove 56 from this, you'll get 5 and 3. So the value of x is 35. So the value of the non-equal side would come out to be 35. Okay, so this is how we used the formula, the perimeter of a triangle. We also learned the formula of area of an isosceles triangle when you don't have all the sides, but you have the equal sides and the median. Okay, so I hope all of this is clear to you. So we've moved to the concepts of right angled triangles now. Okay, what happens in right angled triangles is that one of the angles, one of the three angles is a 90 degree. If one of the three angles is 90 degree, the sum of all the angles is 180. So any one of the other two angles can never be 90 degree. Okay, there can only be one and only one angle which is 90 degree, not more than that. Okay, so keep this in mind, 90 degree can only be one. So if it's a right angle triangle, the simple formulas of half into a into c, what we have over here is a into c. This would give me the area of the right angle triangle. Here b, this is called the hypotenuse. Okay, this is called the hypotenuse. A can be called the base when it is sitting on a. When it is standing on a, then it can be called the perpendicular. Okay, so do not get confused between the base and the perpendicular. Anything can be the base and the perpendicular, provided the orientation that comes out of it. Okay, provided the orientation that comes out of it. So this is pretty much about it. Moving on, there is a very standard theorem which establishes the relationship between these three. Okay, there is a standard theorem which establishes the relationship between all the three sides of a right angle triangle, and that theorem is called the Pythagoras theorem. Okay, so the Pythagoras theorem says that the hypotenuse square is equal to the perpendicular square plus base square. Okay, I know most of you must know, might be knowing about it, but there's no there's no there's no negative point in not knowing about it. You may relearn it. Okay, then whatever can become one of the side or the three of the sides of the triangle is called nothing but Pythagorean triplets. Okay, they are called Pythagorean triplets. Okay, Pythagorean triplets, because they occur in a very standard form and they occur together only. So if you find any of these as to be the sides of the triangle, then you can easily judge that these are the sides of a right angle triangle. Okay, you can remember that, you can definitely learn it. 3 4 5 9 12 15 6 8 and 10. I'll tell you the ones which are very very important and which are the ones which you usually find in the examination. Just a second. Okay, um I'll just highlight the ones. See, 3 4 5 is the standard point. This is nothing but a multiplication of 3 into the first triplet, and this is nothing but a multiplication of 2 in the first triplet. So 3 4 5 is one of the standard triplets, you can remember it. This 5 12 13 is one of the second standard triplets. 7 24 and 25 is another. This one is pretty no, this one is again a multiplication of 3 into it. Then 8 15 17, yep, this is unique. Talking about 9 14 40 40 and 41, this is another unique. There's another unique one which I would like to tell you. This, when there is 24 26, then there is a 10 involved over here. Okay, so these are easy to find out because 1 square plus 1 square is 2, so root 2 is the third side, and 1 square plus root 3 square is equal to 4, so root of 4 is 2. So this is easy. So if you can recall or remember these 5 or 6 triplets, then life becomes a little easier. Okay, you don't have to rush to finding out, like you don't have to calculate it more and more. You can just simply recall, okay, 3 4 5, okay, definitely a 90 degree triangle. So moving to this point, Then once multiple triplets were formed, once multiple triplets, I've told you only 6. Let's assume that there are 100 triplets. Then a standard equation was resolved. A standard equation was resolved in which if you put your own numbers, then you'll get triplets automatically. So I'll use the first equation to find out a triplet. This is n square plus 1 being the hypotenuse. N square minus 1 can be the base or the perpendicular, no problem. And 2n can be the other option. If I put the value of n is equal to 0, this is not going to amount to any triplet. If I put the value of n is equal to 1, again, no triplet is going to come out from there. Okay. But if I put the value of n is equal to 2, then according to this particular equation, we will get a triplet which is equal to 3, 4, and 5. Okay. So you can remember this equation as 2n, n square minus 1 and n square plus 1. If you'll put in random values of n, you might find a triplet out of it. Okay, you might find a triplet out of it. So if I put the value of n is equal to 4, n is equal to 4. So the triplet which I would be finding out would be 2n, which means 8, n square minus 1 means 16 minus 1, which is 15, n square plus 1 means 16 plus 1, which is 17. See, I again found a new triplet. So this is nothing but the source of triplets. The source equation of triplets. Okay, it's not extremely necessary for you to remember it, but in questions where you find it pretty difficult to answer, this would definitely come for your rescue. This would definitely come to your rescue if you can remember this source of the equation triplet. Okay, moving to the questions directly. The question says that in a triangle ABC, angle C is 90 degree, as we can see here. Further, Q is the midpoint of BC. Q is the midpoint of BC. AB is equal to 10. The hypotenuse is 10. And AC is equal to 2 root 10. AC is equal to 2 root 10. I need to find out the length of AQ. I need to find out the length of AQ. So we'll be employing the Pythagoras theorem twice. Okay. So we have the bigger triangle. I'll be using it in the biggest triangle to find out the length of BC. BC square plus AC square is equal to AB square. If I talk about the big triangle, okay, the big triangle being triangle ABC, okay, ABC or triangle ACB, whatever you may call it. I need to find out the value of BC square from it. So BC square would be equal to AC square, which is nothing but 4 into 10. This is 40. Yeah, 4 into 10 would be 40. And AB square is 10. So 10 square would be equal to 100. So 10 square would be equal to 100. So the value of BC square is equal to nothing but 60. Okay. I would hold on to BC square, or I shall convert it to BC. If I root it out, it's 15 4 is 60. So 2 root 15 is the value of BC which I'm looking for. In this particular triangle, Q has become the midpoint of BC. So it will split BC into two equal parts. If the entire length of BC is 2 root 15, then the length of QC would be 2 root 15 upon 2, which is equal to root 15, which is equal to root 15. So I've gotten the new side as root 15. Now it becomes very easy for me to find out the value of AQ. I'll be employing the Pythagoras theorem one more time. AQ square is equal to QC square plus AC square. Okay, I'm talking about AQ square. Now AQ square being one of the party in question, I'll let it be here. QC square being root 15. Root 15 square becomes 15 plus AC square. This becomes 2 to the 4. Like 2 square is 4. 4 into 10 is 40. So the value of AQ square is equal to 55. And the value of AQ in turn is root 55. Okay. The value of AQ is root 55. I hope everybody has understood what we're talking about. We'll be moving on. In a right angle triangle, if the longest side is 26 and one of the other sides is 24, then find the length of the third side. Okay, so this is my right angle triangle. Okay, let's assume this is A, B, and C, and 26 being the longest side, it has been written that this is the longest side. The longest side is also the hypotenuse. Okay, so this is 26. The base has been given as 24, and this side is x, which we need to find out. So what we'll be doing is we'll be employing the Pythagoras theorem. The Pythagoras theorem says that 26 square plus 20 is equal to 24 square plus x square. Okay, if you're a little weak at calculations, you can still use the algebra and like algebra to find out your answer. So the value of x square is equal to 26 square minus 24 square. I'm assuming that you're weak at calculations and you don't remember the value of 26 square or that of 24 square. I will be helping you find out the quick ways of solving a square as well, but we'll be employing algebra over here. In algebra, an identity says that when a square minus b square is given, then it can be split up in the multiplication of a plus b and a minus b. Okay, so this route would be quicker for us, so we'll be solving it in that way. 26 plus 24 multiplied by 26 minus 24. Okay, 26 plus 24 is nothing but 50, and 26 minus 24 is 2. So this comes out to be 100, which is value of x square. So value of x comes out to be 10, which is the correct answer. Okay, another way of solving it is by memorizing the value of 26 square. The value of 26 square is 676, and the value of 24 square is 576. So the difference between 576 and 6 the difference between 676 and 576 is 100, which could have easily gotten us the value of x square. Okay, so this is another way of solving it. The value of x comes out to be 10, which is my final answer. We have the perimeter of the right angle triangle in front of us. It says that sum of all the sides of the triangle, which is equal to a plus b plus c, which is the perimeter of the triangle. Okay, now the area of the triangle, which I've already mentioned multiple times, is nothing but half into base into height, and this point is basically reiterated and stressed on here. So we'll be moving to the questions directly. The question says that the area of the triangle is 96 centimeters square. Okay, I'll just form a right angle triangle very quickly. This is A, this is B, this is C. Okay, and the length of one of its sides is 24. Okay, find the length of the perpendicular drawn to this side of the triangle from the opposite vertex. Okay, so firstly I am assuming that one of the sides is the perpendicular or the base. Okay, so as to reduce my efforts, but I would also consider one of the other sides to be 24, and the perpendicular which is being dropped over here is 90 degrees. Okay, 90 degrees. And also I will assume a third category of problem, that we don't know if it is a right angle triangle or what sort of a triangle, and it's just a normal triangle. Okay, just a random triangle. We don't know isosceles, we don't know right angular, we don't know what other properties it has. And one of the sides is 24, and from the opposite side we have a perpendicular being dropped from the opposite vertex. In the first scenario, if it was the perpendicular, then from the opposite vertex would be C, and automatically the line which is being dropped, or the side which is being dropped on it in a perpendicular fashion, is the base of it. So half multiplied by 24 multiplied by the side BC, which is what we want, that is equal to 96 centimeters square. That solves my purpose. So 24 ones are 24 fours are, and the value of BC comes out to be 8. Simple as that. In the second scenario, I am assuming that 24 was the longest side of the triangle. Okay, and we want to draw a perpendicular from this point from the opposite vertex to the side in question. So we need to find out the length of this perpendicular. Okay, let's assume that this is bx. So half into 24 into bx is equal to 96. We will get the value of bx to be same as 8, as the same question talks about it. And further, if I assume this side BC to be 24 and I employ the same formula, half into 24 into AK, I'm assuming this point to be AK. So AK, this is equal to 96. I get the value of AK to be 8 again. So no matter what sort of a triangle it is, it wasn't mentioned what sort of a triangle it is. So no matter, irrespective of what sort of a triangle it is, whenever you need to find out the length of a perpendicular which is drawn from the opposite vertex, you always have to use the same formula of half multiplied by base into height, and the height which is dropping on it is nothing but a line segment, is nothing but a perpendicular line segment which is being dropped on it from the opposite side, from the opposite vertex. Okay, I hope that is clear. When I talk about the opposite vertex for A and B, I'll just point it out. When I talk about the opposite vertex for A and B, it comes out to be C. When I talk about the opposite vertex for A and C, opposite vertex for A and C, it comes out to be B. And when I talk about the opposite vertex for B and C, it comes out to be A. Okay, the names are different of the vertices, but the concept is the same because the output that we have over here is the same. Okay, moving to the next question. In an isosceles right angled triangle, the perimeter is 30 meters. I need to find out its area, and that too in the nearest integral value. Okay, so I'll quickly draw a right isosceles right angle triangle. It means a plus root 2a. Okay, a plus root 2a. The perimeter which I have over here with me is root 2a taken common, um, root 2 plus 1. Okay, this is the perimeter. I learned it, I remember it. So it's nothing but 2a plus root 2a. Taking root 2a common from the entire equation, what I would be left with is root 2 plus 1. Okay, I would be left with root 2 plus 1, and the perimeter is nothing but 30. What is the area of such a triangle? The area of this right angled isosceles triangle would be equal to half into base into height. The base and the height are the same, so half into a square, or more simply putting it, it's going to be a square upon 2. I would find the value of a from this equation and then move it there. Okay, the value of a from this equation would be 30 divided by root 2 multiplied by root 2 plus 1. Okay, root 2 divided by root 2 plus 1. Now I'll be squaring it off. Squaring a, which is equal to 900 divided by 2 divided by root 2 plus 1. I will leave this to be in the whole square, and I would again put another half over here which is coming from here. Okay, this is the entire value of a square, and this is the half which is coming from the formula. Now solving it off, this is 2 ones are, this is 2 450s are. Okay, the value, this is a square, not 9 square. Okay, this is a square, this is a square. What I am left over here with is, I'll use this as well. This is 225. Okay, so 225 divided by root 2 plus 1. The value of root 2 is equal to 1.414, and the value of 1 is 1. So this gives me the value of 2.4 with me. I need to give a square of 2.4. Just in the last few questions, I gave you the square value of 24, which is over here, which is 576. Okay, I will use it very judiciously and put it as 576. There was one decimal over here, there would be two decimals over here because it has been squared. Okay, because it has been squared. So now I am coming down to an equation which is going to be very useful to me. 5.76, I am assuming it to be 6. and 22.5 or 225 stays where it is supposed to stay. 6 ones are 6, 6 threes are 18, and 6 sevens are 42, and another 3, 37.5. Okay, 37.5 is my guessed answer. What why am I calling it my guessed answer? Because I did not consider 5.76 to be the final answer. I considered it to be 6 in a way. So if I have increased my denominator, then the value of the numerator would have shrunk. If I wish to reverse that, I will have to increase the value of my answer. Okay, if I wish to reverse the effect, I will have to increase the value of my answer. So I would land up just moving a little bit forward, just moving a little further, and that is 39. Okay, so the value which is next to 37.5 is 39, which is my final answer, and it is my bet that this is going to be the answer. I hope you've understood it. So that was this. Moving towards concept 12a, it talks about the right angle triangle. It's in center and it's in circle. So what happens in an in center is that in a right angle triangle, a circle is drawn touching all the sides at right angles. Okay, touching all the sides at right angles. When a circle is drawn on the inside, it is called an in circle. Okay, this is called an in circle. And when it has a radius as well, which would be called in radius, and it has a center as well, which would be called the in center. Okay, so all the terms which start with an in have been described over here. There is a circle which is drawn inside a triangle, and it happens to be a right angle triangle, and it has an in radius with it. Okay, it has an in radius with it, and it has an in center. That is why it becomes an in circle. So an in circle is a right angle triangle. The in circle of a right angle triangle is the center that lies within the triangle and is tangent to all the three sides. Specifically, in a right angle triangle, the in circle touches the hypotenuse and the other two sides. The center of the in circle is called the in center. It is the point of concurrency of all the angle bisectors of the triangle. Similarly, the radius of the in circle is called the in radius, which is the distance from the center to any of the sides of the triangle. Okay, distance from the center to any of the sides of the triangle. There is a very standard formula which is followed in calculating the in radius of a circle. The in radius of an in circle is nothing but area divided by semi perimeter. If the perimeter of a triangle is a plus b plus c, then the semi perimeter of the triangle would be a plus b plus c upon 2. Okay, the area can be calculated in the standard way of half into base into height. Okay, so once you have that, it's easy to find out the in radius. So this is all about in radius that we have to talk about. Also, this is the standard formula for all kinds of triangles. All triangles would be solved using the in radius of area upon semi perimeter, but specific to right angle triangles. Okay, specific to rats or right angle triangles, the formula changes. The formula changes in the sense that the right angle triangles in radius would be equal to perpendicular plus base minus the hypotenuse divided by 2. Okay, perpendicular plus base minus the height whole divided by 2 would make it the size or the side of the in radius to be p plus b minus h upon 2. Okay, I hope this is very very clear to you that the in radius of a right angle triangle would be p plus b minus h upon 2. Okay, just remember this. This is very very important. Remember both these formulas. Okay, moving on. In a right angle triangle ABC, the lengths of the sides containing the right angle are 5 and 12. A circle is inscribed inside the triangle ABC. What is the radius of the circle in centimeters? Okay, this is side A, this is side B, and this is side C, which is the hypotenuse. Okay, A, B, and C. These two sides contain the right angle, and this by virtue of using the Pythagoras theorem. Using the Pythagoras theorem, this is a 5 square plus 12 square, which is equal to 25 plus 144. When added up, it makes 169, and when rooted, this makes 13. Okay, so this side is nothing but 13. A circle is inscribed in the triangle ABC. Okay, there is a circle which is inscribed in the side ABC. There is a circle which has been inscribed over here. So in this particular circle, we have the center. Now it is asking me for the radius of that circle. It's asking me for the radius of that circle. So I have already found it out. For right angled triangles, the incenter or small r would stand for perpendicular plus base minus the hypotenuse divided by 12. We have the perpendicular as 5, the base as 12, and hypotenuse as minus 13 whole upon, this is not 12, this is whole upon 2. Whole upon 2. Okay, this is 17 minus 13, which is equal to 4 upon 2 is this, and the answer is, the final answer is 2. Okay, this is the final answer. The radius of the circle is 2. Okay, radius of the in circle basically is 2. Moving on, the circumcenter of a triangle is that circle which passes through all the vertices of the triangle. If we go back, we can see over here, this is passing through all the sides and not actually passing through. If I zoom it in, I'll just try to zoom it in. Just see, just look at here. It's just touching it once. At one single point, it is touching. Okay, it is touching it at one single point. So over here, it is not touching it at a single point, but touching the vertices. Okay, A, B, C are the vertices of the triangle. So when it is touching the vertices of the triangle, all the vertices together, that is when we call it the circumcircle. Okay, circumscribing, okay, the outside, the circumcircle of the triangle. It is a circle that passes through all the three vertices of a triangle. For a right angle triangle, the circumcircle will have its center at the midpoint of the hypotenuse. Okay, this is a very, very important finding. The circumcircle will have its center at the midpoint of the hypotenuse. And if this is the midpoint of the hypotenuse, then I can easily say that the value of hypotenuse divided by 2 would be my circumradius. Okay, as simple as that, it will become my circumradius. The circumcenter of a triangle is the point where all the perpendicular bisectors of the sides of the triangle intersect. Okay, perpendicular bisectors of the sides of a triangle intersect. In case of the right angle triangle, the circumcenter coincides with the midpoint of the hypotenuse, which I have already given you an output of. Okay, this has not been taught yet. It might be coming on the next or the next slide of that. Okay, I've already told you that hypotenuse upon 2 would be the circumradius. Now, there is a formula to it. There is definitely a formula to it. There is a formula for general triangles, and then there is a formula for rats. Okay, for right angle triangles. For general triangles, the formula for capital R, it is denoted by capital R. Okay, it's circumradius is denoted by capital R. Capital R is given as product of all the three sides, A into B into C, divided by 4 times of the area of the triangle. Okay, this is nothing but delta. Okay, delta is nothing but a symbol, a Greek symbol. Okay, a Greek symbol which is also called the area of the triangle. Okay, so its final answer is ABC upon 4 into area. Delta and area are the same thing. So that is used for general triangles. Okay, for general triangles or all the triangles. It can also be used for right angle triangles. Okay, for right angle triangles, the answer is nothing but hypotenuse upon 2. Okay, the h over here is hypotenuse. Okay, hypotenuse divided by hypotenuse, hypotenuse. Okay, the spelling might be a little wrong. Hypotenuse divided by 2. As simple as that. Okay, we'll be employing it in a few questions. There's another output over here. Okay, the in radius and the circumradius of a right angle triangle is 3 and 12 centimeter respectively. Now we need to find out the area of the triangle. There is a very standard formula which says that r square plus 2r. This is the area of the triangle. Okay, this is the area of the triangle. R square plus 2rr is the area of the triangle. Here, over here, r square plus 2rr, the value of small r is given as 3 and the value of capital R is given as 12.5. So r square is 9, okay, or r square is 3 square plus 2 multiplied by capital R, which is 12.5, multiplied by small r, which is equal to 3. Okay, 9 plus this is 25 plus 3, 75. So 75, 25 multiplied by 3 is 75. 9 plus 75 is 84 centimeter square. My answer would be in centimeter square because I'm talking about an area. So the value of the area when a right angle triangle has its in radius and circumradius given is this. Okay, just stamp it on somewhere, just write this formula down somewhere. This is going to be the most important and the most legit formula which you would need, because when you like try to solve it, no, you would get stuck. You would definitely get stuck because you will be stuck in the formula of small r being equal to the area of the triangle divided by the semi perimeter. The semi perimeter you don't have. Then you will go to the bigger formula that says a into b into c upon 4 multiplied by the triangle's area. Then you will put in this value over here. You would leave it and say this value is r into s. Then you will get forever stuck because you have 3 variables whose values you don't know. You'll have 3 variables whose values you don't know, and you will only have one equation to solve it. So you would not be able to solve the equation at all. So this formula needs to be brought into the rote learning part. Okay, just remember it. Trust me, these formulas, these methods save you lots of time. If you'll get 1 minute, or let's say 60 seconds, which is equal to 1 minute, you'll get 60 seconds to solve a question. You will be able to solve this question in 20 seconds just because you remember this formula. Okay, so remember this formula and save yourself. Just save yourself. Moving to the next question, ABC is a right angle triangle, BAC is equal to this and ACB is equal to this. What is the ratio of the circumradius of the triangle to the side AB? Okay, there are a few assumptions which I would have to take. Not exactly a few assumptions, but this would be important. This is triangle BAC. Okay, I'm assuming that ABC is this triangle, and 90 degree is housed in angle A. Okay, BAC. BAC and angle ACB. Angle ACB, this is equal to 60 degrees. Okay. Now I need to talk about the circumradius of the triangle to the side of triangle AB. Okay. Here I would be employing trigonometry. Okay. What does trigonometry say? Tan 60 degree leaves the ratio of root 3 upon 1. Okay. Which is equal to root 3. So if tan 60 is here, this side would be called root 3. And this side is called root 3 only and only because it is AB upon AC. If the value of AB can correspond to root 3, then the value of AC can correspond to 1. Okay, this root 3 upon 1 does not make any difference to the value of tan 60. It remains root 3 only. But just for the sake of convenience, we have AB upon AC here, and we will assume that the value of AC is equal to 1, which is not going to disturb the angle 60 degrees value of root 3. Okay, the output of angle 60 degree is not going to be disturbed. Now assuming that this is root 3 and this is 1, assuming that this is root 3 and this is 1, we will be figuring out the length of BC. Okay, so we'll be using Pythagoras theorem over here. the length of BC is root 3 square plus 1 square, which is equal to BC square. So root 3 squared is equal to 3 plus 1 square is equal to 1 and BC square. The value of BC comes out to be 4 root, which is equal to 2. Okay, so the value of BC has come out to be 2. Now we need to find out the circumradius. We need to find out the circumradius. I'll take you one slide back so as to tell you where I'm coming from. Here we decided and here we discussed that the circumradius, okay, this circumradius, this capital R, this capital R, or this capital R is equal to hypotenuse upon 2. This is the output. Okay, I've put multiple stars over here. This is the output. So similarly in our question, if we draw this, which is equal to capital R, okay, this capital R would have the value of BC upon 2, hypotenuse upon 2. In terms of ratio, the value of BC is 2, and when 2 is divided by 2, I get the value of capital R to be 1. I get the value of capital R to be 1. Here you'll be wondering what units are we using. So there are no units, these are all ratios. Okay, so it's 2 units, 1 units, 1 unit, and this is root 3 units. Okay, root 3 units. So these are units, these are not in terms of centimeters. There was no point in going towards centimeters when we have the very strong weapon of trigonometry on our side. We need not go towards centimeters or decimeters or millimeters or meters. Okay, it can all be done in the form of ratios. Secondly, the question has been asked in terms of ratios. So the value of R comes out to be 1. Going back to the value of AB, okay, it has been asking the circumradius to AB. The circumradius is capital R, which is equal to 1. So it's asking 1 to, it's asking R to AB. Okay, it's asking R ratio AB. R ratio AB. It comes out to be 1 is to AB. AB is root 3 units. So my final answer comes out to be 1 is to root 3. Okay, the final answer comes out to be 1 is to root 3. Moving ahead. Now the points of intersections of all the medians of a triangle is called a centroid. Okay, there is one point where all the medians of the triangle are going to intersect, which is going to be G. Okay, this is called G, and this is the median. What does a median do? A median bisects all the sides of the triangle. Okay, it bisects the side of the triangle where it is falling on. So the median which is falling from A and falling to D is bisecting BC. Similarly, AB is bisected by this median CF, and BE is is basically bisecting the side AC. Okay, all the sides are getting bisected and all the sides are getting split up. If line segment AD, okay, this has been, we've talked about this also. Let's assume that this is the centroid G, okay, and this is coming from the vertex A, this is coming from vertex A, and this is falling on the point, the line segment is falling on point D. Okay, this is the line segment and this is the vertex A. The median, when they cut each other in the ratio of 2 is to 1. They cut each other at the point of G, which is the centroid. So we can easily assume that centroid divides the median in two parts, which are in the ratio 2 is to 1. Okay, centroid divides the median in two parts, which is 2 is to 1. Okay, also one last important point is this, that centroid of all kinds of triangles are always going to stay inside the triangle. Okay, they are always going to stay inside the triangle. Moving on, there is a theorem There's a theorem which is called the Apollonius theorem. Okay, the Apollonius theorem, where AD is the median. Whenever you find this sort of a triangle where AD is the median, then you can make it out that AB square plus AC square. It means this side of the this side of the triangle and this side of the triangle is equal to twice this side, twice the median, and half of the entire length of BC. Okay, where it is falling, that is BC. AD plus CD. Okay, AD plus CD. Now this Apollonius theorem can be asked in terms of, let's assume that CD would be missing from the entire equation, and they can ask you the question of to find out the value of CD. So there you'll have to apply Apollonius theorems. In a right angle triangle, in a right angle triangle, when you'll have this sort of an equation where ABC is the right angle triangle and A is throwing its um, A is throwing its midpoint. And just a second. A is throwing its vertex, one of the line segments, on P, so as to divide it into equal parts. Similarly, C would be throwing its own vertex, its own midpoint on point M. Then AP square, which is the median, okay, and CM square, which is median 2. This is median 1. This is median 2. That would be equal to the hypotenuse square. Okay, this is h square, this is h, and h square would be employed here, and MP. Okay, the point where the two medians are falling, when they are joined, that would create MP. Okay, this is also a part of the Apollonius theorem. So trust me, this is something which you have to remember, because in the exam you'll just get one question on it. If luck is on your side, you won't get a question on it. If luck is not on your side, you will get one question on it. And somebody who remembers the theorem, somebody who can recall what we're talking about over here, is the one who's going to get through for sure. Okay, moving on. The question says G is the centroid of a triangle ABC, where AB, BC, and AC are 7, 24, and 25 respectively. Then what is the length of BG? Okay, it's talking about the length of BG. I'll quickly draw a right angle triangle. Okay, this is the right angle triangle, A, B, and C. This being 7, this being 24, and this being 25. G is the point in the center, somewhere in the center, and BG, okay, this just went past it. Okay, G is lying somewhere here. G is lying somewhere here. Okay, this is the median which I'm dropping. Let's assume this is BX. Okay, BX is the median which I dropped. Now it's going to ask me what is the length of BG. From this particular equation, can I find out the value of can I find out the value of capital R? Can I find out the value of circumradius? The answer is yes. This is a right angle triangle. How am I so sure that this is a right angle triangle? Because 7 square plus 24 square is equal to 25 square. Okay, when I told you, I'll just move the slide back. Okay, so do not just get confused what happened when I was talking about these. Yep, I was talking about these. See, we have it over here with us. This is one of the triplets. So I told you you need to remember them really well. You need to remember the triplets really well. So when I was talking about this, I very sincerely talked that you need to remember all three. So this is one of the triplets. So this is definitely a right angle triangle. In a right angle triangle, the circumradius can be calculated as hypotenuse divided by 2. The length of the hypotenuse according to the question is 25, and upon 2, that would give me 12.5, or I would let it remain 25 by 2. Now this being said and done, the value of bx has been calculated, which is 25 upon 2. The value of bx has been calculated, which is 25 upon 2. Now, I've told you about it. bg is to gx. bg is to gx is divided in the ratio 2 is to 1. Because I'll be again moving the slide back. Whenever there is a centroid, the centroid divides the ratio of the median in the size 2 is to 1. Okay? Centroid divides the ratio of the median in the size 2 is to 1. This is something very clear, very sure. 2 is to 1 is here, bg is to gx, bg is to gx, 2 is to 1, 2 is to 1, and we are through. Using this, I need to find out the value of bg. Now, bg would be 2 by 3 times of bx, okay? 2 by 3 times of the entire length, because if this is divided in 2 is to 1, I need to find out the value of 2. So out of a total of 3, the value of 2 needs to come out. So what is the value of bx? The value of bx is 25 upon 2 multiplied by 2 by 3. So these two get cancelled, and the value of 25 upon 3 is something that I'm looking for. So 25 upon 3 is equal to 8 1 by 3, which is my final answer. The value of bg is 8 1 by 3. The value of bg is 8 1 by 3. That is something very, very important. Okay, we used two concepts. The first one being that of the circumradius. The circumradius of a right angle triangle is h upon 2. And the second one being that the centroid divides the median in the ratio 2 is to 1. Okay, I hope I have made myself very clear. So in this particular question, we'll first check if this is a right angle triangle or not. The length of 3 sides have been given, and I need to find out the length of the median, which is joining the longest side and its opposite vertex. So the first thing we'll be checking out from here is if it is a right angle triangle or not. We have 3 sides available with us, which are 48, 55 and 73. See, if we follow the regular approach, this calls for 48 square plus 55 square should be equal to 73 square. This kind of a situation is a little tough. Why? Because most of you don't know what 48 square is, and most of you also don't know what 55 square is. 55 is still doable because it must be 3025, yeah, but you don't know what 73 square is. But if I tell you that you may have 55 square on the left hand side and then 73 square minus 48 square, then this situation is very much controllable. Why am I saying that? Because I can apply a square minus b square identity and call it a plus b multiplied by a minus b. I can call it a plus b multiplied by a minus b. So how do I go about it? I say that 75 plus 48 should be multiplied by 73 minus 48. When I do 73 minus 48, I get a 25. And when I do a 73 plus 48, I get a 121. Both of them need to be multiplied, and then a square root needs to be taken. Once that is done, I can see it is 11 into 5, which is equal to 55. So this is satisfying my equation. This is a shorter route to find out if a triangle is a right angle triangle or not. Once we know that this is a right angle triangle, what we'll have to do is we'll quickly just draw it here. I'll say this is 48, I'll say this is 55, and I would also say that this is 73. Now the median joining the midpoint of the longest side to its opposite vertex. This is the opposite vertex, and this is the median that we are talking about. We know this very well. If a median is dropped from the 90-degree side to the longest side, which is the hypotenuse, it basically divides the hypotenuse into two equal parts. That is the standard property of a median. But this also equals to the half of the full length of the median. That means 73 upon 2, or half of the entire hypotenuse, which is 73 over 2, which is going to be 36.5. So 36.5 is my answer. Right? Moving forward, there is a median based theorem. The theorems is is such that uh, a median AD is a median in a triangle ABC. This is a triangle ABC, and AD is a median. AD is a median dividing BC into two equal parts. Then AB square plus AC square is going to be equal to 2 times of AD square plus BC square over 4. Okay, BC square over 4. So this is the kind of formula which you must remember. Okay, this is the formula which you must remember, and we'll be employing the same formula in the above upcoming 2-3 questions. In a triangle ABC, if AB, let me quickly draw it. If A, B, and C, if AB is 6, AC is 8, BC is 9, and I need to find out the length of the median AD, so I'll be employing the same formula. AB square plus AC, no, AB square plus AC square, yeah. AB square plus AC square is equal to 2 times AD square plus BC square by 4. So 2 times AD square. AD square is something which I need to find out. BC square is 9. 9 is, this is 81. 81 by 4 is something I have here. Let me write 4 properly. AB square is 6 and 36 plus AC square is 64. This is 100. 100 upon 2. This is 50. 50 is equal to AD square plus 81 over 4. This goes to the other side. This becomes 200 minus 81. 200 minus 81 becomes 119. So 119 over 4. I believe I am correct here. 200 minus 81. Yes, this is going to be 119. So AD square is equal to 119 over 4, or I can also say that AD is equal to root 119 whole upon 2. The root is only on 119, not on 2. Okay, so this is how I did it. Doing the same thing here. PQR is right angled at Q. This is not a beautiful triangle. I should only make beautiful and pretty triangles. Yeah. So this is P, Q, and R. It is said that PQ is equal to X minus Y, QR is equal to X, and PR is equal to X plus Y. S is on QR. S is on QR such that QS is equal to PQ. QS is equal to PQ. So this is nothing but X minus Y here, and this portion must be Y, because X minus Y plus Y, the X would get cancelled and would give this whole thing a meaning. What is the ratio of QS is to SR? QS is to SR. Okay, a pretty tricky question. Let me see. So yes, we were trying to figure out what could be done here. Let me remark the points with a different color. This is P, this is Q, this is R, this is S. Okay, P, Q, R, and S. Then we have a 90-degree angle over here. This is X minus Y, this is X minus Y, because it's mentioned in the question that S is on QR such that QS is equal to PQ. This is QS and this is PQ. So both of them are supposedly equal. What is the ratio between QS is to SR? When I say QS upon SR, talking in a manner of all the variables that have been given to us, QS can be called X minus Y in terms of length, and SR can be called Y. This Y was not given to us, and how did it actually come up? I'll tell you a very simple story here. It was given if on a line it's said that this entire portion, the entire length of the line is x, and this small portion of the line is x minus y. So there is supposed to be something which clears out the y from here and gives the entire length the value of x. That is why I can say if this remaining length is equal to y, then x minus y, which is the first portion, plus the second portion would give me an x. That is why this y is legit. Okay, this y is legitimately here. So SR, the value, the length of SR is equal to y. So x minus y upon y. This is the ratio which should have been the answer. But it has been given in numerical terms. That means we have to find out a relationship between x and y such that in the end, x can be given in some sort of ratio of y, and I can replace the x with some value of y. So once that happens, I would get my answer. Okay. So QS upon SR has already been given here. I'll quickly try to establish a relationship between x and y. How would that happen? I would use a right angle triangle, which is triangle PQ and R. Okay. What does a triangle PQR say? It says that x minus y whole square plus x square is equal to x plus y whole square. Let me solve it out. X square plus y square minus 2xy plus x square is equal to x square plus y square plus 2xy. This entire situation of x plus x square plus y square gets cancelled off. This minus 2xy goes to the other side, becomes plus 2xy, and I get x square is equal to 4xy. So this 2 and this x goes away. So I get the ratio of x being equal to 4y. I can employ the same ratio here and replace x with 4y. So I can say 4y minus y whole upon y. This means 3y upon y, and the y gets cancelled, and I am back with the ratio of 3:1. Okay. At the first sight, you would see this question as a little tough, but trust me, I also found it tough. But as soon as I employed the Pythagoras theorem and found out a relationship between x and y, then I was clear that this ratio of x of QR is to SR cannot be contained. This ratio cannot be contained only in the terms of x and y. It has to come out as some numerical ratio. That's why we got 3:1. All right, let's move forward. So these are a few theorems, some multiple upcoming theorems. What happens here is there is a double right angle available in a single triangle. Okay, hear me out again. There is a double right angle triangle, or there is a double right angle in one single triangle. How is that happening? There is a standard right angle triangle ABC with angle B having 90 degrees. So this is the first right angle. Then there is a perpendicular being dropped from the 90-degree vertex to the longest side of the triangle. Okay, this is being dropped to the longest side of the triangle. So once this situation is in place, then we get a few outcomes. The first few, or the upcoming few outcomes, are a square is equal to x square into c. Similarly, with a lot of similarity, b square is equal to y into c. T square, which is the length of the perpendicular, is equal to x into y. AB is equal to p into c. Okay. Also, 1 by p square is equal to 1 upon a square plus 1 upon b square. Okay. These are the 5 outcomes which you must know. You can draw the same triangle on your own. Draw the same triangle on your own and see how easily and how smoothly you would see all the outcomes that we are talking about. This is the entire length of C. Okay, a square is equal to x into C, b square is equal to y into C, p square is equal to x into y, then AB is equal to xy, and the last one being, no, AB is not equal to xy, AB is equal to PC. Yeah, AB is equal to PC, and what more? 1 upon P square is equal to 1 upon A square plus 1 upon B square. Okay, happy enough? Let's move forward. Okay, there is a double right angle situation here. Again, there is this triangle. Let's call it ABC. D is a point on AC such that BD is perpendicular to AC. If the length of BD is 6 and the length of AD is 3, then what is the length of entire AC? I'll employ the formula of P square being equal to X into Y. Okay, P square being equal to X into Y. P over here is 6, which is 36. X over here is 3. And Y over here is DC. So from here, I can say that the value of Y is 12. And I need to find out the value of AC. And the value of AC is going to be 3 plus Y, which is also equal to 3 plus 12, which is finally equal to 15 centimeters. Okay, it's equal to 15 centimeters. Good enough. Let's move on. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This is nothing but AC square is equal to AB square plus BC square. Okay, there are a few theorems to prove it, but I don't think they are relevant for the exam. Okay, simple ABC. This is a right angle triangle. You know this very well already. Moving forward, it is said that PS is perpendicular to QR. This is again a double theorem or a double perpendicular theorem. No, it's not ABC, it's PQR. It's PQR. P, Q, and R. Okay, I think angle R has been given as 47 degrees. Good. This is 47, this is 90, and PS is perpendicular to QR. PS is perpendicular to QR. That's already there, no? Find the value of angle QPS. There is a double, no, it says that angle P, this is angle P, this is angle Q. Let's call this angle R. PS is perpendicular to QR. This is a double perpendicular situation. PS is perpendicular to QR. Find the value of Q, P, and S. Okay, so this is 47 degrees. If this is 47, the other one is going to be 43. Q, P, and S. If this is 90 degree already because of a double 90-degree triangle, so this would come out to be QPS. This is the question being asked. So 90 plus 43 is equal to 133. This thing has to be subtracted out of 180, which would give me another 47 degrees again. So 47 degrees is going to be my answer. Why did I subtract it out of 180? Because in this smaller triangle, I'll use a different pen. In this smaller triangle, the sum of all interior angles is going to be 180 degree, or the simple angle sum property of a triangle is 180 degree, all of them. Okay, from this 47 we stepped up and reached 43, and because of this 43, again in this triangle we were able to find out this angle, which was a question mark, and it is equal to 47. Okay, let's move forward. Now, talking about a few special angles and another few set of properties. So when two medians from acute angled of which are part of some acute angle and they are perpendicular to each other, at that time we get AB square, which is this side, and AC square, which is the other side. we are going to leave out the side which is which doesn't have a perpendicular on it, or which doesn't have a median dropping on it. Okay, so it's going to be 5a square being equal to b square plus c square, right? 5a square being equal to b square plus c square. This is the first property which you must remember. Also, P and M are points on AB and BC. If they are just points and they are connected, then we get a useful identity from this. The first one is AP square plus CM square. It shouldn't be MC. AP square plus CM square. It's easier to remember it that way. Is equal to AC square plus MP square. MP is the line which is drawn once these two distinct points are connected to each other. Okay, this is MP, right? Right. Now these are supposedly medians which are getting caught up, which are getting intersected, at 90 degrees, at 90 degrees. For special points construction, AP plus MC, AC square, MC square. Okay, all okay, sorted. Let's move forward. In a right angle triangle, the length of the medians from the vertices of acute angles are 7 centimeter and 4 root 6 centimeters. What is the length of the hypotenuse of a triangle? Okay, so I'll quickly draw one. In a right angle triangle, the length of the medians from the vertices of acute angles. What is the length of the hypotenuse of the triangle? See, this one is getting cut here, and this one is getting cut here. Length of the medians are 7 and 4 root 6. 7 and 4 root 6. Yeah, 7 and 4 root 6. We'll employ the same formula. There's this concept which says that if this is triangle ABC and it is a right angle triangle, and let's say AX and CY, these are the medians, and AC is the hypotenuse, then AX square plus CY square, this whole thing, when it is done 4 times, this is equal to 5 times AC square. Okay, this is something which you must remember. Okay, this is something which you must remember. So 4 times AX square plus CY square. AX square is 7, which is nothing but 49, plus CY square, which is 4 root 6, which is 16, 6 are 96. This added up 4 times, this is equal to 5 AC square. This is going to become 5, and 145 upon 5 into 4. This is equal to AC. This is 5 2s are 10, and 5 9s are 45. So 4 into 29, if 4 into 30 is 120, 120 minus 4, 120 minus 4 is gonna be 116. So the value of AC is 116 centimeters, right? No, isn't. It's basically 29 root, or root 2 root 29. 2 root 29. Okay, 2 root 29, because the value which I was trying to find out was that of AC square. Okay, so AC square is nothing but 2 root 29 in this case, right? Moving forward. Now, points P and Q are on the sides of AB and BC of the triangle ABC. Is it a right angle triangle? Yes, it is. A, B, and C. I first draw the triangle and then check if it is a right angle triangle or not. Okay. So here AB and BC right angle at B, if AQ is equal to 11 and CQ, find the length of PQ. Just a second. This is AQ, this is 11. It's talking about CP. It's talking about CP. CP being equal to 8, and then AC. This is A, then this is P. And then AC being equal to 13. Then find out the length of PQ. Then find out the length of PQ. We've just done this where we say that the squares of the lines, which are falling on the other side, let's call them medians for now. Are they medians or not? No, they aren't medians. Okay, these are special point construction theorems where the special points starting from the vertices, when they are squared and added up, then they are equal to the hypotenuse square plus the points, plus the line joining those special points. So here the identity goes like this, that AQ square plus PC square, AQ square plus PC square is going to be equal to 13 square, or let's say AC square here first, AC square plus PQ square. Okay, this is the theorem that we are coming up with. So AQ square here is 11 square, which is 121, plus PC square is 8, which is equal to 64. This is going to be equal to AC square, which is 169 because it's square of 13, plus PQ square, or PQ is something which we need to find out. When I add all of this up, I get 185 minus 169. This is going to be 6. This is going to be 6, and this is going to be 1. 16 is equal to PQ square, so the value of PQ comes out as 4 centimeters. Right? 4 centimeters. So we've been dealing with such questions, and one of them is this, that BD and CE are the medians of triangle ABC, which is right angled at A. And if CE is equal to 5 root 32, this is not 5 root 32, this is 5 root 13. Okay, this is 5 root 13. So this is the one which I have here. This is A, B, and C. So it's talking about BD and it's talking about CE. And if CE is equal to 5 root 13 by 2, or 5 by 2 root 13, yeah, 5 by 2 root 13, 5 by 2 root 13, and we talk about BC, this is CE, and we talk about BC, the value of BC is equal to 10, then find the value of BD. We know one relation from the past videos or the past few slides, that BD square plus CE square, the 4 times of this thing, is equal to 5 times of BC square. Okay, we've learned this property. We'll apply the same property over here. CE is, this is CE. CE is 5 by 2 root 13. So 5 by 2 means 25 by 4, 25 by 4, 25 into 13 by 4 plus BD square. In the whole, there's a 4 outside, and there's 5 BC square. BC is 100. I'm sorry, BC is 10. So 5 into 100 is 500. The 4 goes here. This becomes 125. Against 125, I have 125 minus 25 into 13 by 4, and I have BD square. So the value of BD square here is 500 minus 325. That will give me 175 whole upon 4. 175 whole upon 4. 175 is nothing but 7 into 25 by 4. This entire thing has to go into root to find out the value of BD. from outside, like from the inside of the root, 5 by 2 shall go outside the root and a root 7 shall come here. So the value of BD comes out to be 5 by 2 root 7. Understood? Okay, let's move forward. When two sides and the angle between them are known, we use sine rule and cosine rules. Okay, so firstly, there are two standard rules. The first one is the sine rule and the second one is the cosine rule. You just need to understand what the formulas are talking about and how we'll use them. We'll talk about them in the upcoming slide. So there is A by sine A, B by sine B, C by sine C. The sine of the angle in front of the line we are talking about, or in front of the side we are talking about. Okay, so A upon sine A is equal to B upon sine B is equal to C upon sine C. This entire thing is equal to 2R. Okay, this entire thing is equal to 2R. Got it? Got it? So now talking about the cosine rule. Cosine rule talks about, let's assume that we need to find out the cos of A. At that time, we won't be touching the side A that quickly. We'll be touching the adjacent sides first. We'll talk about B square plus C square minus A square whole upon 2BC whole upon 2BC. The side which is opposite to angle A would be talked about the least. It would be talked about the least. Got it? Holy crap. We were recording. Okay. There is a small sequence where things went wrong. Okay. It's okay. So I have cos A. Similarly, all the other things will follow up. Also, if you have two sides and the angle between them, then you can find out the area of the triangle. You can find out the area of the triangle by using half into the sides, which is like the sides which we have, like the B and C side, and the angle A must be between them. So this is going to be sine of A. Okay, so this is how we'll be going about things, right? Moving forward, we'll now use it. The sides of the triangle are in the ratio 1 by 3, 1 by 5 and 1 by 4. So in such a situation, we need to have a straight ratio which all comes in the numerator only. So I'll take in the LCM of 3, 5 and 4. The LCM of 3, 5 and 4 is 60 or 30. 60, yeah. 60 against 60, I would get a ratio of 20 and 12 and 15. Okay, so this is the ratio in which the sides are. Now talking about the perimeter is 141. The perimeter is 141. So if the ratio is this and we have an absolute value, which is the perimeter, which is 141. So 20 plus 12 is 32, 37, 47. So I have 47x being equal to 141. That means the value of x is going to be 3 units. Once I have it, I know that the final side values are 60, 36 and 45. These are all in centimeters now. It was in ratio terms before, but it is in centimeter terms now. What is the difference between the greatest and the smallest side? This is the greatest side, this is the smallest side, and the difference which I can see over here is that of 24. So 24 centimeters is my answer, right? Let's move forward. Okay, a triangle has the following sides. If the area of the square exceeds the area of this triangle by 21 square units, then the side of the square is what? Hmm. So first, let me see if it is a right angle triangle or not. I can say that by doing 25 square plus 34 square is equal to 39 square. Now let me check if it is valid or not. I'll take the 34. I'll take 34 to the other side. 39 square minus 34 square. I have a 5 square. Like I have a 5 because 39 minus 34 is 5, and this would be multiplied by 39 plus 34, which is nothing but 73. So when I multiply 5 and 73, I am nowhere close to 25 square. This means this triangle is not a right angle triangle. That's why I would use the Heron's formula. I would use the Heron's formula. What does the Heron's formula talk about? Heron's formula says that when you have a side or a triangle with three sides and they are not forming maybe an isosceles triangle, or it's basically a scalene triangle. So it's easy to find out the area using the value of semi-perimeter. The value of semi-perimeter is adding up all the sides and dividing it by 2. What do we get? We get a 60. No, we get a 59. 59 plus 9 is 68. 68 plus 30 is 98. Yeah. So we get 98 over 2. We'll check again. Okay. This is 25. This is 34. This becomes 68. No, this becomes 9. And this becomes 59. With 59, there is 39. We get an 18 here and we are at 98. Yeah. 98 over 2, which is 49. Now employing this formula with S into S minus A into S minus B into S minus C and putting a root on top. This would lead to us getting 49. With 49 minus 25 is 24. 49 minus 39 is 10. And 49 minus 34 is 15. Right? Yeah, it's 15. So taking a whole root out of it, I'll get a 7 out here. I'll get a 5 out here. Then I'll get a 6 into 24, that's 144, and a 12 out here. So this is the area of the triangle which we have gotten. If the area of the square exceeds the area of this triangle, we have the area of the triangle here. 12 sevens are 84. 84 into 5 is 420. 420 is the area of the triangle, and the area of the square. The area of the square is equal to 21 plus 420. This would give me 441. Now 441 is the area of the square. I need to find out the side of the square. So I'll simply put a square root on top. 441 is the square of 21. And that is the answer that I was looking for. Okay, let's move forward. Similarity of triangles. There are multiple kinds of similarities which we get in triangles, and 3 of them have been written: angle, angle, side, 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 and side, angle, side, and line parallel to base. Okay, so what happens is that there are when two triangles are similar, their corresponding angles are equal and their corresponding sides are in the same ratio. When we talk about congruence of triangles, we talk about them being equal in height, sorry, equal in all parameters, all parameters. That means all angles would be equal and all sides would be equal. Okay, all angles would be equal, all sides would be equal. So in such a situation, that those triangles are called congruent, or they are congruent in nature. When we talk about similarity, At that time, we don't get all the parameters equal. We get angles equal, and we get sides in equal proportions. We get sides in equal proportions, and we get all the angles as equal. Okay, so AB upon PQ is equal to BC upon QR is equal to AC upon PR, right? And the congruence sign, or and the similarity sign is written as this. The congruence sign, is written as one, the equal to, and the tilde sign. Okay, this sign is called the tilde sign. Okay, let's move forward. Double A is two angles of one triangle are equal to two angles of another triangle. Triple S means all three corresponding sides are in proportion. And SAS, side angle side, these include angle, the included angle is equal, and the ratio of the surrounding sides is equal. AB upon PQ, BC upon QR, and AC upon PR. So this entire situation is going to be squared up. Okay. Also, if DE is parallel to BC, that means we are talking about the Thales theorem. Okay, we are talking about the Thales theorem, in which, or rather, it's the basic proportionality theorem. There is a line DE parallel, which is parallel to BC. In that situation, AD is proportional to the entire triangle's AB length, AE is proportional to the entire triangle's AC's length, and DE is proportional to BC, which is the dividing side and the base. Okay, moving on, and we'll now solve the questions. Also, yeah, we'll now solve the question. Both the triangles are similar, BC and EF. Okay, 4 by 5. BC over EF is 4 by 5, and the triangle of area ABC is 80. Then what is the triangle of DEF? What is the area of triangle DEF? The answer to this question is the area will also be in the same proportion as the sides are. The area is also going to be in the same proportion as the sides are. So triangle DEF's area is what we'll be looking at. Right? 4 20s are 5 20s is 100. So 100 is the area of triangle DEF. Right? Let's move on. Now, talking about triangle ABC being similar to triangle QRP, the area of ABC upon area of QRP is 9 by 4. The area is 9 upon 4. The corresponding sides are 18 and 15. Okay, because they are coming from the same triangle. If we are talking about ABC, we're talking about ABC, and we're talking about QR and P. AB is proportional to QR, BC is proportional to RP or PR. So we'll only talk about BC here. Okay, AB is not required in the equation. BC upon RP, or I'll call it PR for now. Okay, so BC over PR is equal to 9 by 4 is equal to 15 over PR. From here, I'll get the value of this. This is 4 5 is 20, and 20 upon 3 is the value of PR. Okay, 20 upon 3 is the value of PR. Good enough? Let's move on. In triangle ABC, points P and Q lie on AB and BC respectively. Okay, this is a triangle which I am drawing, and AB, P and Q lie on this P and Q, and A, B, C. Right? So after solving this part, I just need to settle the camera for a second. Yeah. Okay. I think it's better now. Hmm. Yeah. So after solving this part, we have this point where it is not helping us solve a question, but it's just telling us a few basics that in a triangle, there is a possibility that there is a triangle. This is ABC, and PQ is a line which is pointed at P is a point on the line AB, and Q is the point on the line AC. So this would be parallel with this. This is being parallel with this. So nothing. Just because of this, there is a relation which comes up, which is AP upon AB being equal to AQ upon AC being equal to PQ upon PQ upon BC. So this ratio relationship comes up because of similarity of triangles. There is a common angle A. These two lines being parallel, there is a common angle. There is an equal angle of P and B, and there is an equal angle of Q and C. That is why this similarity occurs. Okay, this similarity occurs because of that. Moving forward, we have a question on that. We have a triangle ABC. We have a triangle ABC. D lies on AB and F lies on BC. Okay, this is F. F lies on BC. This is no point. Let me quickly remove it. Yeah, F lies on BC. So this is where the joining is happening, and DE is parallel to uh, and E lie on. See, we have DF which is parallel to AC, and we have DE which is parallel to AF. Okay, we are talking about this. We have DE being parallel to AF. Where does E lie then? E and F lie on BC. Okay. So it lies somewhere here. This is E. Yeah. Yeah. So these two, 1 and 2, these are parallel, and 3 and 4, these are parallel. Okay. The arrows are pretty much visible. So you know which ones are parallel to what. If BE is equal to 4 and EF is equal to 6, then find the length of BC. Okay, so in such a question, I can say that BE upon EF, BE upon, no, this is BE over BF, BE, this is the small portion, over the entire portion which is BF. This would have the same ratio as of BF over BC, which is 10 over BC. So 4 by 10 is equal to 10 over BC. So the value of BC comes out to be 25. And this was our question. Moving forward, in a triangle LMN, OP is parallel to MN. LMN, this is OP. OP is parallel to MN. OP intersects LM. OP intersects LMN at O and P respectively. Okay, that's okay. If LM is equal to 15 and OM is equal to 4, TN is equal to 5, then what is the side? What is the length of side? LN. Okay, we need to find out the length of this side. So when I say LO, do we have the length of LO available? Yes, we can find that out. We have the entire LM is 15 and OM is 4. So LO is 11. So there is 11 upon 15, the entire side, upon LP. LP is something which we need to find out. and LP plus PN would make LN, and LN is LP plus 5. So this is the only thing that we have to solve. 11 LP plus 55 is equal to 15 LP. So 55 becomes equal to 4 LP. The value of LP is equal to 4 ones are 4, 4 6 are 16 for the 54, 16.25. So 16.25 centimeter is the length that we were looking for. Great, good. Let's go ahead. Yeah. So here we'll be talking about the similarity of triangles. We have already talked about it in one of the previous slides. Yeah, we've already talked about the similarity of these triangles in the previous slide, but this is a little different. If two triangles are congruent when the corresponding sides are equal in length and the corresponding angles are also equal, at that time we get a sign. This is the sign, the tilde sign, the equal to and the tilde, which is the congruence triangle. The congruent triangle sign, it cannot be created. That is why we show here as two tildes in parallel. Okay, so this is the sign of congruence. Then we have four types of congruences, and the first one being the side. When all the sides are equal, this is very sure that the both the triangles will also have equal angles. Okay, then there is side angle side, two sides and the angle which is included, which is between them. Let's assume that these are two triangles that I'm calling congruent. So if this side and this side are equal, these two sides are equal, then the common angle, these two angles, they would be equal, and hence they would be congruent. See, congruence is a condition that is supposed to be satisfied. Congruence is a condition that is supposed to be satisfied. If the three sides, if the three sides in the first option are equal, they are congruent. If two sides and a common angle are equal, they are again congruent. If two angles, if two angles and the sides which is included between them, let's assume we again call for two triangles. If two angles, this angle corresponding to this angle and this angle, including this common side, this side, if all of them are equal, then the triangles are congruent. Then in RHS, in right angle triangles, hypotenuse and one side. Okay, because we already have the 90-degree with us. We already have the 90-degree with us, which is common in both the triangles. That is when the RHS thing comes up, the right hypotenuse side comes up. So one side and one hypotenuse, one side and one hypotenuse. What you will be able to see is that once two sides are equal, you will also see the third side automatically equal in a right angle triangle. Okay, so moving forward, we've already talked about everything here. We'll be switching to the question. Here again, we have a few problems in front of us and we'll be solving them through and through. So triangle ABC, let's consider this one to be ABC and this one to be D, E and F. If angle A is equal to 55 degrees, B is equal to DE. BC is equal to DE. I think this is what it is talking about. Angle E is equal to 85. Let me first write that. Angle E is equal to 85. Angle F is equal to 40 degrees. 40 degrees. Okay. So I think this is BC is equal to DE, if I am not wrong. Yeah. BC is equal to DE and CE, CA, I think. Yeah. That's right. CA is equal to DF. So CA is equal to DF and BC, no, I think it is not, it's not BC, it would rather be AB, AB, AB. This one is equal to this one. So from this triangle, I can say that this angle is also equal to 55 degrees using the angle sum property. So I have two sides plus common angle, two sides plus common angle. This gives me the property of SA of SAS. SAS stands for side, angle, side. Okay, side, angle, and side. So this is the property by which A, B, C, and triangle DEF are congruent in nature. Got it? Moving forward. Now it is given that PQR and M and Y. This is PQR and M and Y. They are congruent to each other. The value of PQ is 8. The value of angle Q is 55 degrees. The value of angle P is 72 degrees. So let me find out the value of angle R. 72, it's basically going to be 180 minus 72 minus 55. Okay, so this would be 180 minus 127. This would give me a 3 and this would give me a 5. So this is going to be 53 degrees. This would be equal to 53 degrees. Now the question is, which of the following is true? We have the value of PQ. First of all, if PQR and M and Y are congruent, that means the congruent sides would be congruent sides of corresponding triangles are going to be equal. So that means MN is also going to be 8 centimeters. So these two options are gone. Only MN. These are 8 centimeters. These are like 8 centimeters. Then talking about angle M or angle Y. Angle M corresponds to angle P and angle Y corresponds to angle R. So we've just found out the value of angle R. That means the value of angle Y is going to be 53 degrees. And that is what we are looking for. So 53 degrees is the value of angle Y is equal to 53 degrees. Okay. So this is what we are looking for. 8 and 53 degrees. Moving forward. Yeah. Area of triangles when base is divided and the height is same. What happens is when triangles are sharing the same height and their areas are directly proportional to the bases, then their areas are directly proportional to the bases. Like here, I can say that AD, this is the common height. Both of them are standing at a common base as well. This is a common base, but the base is split into 2:3 ratio. That means the area of the triangle is going to be 2:3. Okay, if a point divides the base in a given ratio, then the areas of the two subtriangles also get divided in the same ratio. Okay, also get divided in the same ratio. If two triangles share the same height, then their bases are in the ratio A is to B, then the area ratio is simply A is to B. Nothing, there's no sort of A square is to B square. The answer is only going to be A is to B. Right? Moving forward. In triangle ABC, this is a triangle ABC that we've drawn here, pre-drawn here, and D is a point on BC such that BD is to DC is 2:3. BD is to DC is 2:3. So what is the ratio of the areas of ABD? Let me join it off. Ratio of areas of ABD is to ADC. The answer is pretty simple. It's also going to be 2:3 because I just talked about the property which says that if the height of the triangle is the same and the bases are divided in a certain ratio, then the area would also get divided in that certain ratio. Right? Let's move forward. In triangle ABC, medians BE and CF. BE and CF. This is F, this is E. Intersect each other at M and are perpendicular to each other as well. Okay, they are perpendicular to each other as well. If the value of BE is 9 centimeters and the value of CF is 13 centimeters. Okay, let me use a different colored pen here. BE is 9 centimeters and CF is 13 centimeters. Then find the area of the triangle ABC. So what can be done here is that so what happens is that as soon as we get medians into the picture, we know that this becomes the M becomes the centroid of the triangle. M becomes the centroid of the triangle because the intersection point of all the medians is the centroid. Even if we have two medians, we can still call it a centroid because in actual it is a centroid. But if we see what is the true picture is that once these three medians meet up and we talk about the circumradius, we've all these are the circumradii MB, MC, and MA. This is nothing but the circumradii because it is passing from the centroid, and the centroid is the center where if you draw a circle, it will touch all the vertices on the outside, right? So here I can see that if I know the area of the triangle, if I know the area of the triangle BMC, that would be 1/3 of the area of ABC. If I get to know the area of the triangle BMC, that is going to be 1/3 of the area of the triangle ABC. I hope that picture is correct. Now, once this situation is in place, what are we supposed to do? We're talking about BMC. BMC has two sides which can be brought into the picture because it is a right angle triangle. Half into BM into MC would give me the area of this triangle. Let me try to find out what is the value of BM. When I talk about BM, BM is equal to 2/3 of its length, which is 9, because the centroid divides it in 2:3 ratio. So 2/3 of its length, 2/3 of 9. So 2 by 3 of 9 is nothing but 6 centimeters. Further, what about MC? MC is also 2/3 of its length, 2/3 of 13, which is nothing but 26/3. So I have the length of BM and MC. The length of BM is 6, the length of MC is 26/3, and half of it, because half into BM into MC would give me the area of the triangle BMC, right? So 3 to the 6, this is gone. The area of the triangle BMC is nothing but 26 centimeters. Okay, it's nothing but 26 centimeters. I've already declared that the area of the triangle, once it is found out, if I do 3 times of that, then I would get the area of the triangle ABC. So area of the triangle ABC is nothing but 26 into 3, which would become 78 centimeters. Okay, so 78 centimeters is my final answer. I hope you got it. Moving on. Now, there are a few other theorems which I really want you to know. In a scalene triangle, all the angles are different and all the sides are different. Then simply the perimeter of a triangle is A plus B plus C. Talking about Heron's formula, I've already talked about it. Heron's formula is nothing but the area being equal to, in the root, semi-perimeter multiplied by semi-perimeter minus first side, semi-perimeter minus second side, and semi-perimeter minus third side. What is actually semi-perimeter? Semi-perimeter is half of the perimeter of the triangle, which is A plus B plus C whole upon 2. Talking about acute angle triangles, in acute angle triangles, all the angles are less than 90 degrees. Okay, all the angles are less than 90 degrees. Also, the sum of the squares of two sides is always greater than the third side. This is a precondition. This is a precondition for acute angle triangles. Similarly, in obtuse angle triangles, one of the three angles is definitely greater than 90 degrees. Okay, if you only have one angle which is greater than 90 degrees, that will create an obtuse angle triangle. Okay, moving forward. sum of the squares of the smaller sides is greater than the square is less than the square of the largest side, which means that AC square, let's assume this is the largest side, it's going to be greater than the sum of the square of the smallest smaller sides basically. Here I'm talking about AB square plus BC square, it is going to be greater than AC square. AB square plus BC square is equal to greater than AC square. This condition sets true or sets itself true as obtuse angled triangle. For an obtuse angle triangle, this works that way. Okay. Talking about internal bisector theorem and external bisector theorem. When AD is bisecting angle BAC, that means when angle A has a bisector of itself which divides both the angles into equal parts. Let's assume that both of them are x is to x. At that time, we have BD is to DC. There is a proportion which comes up which says that AB upon AC, which is the supporting hands or the joining hands of the angle AB upon AC is equal to BD upon DC. Okay, AB upon AC is equal to BD upon DC. Similarly, if this angle this happens externally, let's assume this was the triangle. This was the triangle that was in question, but external angles external angles got bisected. The external angle was angle DAC, it got bisected. The bisector is AE, so the proportion is going to come out in almost the similar manner, which is AB upon AC, which is the supporting angle or the outside angle of angle A, which is equal to BE upon CE. This is BE, which is the entire thing, upon CE, which is only the external arm. Okay, entire line CE is the external arm. Okay, so I think everything is very clear over here. Also, in external angle bisection, it becomes half of the internal two angles or half of the difference of the internal two angles. We will be talking about this once we come to the real questions. Yep. So it's given that in triangle ABC, AD bisects BAC, AD bisects angle BAC, given that AB is equal to 6 and AC is equal to 2x minus 3. If the value of BD is x minus 2 and the value of DC is x, then find the value of BD. That means I need to find out the value of x minus 2. Now this is the bisector and I would apply the internal angle bisector theorem, which is AB over AC is equal to BD over DC. The value of AB is 6. The value of AC is 2x minus 3. This is going to be covered in BD. BD is x minus 2 and DC is going to be x. Okay, so this would lead to a simple quadratic equation which I'll have to solve. The value of 6x is equal to 2x square minus 3x minus 4x plus 6. This minus 6 would also, this 6x would also come over here and I would get 2x square minus 13x plus 6 being equal to 0. This I can write down as 2x square minus 12x minus 1x plus x being equal to 0. 2x taken out common. This would give me x minus 2, sorry, x minus 6 and minus x taken common sorry, minus 1 taken common, this would give me x minus 6, which is equal to 0. From here I can say that 2x minus 1 was multiplied by x minus 6. This is equal to 0. Either the value of x is half, or the value of x is 6. If I use the value of x as half, then BD would not exist. It would become a negative value. That is why I would consider the value of x as 6. If the value of x is 6, I need to find out the value of x minus 2, which is equal to 6 minus 2, which is also equal to 4. And this is my answer, and this is the length of BD that I was looking for. Okay, this is the length of BD that I was looking for. Moving forward, talking about AB is to AC. AB stands for 5, AC stands for 2. The value of BC is in total 9. And the angle bisector of angle CAD. So this means this is an external angle that we're talking about. This is angle CAD meets extended BC. Okay. Meets extended BC, yeah, at E. This means, let's assume that this is the angle and this is the bisector. They are going to meet somewhere on the outside at this point. Okay, this isn't C. Let's assume this to be C. Okay, so we'll be using the external angle bisector theorem. It is the same, AB upon AC being equal to BE upon CE. We need to find out the value of CE. AB upon AC is pretty clear, which is 5 over 2. BE is something which I need to find out. Let's assume that BC is equal to X. Let's assume that BC is equal to X. No, let there be 9 only. BE is made of CE. Let's assume CE to be X. Okay, let's assume CE to be X. This gives me an X here, and this gives me a 9 plus X here. This is 5X being equal to 2 multiplied by 9 plus X. This would give me 18 plus 2x, and this is 5x. The 2 shall go on the other side, and 3x would become 18. The value of x is nothing but 6. That means the value of CE, which I was trying to find out, the value of CE is equal to 6. Good enough. We use the same external angle bisector theorem. This is the external angle bisector theorem. External angle bisector theorem. Right? Let's move on. In triangle PQR, PS is perpendicular to QR. PS is perpendicular to QR, and PT is the bisector of angle QPR. QPR, let's assume this is PT. This is PT, right? Is a bisector of angle QPR. If angle Q is equal to 60 degrees and angle R is equal to 36 degrees, then find the value of angle SPT. Okay, we ignored a point which came up 3 slides back. This was, if you need to find out the value of angle SPT, it's going to be half the difference of Q and R. Half the difference of Q and R. If I simply need to find out the value of angle SPT, I would call it half the difference of 60 minus 36. 60 minus 36 is 24. 24 upon 2 is 12 degrees. Okay, 24 upon 2 is 12 degrees. You can also follow it up with a bigger approach. The bigger approach says that this external angle 60 plus 36 make it 96, and another 84 is something that comes here. 84 degrees comes here. If 84 degrees comes here and 36 is on the other side, then using the angle sum property, we can find out the external angle like this. We can find out the external angle like this. Once the external angle is found out, then we can go inside and find the smaller angle. But it is much better to remember this formula, which says that if you have the perpendicular as well as the angle bisector coming together, and you need to find out the angle between both of them, then half of the angle 60 degree minus 36 degree is going to be my answer. Okay, so 12 degrees is my final answer. Moving forward, angle A is 92 degrees. If I is the in center of the triangle, then find out the value of angle BIC. Okay, this is I, this is A, B, and C. There is this property of in center of triangle which simply and straight away gives you the value of angle BIC. So the simple formula is that angle BIC is equal to 90 plus half of angle A. Okay, angle BIC is 90 plus half of angle A. This means it becomes 90 plus 92 over 2, which is 45 plus 1, 46. 46 plus 90. This would give me a 6. This would give me a 13. So this is 136 degrees that we are talking about. Okay, 136 degrees that we are talking about. To solve such a question which says that 2, 5, and 9, these are the three sides of a triangle, can they actually form a triangle or not? There is a very simple concept which says that the sum of two sides must be greater than the third side. Okay, the sum of two sides of a triangle must be greater than the third side. So I have 2 plus 5, which is equal to 7. This 7 is not greater than 9, but 9 is greater than 7. That means this kind of a triangle cannot be formed. Okay, this sort of a triangle cannot be formed. Moving forward, in triangle ABC, AB is equal to AC, and angle BAC, this is BEC. This is angle BAC. Angle BAC is 35 degrees. And I need to find out the value of angle ABC. This value has to be found out, and AB is equal to AC. This is a simple isosceles triangle. If I consider this angle to be x, the opposite angle is also going to be x. So 2x plus 35 degrees is equal to 180 degrees. This is nothing but the angle sum property. When it goes here, it becomes 145 degrees. 145 degrees over 2 is the value of x. So the value of x, or the angle of A, or the value of angle ABC is 72.5 degrees. Okay, the value of angle x, or the value of angle ABC is 72.5 degrees. Okay, moving forward, in triangle ABC with sides 8, 9, and 12, let's call this 8, 9, and 12, the angle bisector of the largest angle would be opposite to the largest side. Let's call this ABC. That means the largest angle is angle ABC. Okay, the angle bisector of the largest angle divides the opposite side into two segments. Okay, this is the angle bisector. Find the length of the shorter segment. This is a angle bisector. We have just found out with the last property that AB over AC is equal to BD over DC, calling this point D for a while. AB over AC is equal to BD over DC. AB over AC is 8 upon 9, and BD over DC is something upon something. BD over DC is again 8 is to 9. find the length of the shorter segment. The total length of BC is 12, which is also equal to 17 units. Why and how I could write 17 units is that BD over DC in terms of ratio is 8 upon 9. So BD and DC when added would become 17 as a ratio. So 17 units is equal to 20 centimeters in real world. 17 units or 17 ratio is 12 centimeter in the real world. I need to find out the length of the shorter segment. The shorter segment is going to be towards this side. Okay, this is going to be the longer segment, and this is going to be the shorter segment. That means I need to find out the value of BD. The value of BD is nothing but 8 units. The value of 17 units, the value of 17 units is equal to 12 centimeters. The value of 8 units should be equal to 12 centimeter upon 17 into 8. 12 8s are 96. 96 over 17 is my answer. When I split it away from my mixed fraction, 17 5s are 85 and 5 11 by 17. This is my final answer. Okay, let's move forward. Now, in triangle ABC, this is not BC, this is B, this is C. AD is perpendicular to BC. AD is perpendicular to BC, and AE is the bisector. Let's assume it's talking about this. AE is the bisector of angle BAC. If angle ABC is 58 and angle ACB, yeah, it's 34, find the value of angle DAE. We've already done this. The clear cut and short answer of this is half into half multiplied by 58 degrees minus 34 degrees. 58 minus 34 is 24 over 2. This 24 over 2 is 12 degrees in nature. So 12 degrees is what I am looking for, and this is my final answer. Whenever you have to find out the angle between the perpendicular and the angle bisector, that is going to come with half of the difference between the other two sides which are at the opposite ends. Okay, let's move forward. PQR. So PQR is a triangle, and the bisector of the internal angle of Q and external angle of R. Internal angle of Q and external angle of R meet at S. If QSR is 40 degrees, then find out the value of angle P. See, there is a very set and very clear formula for such a question, and that, yeah, so the simple formula is that angle P by 2 is equal to angle S. Whenever such a thing happens that one internal bisector meets the other external bisector, then a relationship between the top angles comes out, and that relationship is half of the bigger angle or half of the angle which was already there in the triangle is equal to the new angle which comes up. Okay, the angle which is formed between the internal angle bisector and the external angle bisector. So simply, if I need to find out angle P over 2 is equal to 40. So angle P would be equal to 80 degrees. Okay, quite natural, quite simple. Let's move forward. So if three sides of a triangle are 9, 24 and S units, which of the following is correct? See, the correct portion over here is determined. See, all the options are equal. All the options are same. See, what usually happens is if you have two sides as 9, 24 and S, then the third side would always fall in the range of 9 plus 24, which is 33, and 24 minus 9, which is 15. This is the range in which this side will definitely fall. Okay, moving forward, talking about parallelogram. In a parallelogram, it is basically a four-sided figure. You start from the bottom left, A, B, C, and D. It has two sets of parallels where AB is parallel to DC and AD is parallel to BC. Okay, it has two set of parallels. The opposite angles are equal. The angles which are opposite to each other, this angle is equal to this, and this angle A is equal to angle C, angle B is equal to angle D. The adjacent angles add up to 180 degrees. These two add up to 180, these two add up to 180, these two add up to 180, and these two also add up to 180 degrees. Diagonals bisect each other but are not as necessarily equal. Like the diagonals do not divide each other into half, but they cut each other for sure. Some formulas which are important is that angle A plus angle B is equal to 180. I told you the adjacent angles are equal. Adjacent angles sum up to 180. Talking about area of the parallelogram, area of the parallelogram is based into height. You can consider any one of them to be the base. If you consider AB to be the base, then the height would come out from here and this would be the height. If you talk about BC to be the base, then the height would come from the opposite side. Okay, the height would come from the opposite side. Then perimeter is simple, 2 into A plus B, 2 times the A plus B. A is the length of one side, B is the length of the other side. What about the diagonal identity? The diagonal identity says that AC square into BD square, AC square into BD square, which is the sum of the squares of the diagonals, it's equal to 2 times AB square plus AD square, 2 times the sum of the squares of the sides, sum of the squares of the sides. Okay, good enough. We know all the properties. Now we can move forward. The adjacent sides of a parallelogram are 10 and 15 centimeters. If the height corresponding to the shorter side, let's assume this to be the shorter side. No, this is not the height corresponding to it. Wait. Yeah. Had it been 15, the height would have been this, but it is 10. That means this is going to be this. Yes. So let's assume that this is a 90-degree angle which has been created, and this is 10 as well. This is the height. Okay. If the height corresponding to the shorter side is 6 centimeters, this is 6 centimeters. What is the height corresponding to the longer side? The height of the shorter side multiplied by the side corresponding to it. This would form the area of the parallelogram. This would form the area of the parallelogram. If the height is equal to 6, the side is equal to 10. This would give me 60 as the area of the parallelogram, right? We learned it here, base into height. So 60 is the area of the parallelogram. If I have the area, I need to find out the height to the corresponding longer side. The longer side is 15 multiplied by the height x that we're talking about. This is equal to 60. This would come up as the height of the shorter side, or the height corresponding to the longer side is going to be 60 over 15, which is equal to 4 centimeters. Okay, this is equal to 4 centimeters. Moving forward, in a parallelogram, if one of the diagonals is 20 and the perpendiculars dropped from the opposite vertices are 6 centimeters and 4 centimeters, then what is the area? We have actually learnt this. We have actually learnt this in 2D mensuration. In any parallelogram, if you have the length of one diagonal available to you, which is 20 centimeters, which is the length of one diagonal available to you, and perpendiculars are dropped from opposite vertices. This is one vertex, a perpendicular is dropped here. This is another vertex, another perpendicular is dropped here. If this one is 6 and this one is 4, I need to find out the area of the entire figure. The discussion ends here when I say half into AC multiplied by, let's call it AD, and BL. Okay, half into AC, which is the diagonal, KD plus BL. Half into AC into KD plus BL. This means it is half into 20 into KD is 6, BL is 4, 6 plus 4, it is 10. So 200 over 2. So 100 centimeter square is the area. 100 centimeter square is the area that we are looking at. Okay, let's move forward. A triangle and a parallelogram have the same base, which is 28. This is also 28 and the same area. If the height of the parallelogram is 12, let's assume this is what we were talking about. The base is 28, so this base is also 28, and this height is equal to 12. Then I need to find out the length of the altitude of the triangle. First, we need to say that area of parallelogram is equal to area of triangle. Area of parallelogram is base into height. Area of triangle is half into base 1 into height 1, half into base 1 into height 1. The base and the height of the parallelogram have been given as 28 multiplied by 12. This is going to be half multiplied by the base of the triangle, which is 28, multiplied the height, which we need to find out. Let's call it h1. The 28 and the 28 get cancelled. The 2 goes to the other side, which gives me the value of h1 being equal to 24 centimeters. So the value of h1 is nothing but 24 centimeters. Good enough. Let's move forward. A parallelogram is a special quadrilateral. We've already done this. Okay. Then there is something called the diagonal angle bisector property. If the angle bisectors of angle B and angle C are drawn and they meet at a point O, then the angle between them, which is the angle BOC, is half of angle A and half of angle D. Remember this, okay? And there is a diagonal identity which says that the diagonal 1 square plus diagonal 2 square is 2 times the length square plus breadth square. Okay, we've already done this property somewhere here, right? Two times the length of A square and the length of B square, which are the adjacent sides. Once you touch any adjacent side, they would definitely come out as one of them would be a flat line, one of them would be the horizontal side, and one of them would be the vertical side. So 2 times A square plus B square is equal to AC square plus BD square, which is nothing but the diagonal square relationship or the diagonal identity, right? So this is what we were talking about here. Okay, moving forward. In a quadrilateral A, B, C, D, the bisectors of angle C and D meet here. This is the point at which they meet, and this is the angle which they form. Angle C and D meet at point E. If angle CED is 57 and the value of angle A is 47, what is the measure of angle B? We've just learned it through this example that angle BOC is half of angle A plus angle D. Similarly here, half of angle A plus angle B. Let me check. Half of angle A plus angle B is equal to angle DEC. Angle DEC is 57. Angle A has been given as 47. 47 plus angle B would be equal to 57 into 2. This would come out as 114 degrees. 114 degrees, 47 degrees plus angle B. 47 would go to the other side. Yeah. 47 would go to the other side. This is 107. 107 minus 47 is 40, is 40, 67 degrees. So angle B is nothing but 67 degrees. Okay. Angle B is nothing but 67 degrees, which was the question in point. Moving forward, the length of two adjacent sides of a parallelogram are 3 and 10. Let's say this is 3. Let's call this as 10. What is the sum of the square of the diagonals? We learned this method that 2 times the sum of the squares of the sides is going to be the sum of the squares of diagonals. D1 square plus D2 square. So 2 times of 109, which is 218. 218 is the value of D1 square plus D2 square, and this is final. Okay, this is completely final. Moving forward, in a triangle STU, let's say this is triangle STU. V is a point on the side ST and W is a point on the side SU. Such that VWUT, VWUT becomes a trapezium. Given that VW is 2 and TU is 7 in terms of ratio, what is the ratio of the area of the trapezium VWUT to the area of the triangle STU? STU stands at the height. STU stands at the height. So in this particular side, we'll be touching upon the area of a triangle which is bisected somewhere, which is cut somewhere between the center. So this is one height of a triangle and this is another height of a triangle. The bases are different, which are 2 and 7. So in this kind of a concept, I need to know the area of triangle SVW and the area of triangle STU. Here the heights are different, that is why we cannot establish a relationship between them, but we can still find out what ratio they together will be. So first one is having a base of 2. The ratio would be base square, which is 4. The base of the second one is 7 and the ratio would be base square, which is 49. So 4 is to 49 would be the ratio of the area of the smaller triangle and the full big triangle. Now what is it asking us? It's asking us the ratio of the trapezium and the full triangle. The area of the trapezium is the full triangle minus the small triangle, and this is how we find out the trapezium. And talking about the entire triangle, the area of the entire triangle is 49. So 49 minus 4 upon 49. This gives me a ratio of 45 is to 49. Okay, so this is my answer. Moving forward, talking about a few similarities. If there are two similar triangles, no, this is nothing. Diagonal, no. Triangle similarity, Pythagoras. So I've seen a couple of you getting stuck at this particular question. So I'll be solving it very, very slowly. In the given figure, ABCD is a rectangle, and let me adjust the camera. Yeah, how is it now? Let me see. Yeah, this is good. So in the given figure, ABCD is a ABCD. This is A, B, C, and D. This is a rectangle, and P is a point on DC. P is a point on DC such that BC is 24, DP is 10, and CD entirely is 15. If CD is entirely 15, then I can say that CP is 5, right? If AP is produced to point Q, and let me rephrase this, and BC is also produced to Q, then find the length of AQ. Let me join these first. There is an extension here as well, and this is the point Q. Now we are asked to find out the length of AQ. Okay, so what can actually be done here? I can say that this line, let's call it PX. The length of PX is also 24 because it is sitting inside the breadth of the triangle, right? Because it is sitting inside the breadth of the triangle. So this is also 24. But the value of AX is equal to the value of DP, which is 10, because again the same side of the triangle, same the opposite side of the rectangle, and PC is 5. That's why XB is also 5. So I'll do a very familiar thing. I'll assume that this angle this angle PAX is equal to theta, or this sine theta. Okay, so I'll apply tan theta over here, and I'll find out the value of tan theta using triangle PXA. In triangle PXA, the value of tan theta is 24 by 10. Further, in triangle QBA, the value of tan theta would be equal to, let me call the that would be equal to 24 plus QC whole upon 15. Both the tan thetas are equal because we are talking about the same angle. That is why 24 over 10 is equal to 24 plus QC over 15. So this is 5 2s are 10, this is 5 3s are 15. This would become 12, and 3 12s are 36. 36 minus 24 would give me 12. So the value of QC is equal to 12 centimeters. Once I have the value of QC, I can again focus on triangle QBA. I can again focus on triangle QBA. What does triangle QBA stand for? Triangle QBA is a right angle triangle at angle B. That is why Pythagoras theorem, it can be applied there. Pythagoras theorem can be applied there. How do we apply that? We apply that by saying that QB square plus AB square is equal to AQ square. The value of QB we've right now, like very recently found out, which is 36 square. The value of AB we have 15 square. This would give me the value of AQ square. If you do this, the square of 36 is another 36. 3 3s are 9, and 3 6 are 18. 18 2s are 36. It's 1296. Okay, this is 1296, and the square of 15 is 225. The square of 15 is 225. When you add it all up, you basically get the square of 39. So 39 is the value of AQ that we were looking for. Okay, good enough. Let's move forward. Now we'll be talking about another quadrilateral, which is a rhombus. A rhombus is a special type of a parallelogram in which all the four sides are equal. The opposite angles are equal, the opposite sides are parallel, diagonals bisect each other at 90 degree at right angles, but they are not necessarily equal to each other. Diagonals divide the rhombus into four congruent right angled triangles. Okay, four congruent right angle triangles. Congruent means they are equal. Okay, they are equal. Then talking about sum of adjacent angles, sum of adjacent angles is definitely 180 degrees. The formula of area that we employ most of the time is half into d1 into d2. That is the length of diagonal 1 into diagonal 2. Further, diagonal 1 square plus diagonal 2 square is equal to 4 times of the side square. And lastly, angle A plus angle B, the angles which are lying in the same line or which are adjacent to each other. The angles which are adjacent to each other, they would have the angles which are adjacent to each other, they would have the sum as 180 degrees. They are supplementary to each other. Okay, let's go ahead and do a few questions for it. Okay, if the diagonals of a rhombus are 8 and 6, then what is the square of its side? Okay, I'll quickly draw the diagonals of a rhombus. One is 8 and the other one is 6. I can find that out quickly by using the property which says that the diagonals bisect each other and they bisect each other at 90-degree angle. So if this is a 90-degree angle and the diagonal has been bisected, so this length of, let's say they are meeting at O, and this is a rhombus ABCD. So I can say that the length of AO is 4. Similarly, the full length of BD is 6. So I can say that the length of OD is equal to 3. The length of OD is nothing but 3. So 4 plus 3, like 4 square plus 3 square using Pythagoras theorem, becomes 4 square plus 3 square becomes the side square. We've been asked what the side square is. So 4 square plus 3 square is nothing but 16 plus 9, which is equal to 25. Okay, this was a conceptual angle which I showed you, but if I take you to the raw formula side, we already know that d1 square plus d2 square is equal to 4a square. So I'll use this. D1 square plus d2 square is equal to 4 times a square. D1 square plus d2 square is equal to 4 times a square. In this method, what we usually do is d1 square is nothing but 6 square and d2 square is nothing but 8 square. This is equal to 4 times a square. We've been asked the value of a square only. So I'll quickly do this by adding 36 plus 64. 36 plus 64 whole upon 4. This is equal to a square. So the value of a square from here comes out to be 25, because 100 upon 4 is nothing but 25. Right? I hope we are doing fine. I hope we are doing good. Let's move forward. In a rhombus STUV, okay, this is S, T, U, and V. In a rhombus STUV, S and U are joined. Okay, the points S and U are joined, not the straightest line in the world, but good enough. Angle SUV is 44 degrees. Angle SUV is 44 degrees. Angle STU is 92 degrees. 92 degrees. Then what is the measure of angle SVU? 4 times SVU. Let's call it angle V. It's already angle V. Let's not touch it. Let's not touch it at all. Angle SVU. This is angle SVU. Let's call it simply angle V. 4 times angle V minus TSU. TSU. Let's call this angle alpha. Okay, let's call this angle alpha. So we'll be able to figure it out pretty easily. I'll tell you how. We've already learned that the adjacent sides are equal to, when they sum up, they are equal to 180 degrees. So angle T plus angle U completely would sum up to 180 degrees. Angle T comes at 92 degrees and angle U comes at 44 plus, let's call this small angle X. This is going to be useful to us. Okay, 92 plus 44 plus X is equal to 180 degrees. So 180 degrees minus, this is going to be 6 and this is going to be 13, minus 136. We get a 4 here, and we have a 7 and a 3. We get 44 here. So from here I can say that angle X is nothing but 44 degrees. Once I have that, I can say that angle, using the angle sum property, angle X plus angle alpha plus 92 degrees, it totals up to 180 degrees. Angle X is already 44, so 92 plus 44. One more time, 92 plus 44. No, I have another shorter way to do it. I have a shorter way to do it. Okay, let me erase this thing that I've done. Let me erase it. Okay, as you've already seen the method that I'm using, you can use that in the exam again. Okay, no big deal. You can use that in the exam again. But let me change the pen color. Let me use a little orange this time. From here, I can say that these two lines are parallel. I can assume that this line SU is a transversal. I can assume that SU is a transversal by virtue of alternate interior angles using the theorem of alternate interior angles. I can say that is equal to alpha is equal to 44 degrees because alternate interior angles are equal. Once that has been found out, let me see if there is any relation between V and T. Opposite angles are equal. Okay, this is also really interesting. So here, using the property of angle V being equal to angle T, using the property of opposite angles being equal, I can say that the value of angle V is going to be, let me quickly change the color of the pen. Angle V is going to be equal to angle T, and angle T has already been given as 92 degrees. So what do I have to do now? I just have to multiply 4 times angle V minus 3 times angle alpha. Alpha has been given as 44. I've just found that out. So 44 into 3, 3 4s are 12, 3 4s are 12, 132 minus 4 times angle V. 4 times angle V. Angle V is 92 degrees. 4 2s are 8, 4 9s are 36. So 368 minus 132. This would give me a 6 here, a 3 here, and a 2 here. So 236 degrees is the answer that I am looking for. Okay, 4 times angle V minus 3 times angle U. No, angle alpha. Okay, angle alpha. Moving ahead. So now we'll be talking a little bit about trapezium. Trapezium is a quadrilateral which only has one pair of opposite sides which are parallel to each other. These parallel sides are basically called bases. The other non-two parallel sides are also called legs. The simplest definition which you can get out of it is, or the simplest properties which you can gather out of it is that the sum of all the interior angles is 360 degrees. There are 4 angles. Adjacent angles between the base and leg are supplementary. Adjacent angles between the base and the leg. This means this angle plus this angle and this angle plus this angle, they would be supplementary. The diagonals always intersect. That's a simple point. And there are multiple kinds of trapeziums. Isosceles trapeziums are the ones where the non-parallel sides, which are AD and BC, they are equal. Okay, right? The right one has 2 right angles in it. Angle A and angle D is equal to D. And scalene, neither the sides nor the angles, nothing is equal. Okay, it is a little bit of an asymmetrical figure, but still very much useful to us. Now, is there a particular formula? Yes, there is definitely a particular formula, which is the length of the mid segment. The length of the mid segment is basically nothing but, here I have a quadrilateral ABCD and I try to divide the quadrilateral into 2 equal parts, and I've used the line E and F to do that. If I now need to find out the length of EF, the length of EF can be given as AB plus DC by 2. Also, length of the line dividing non-parallel sides in the ratio x is to y. If this case was a middle case or the mid segment case, but this case is not a mid segment case. The non-parallel sides have not been cut in equal ratios. They have been cut in different ratios. So if now you need to have the dividing line's length, if you wish to have that, then that would be a times x, b times y whole upon x plus y. Okay, a times x plus b times y whole upon x plus y. Further, diagonal ratio theorem. There is a theorem which is used for finding out the ratio of the diagonals. That is that DE is to EB is to CE is equal to CE is to AE. Okay, this over this is equal to this over this. It works that simply. Okay, I've taken you through all the theorems of trapeziums. Let's now go to some more of them. Okay. There is something called the midpoints of diagonal theorem. We have P and Q. Once you've drawn the diagonals, then also there is a midpoint of the diagonals which is available to me. If the diagonals are connecting, then I can say that AB minus CD whole upon 2 would give me this particular length. Let me take you to the previous question where we found out the length of EF when it was a mid segment. In the case of mid segment, closely see that there is a plus sign being used. In case of mid segment, closely see that there is a plus sign being used, and whenever we are talking about the midpoints of a diagonal, in the case of a diagonal, this situation changes to a minus sign. Okay, this situation changes to a minus sign. Got it? Moving forward, to find out the area of a trapezium, we've already done this in mensuration. We've already done this in mensuration 2D, 2 dimensions. Okay, so half into sum of parallel sides into height is going to be the area of the trapezium. Similarity of triangles simply goes on the basis of like the ratio of the areas squared. Okay, sorry, the ratio of the bases squared. Ratio of bases okay, triangle AOB upon triangle COD, the areas are going to be in the ratio of the bases squared. Okay, remember this, ratio of the bases squared. Why do we have to do that base square ratio? Because they don't have the same height. Okay, had they had the same height, it would have been a different situation. That at that time only the way the base is split is going to matter, but right now we don't have the same height in the equation. That is why the ratio of the bases squared is going to be the ratio between the areas of the two opposite triangles. Okay, let's move forward. Now we are sitting at the question. In a trapezium ABCD, we already have ABCD here. DC is parallel to AB. Good. The value of AB is equal to 16. No, this is the value of AB is equal to 16. The value of CD is 11.2. This is not 16. Let me remove it quickly. The value of DC is 11.2. What is the length of the line segment joining the midpoints of the diagonals? Let me quickly draw it for you. AC. Okay, we have A, B, C, and D here. We already have what is the length of the line segment joining the midpoints of the diagonals. Okay, we have the diagonals available with us. Now I need to find out that particular line that it is talking about, midpoint of the diagonals. I very well know the formula, but I want you to wait and anticipate what's going to come up next, because see, this takes a lot of effort. Okay, this entire situation, the entire teaching thing takes a lot of effort, so there is a very necessary build up that is required. Many of you who don't even understand this, I want you to see very carefully. The ones who know the answer, you can please skip this part. Okay, need not worry, I'm here with you only. Let's call this midpoints of diagonals as E and F. We have a very simple and straight formula. The value of EF is going to be half into AB minus CD. Okay, had it been midpoint or had it been mid segment, then it would have been AB plus CD. So here is going to be half multiplied by AB, which is 16, minus CD, which is 11.2. It could have been 5, but there's a difference of 0.2. That means it is 4.8. 4.8 upon 2 is nothing but 2.4 centimeters. Okay, 2.4 centimeters is what I'm looking for. Well, this was one of the questions that was troubling us. So the question says that ABCD is a trapezium, and sides AB, and CD are parallel to each other. The value of AB is equal to 6 centimeter. The value of CD is equal to 18 centimeters. The value of BC is 8 centimeters and the value of AD is 12 centimeters. Okay. Um, a line drawn parallel to AB divides the trapezium into parts of equal perimeter. Okay. This line, let's call it BC is E and with AD it is F. So the line FE divides the trapezium into two equal perimeters. If BE upon EC is equal to AF upon FD, then find what is the value of BE upon EC. Okay, for that, the first thing that we know is that the perimeters are equal. So I'm going to do the same thing. AB plus BE plus EF plus AF. That means the upper half, the perimeter of the upper half is equal to the perimeter of the lower half. CD, EC, EF and FD. Okay, this is the lower half. The common side gets cancelled, EF gets cancelled, and we are left with this. With everything else, we know two values of 6 and 18 that we are talking about. Now, let the question that we've been asked, that BE upon EC is equal to AF upon FD. Let this be equal to K. Now, I'll be replacing BE plus AF as K multiplied by EC plus FD. Similarly, 18 plus EC plus FD. I would let EC plus FD remain because I need to have some situation where I can find out a value. So the first equation comes out to be K minus 1 multiplied by EC plus FD is equal to 12. Further, the second equation that we can create is that AD plus BC is equal to K plus 1 multiplied by EC plus FD. When I divide equation 1 with 2, I am left with K minus 1 upon K plus 1 as 12 upon 20. Then I am left with K minus 1 upon K plus 1 as 3 by 5. From that, K minus 1 upon K plus 1 as 3 by 5. If I simply do K over 1, I am left with 5 by 5 plus 3 is 8 and 5 minus 3 is 2. So the value of K that I achieve out of it is 4. So K is equal to 4 and that is K is the thing which we were looking for. So the option is C. Okay, the option is C. Moving forward, in a trapezium PQRS, PQ is parallel to RS. This is PQRS. PQ is parallel to RS and diagonals intersect at O. This is the first diagonal and this is the second diagonal. They intersect at O. If PQ is equal to 4 centimeters and SR is equal to 10 centimeters, PQ is equal to 4 centimeters and SR is equal to 10 centimeters, then what is the ratio of the area of triangle POQ to that of the area of SOR? We've already learnt it. And that area comes out to be PQ square upon SR square or simply PQ upon SR whole square. So I'll take you back to the point where we learned this. We learned this over here, that if we are supposed to know the area of these two triangles or the ratio of these two triangles, then I know it's AB upon DC whole square. First I need to put them in a ratio and then I need to square the ratio. Let me first do that. PQ upon SR whole square. The PQ stands for 4, SR stands for 10, this whole square. So 4 by 10, this is 2 by 5. 2 by 5 once squared gives me 4 over 25. And this is the answer that I'm looking for. Okay, let's move forward. Now, we'll be talking about a little bit of theory of rectangle. It's nothing but a four-sided polygon. It has opposite sides which are equal and parallel. The angles are 90-degree. Diagonals bisect each other, but they are also equal in length. Then EF is any point inside the rectangle. Then AE AE square plus EC square is equal to BE square plus DE square. This is the only thing which is important. The rest everything can be derived from the figure itself, but this is something which cannot be derived. So E is basically the intersection point of both the diagonals. So AE square plus EC square is equal to BE square plus DE square. Okay, E is any point inside the triangle. It means it can be any point. Let it be any point. I said diagonals, that is incorrect. Let it be any point inside the triangle, then this equation will satisfy itself. Moving forward, talking about the area of the triangle of a rectangle, area of a rectangle is nothing but L into B. The perimeter is 2 times L plus B. The diagonal is L square plus B square in under root. Whenever we talk about path being outside, at that time we talk about L plus B plus 2 times of D. This is a direct formula of calculating the area of the path which is outside the rectangle and multiplied by 2D. When there is a path, this is outside, okay? This is a pathway outside the triangle. Whenever we talk about inside the triangle, inside the rectangle, we call it L plus B minus 2D whole multiplied by 2D. Okay, this is outside, this is inside. Good enough. Let's move forward. The perimeter of a rectangle is 50 units and the area is 150 square units. What is the length of the shorter side? Okay, the perimeter of a rectangle means 2 times L plus B is equal to 50 units, and the area is, which is L multiplied by B, is equal to 150 square units. What is the length of the shorter side? Now I need to find out the value of the breadth. Okay, because we assume that length is always more than the breadth, that is why we'll be finding out the value of breadth. Let me say that L plus B is equal to 25. This is the first equation that we've derived, talking about L into B being equal to 150, and this is the second equation that we've derived. We need to find out two numbers which when added up make up 25 and which when multiplied make 150. So I can say that the length can be 15, which is greater, and the breadth can be 10. So L plus B is 15 into 10, which is 150, and L plus B is 15 plus 10, which is 25. So this satisfies my equation. The length of the shorter side, B is the shorter side, and this is the length that we were looking for. A rectangular field is 13 into 9. This is the area of the field, 13 by 9. And a path of width 2 meters is built outside. Find the area of the path. Area of path outside. So area of path outside is something that we are looking for. Area of path outside means that we'll be following the formula 2 into width of the path, let me call it D, or the depth of the path, multiplied by L plus B plus 2 times of depth of the path. So the width of the path has already been given as 2. So 2 into 2 is 4. 4 would be multiplied by 13 plus 9 plus 4. 13 plus 9 is 22. 22 plus 4 is 26. 26 into 4. If 25 into 4 is 100, 26 into 4 is going to be 104 meter square. This is the area of the path. Okay, this is going to be the area of the path. Moving forward, PQRS is a rectangle where PQ is equal to this, QR is equal to this. T is a point on RS. Let me quickly draw a rectangle first. I just need to make sure that the rectangle is legible, and yes, it is. P, Q, R, and S. PQRS is a rectangle where PQ is 24 and QR is 16. T is a point on RS. This is, let's say, this is T. What is the area of the triangle P, T, Q? P, T, Q. This is the area that we need to find out. In this particular side, So here we know that the area of a triangle is half into base into height, which is half times base being equal to 24 and height being equal to 16. So half into 24 into 16, this is the height that we're talking about. This would give me 8 into 24, or 8 8 is 64, 64 into 3, 180 plus 12, 192. So 192 centimeter square is the area that we are looking for. Okay, let's move forward. A rectangular pond of this size is surrounded by a walkway of equal width. If the total area of the walkway is 2800 meters square, what is the width of the walkway? If we are talking about a walkway outside, so area outside, we've already discussed, this is equal to 2 times the width multiplied by L plus B plus 2 times the same width. So 2 into the depth that we need to find out. L plus B is 120 because 90 plus 30, and 2 times the depth is what we are looking forward for. So 2800. This means D multiplied by 120 plus 2D is nothing but 1400. Now, if I use these options and I say that I have a 5 on the outside and I would need a 10. I would need a 10 here. Okay. If I have 10 on the outside and I have a 20 on the inside, this satisfies my equation. 120 plus 20 is 140 and another 0 comes in. So that is 1400. Okay. So that is 1400. What is the width of the walkway? So it is 1400 meters. No, this is 1400 meters square. This is the total area of the. No, basically I was trying to find out the value of D, and where I plugged in the value of 10. When I plugged in the value of 10, I could satisfy this equation. So that means the value of D is nothing but 10 meters. Okay, the value of D is 10 meters, and that is the answer that I'm looking for. I just zoned out for a second trying to understand that if something is going wrong. Okay, moving forward, talking about squares. Squares are they are special types of rectangles where all the sides are 90 degrees or the angles are 90 degrees, and all the angles are 90 degrees, all the sides are equal, and the diagonals bisect each other at 90 degrees, and mm, nothing more. Let's move forward and find more properties of squares. Simple properties, there being area being a square, perimeter being 4a, diagonal being a root 2. When we try to find out the area of a rectangle, sorry, area of a square, which is inscribed inside a triangle, at that time, if the square touches the hypotenuse of the triangle at this point, which is P, there is a division that is created between the hypotenuse. It is split into two parts. If the first part is called A and the second part is called B, then this comes out to be AB whole upon A plus B whole square. So this would become the area of the square which is inscribed inside a triangle. Okay. Further, area of a square which is inscribed inside a circle is that this is a point, this is the center. If I go in this direction, this becomes radius. If I also add the other direction, this entire situation becomes diameter. So diameter, I need to find out the thing, right? So this diameter is 2 times of r. This is nothing but the diagonal, and When I do a diagonal square, in reality, when I do a diagonal square, let's assume that we have a square here, and I'll do it very quickly. I have a square which has all the sides as a, and I need to find out the diagonal. So a square plus a square under root, that means root 2a would become the diagonal. If I need to find out the area of a square using the side of the diagonal or the length of the diagonal, I can say that diagonal square upon 2 would give me the area of the circle, the area of the square. Similarly, I get the value of diagonal as 2r. So diagonal square upon 2 would be the area of the square. Okay, would be the area of the square, and the diagonal is going to be 2r. So 2r square by, like, 2r or 4r square by 4. That way it happens. Once the question comes up, then it will be easier for you to understand what I am actually talking about. Okay, let's move forward. Same thing, same thing. Area inside the part, area outside the part. The only difference is the area of the crossing path. See, in area of the crossing path, we haven't done area of the crossing path here. Whenever we talked about area outside, we got the formula of twice the width multiplied by L plus B of L plus B plus 2W. Whenever we talked about area inside, we got twice of the width L plus B minus 2W. Whenever we talked about crossroads, at that time we get the formula as W multiplied by L plus B minus W. W multiplied by L plus B minus W. Got it? W multiplied by L plus B minus W. So here, in rectangle, these formulas are valid. In squares also, these formulas are valid. But the only difference is, in both the places of L plus B, you have to write A plus A. Okay, similarly here A plus A, and similarly here A plus A. Nothing changes. Remember the formulas for rectangles. Apply your own like intellect, and try to figure out how a square would behave. When a square comes in, the length and breadth are the same. So you replace all the lengths and all the breadths with the same thing, which is the side of the square. Okay, need not remember a lot of formulas. Simple formulas of rectangles are enough. Okay, moving forward. The perimeter of a square plot is same as that of a rectangular plot with sides 35 meters and 15 meters. Find the side of the square. Okay, the perimeter of a square plot is the same as that of a rectangular plot with sides 35 in this. Find the side of the square. The perimeter of the, okay, the perimeters are same. Talking about rectangular plot, the rectangular plot perimeter is 2 into L plus B. This is going to come out as 2 times L plus B, means 35 plus 15, that is 50. So here the perimeter of rectangle is nothing but 100. The perimeter of the square is same. If the perimeter of a square is same, the perimeter of a square is 4 times A, which is going to be equal to 100. The value of A comes out as 25 centimeters. Find the side of the square. This is what we were looking for. The side of the square is nothing but 25. Right? Moving forward. The area of a square is 9m square plus 12m plus 4. Find the side of the square. If the area of the square, which is equal to a square, has been given as 9m square plus 12m plus 4, I need to find out the value of a. This means I will have to do a middle term splitting. Okay, I'll first do the middle term splitting and try to find out what this 9m square plus 12m plus 4 is made of. It is supposed to be made up of two sides of the square, and both of them should be equal. So 9 4s are 36. I need to form 36. 6 into 6 is 36. That is how it would be made. 9m square plus 6m plus 6m plus 4. I'll take 3m as common. I'll be left with 3m on the inside plus 2 here, plus I'll take 2 common. I'll be left with 3m plus 2. So from here I can derive that 3m plus 2 multiplied by 3m plus 2. Okay, 3m plus 2 multiplied by 3m plus 2 is going to help me achieve the area. This is a square. These are two terms. If I wish to write what is the value of a, I can write it as 3m plus 2. Okay, a simple root will take away one of the two figures. So 3m plus 2 is gone, and this is what I am left with. Okay, very happy. Let's move forward. A wire in a circle of radius 28 centimeters is bent to form a square. Find the difference of their areas. Okay, so I have a wire. The radius of that is 28 centimeters. If a wire, it's already bent in the form of a circle, we have the radius, so I need to find out the perimeter first, so as to find out the side of the square using that. So the perimeter of a triangle of a circle is nothing but 2 pi r, which is equal to 2 into 22 over 7 into r. The value of r is 28. So 7 4s are 28, 4 2s are 8, 8 2s are 16, 16. This is 176. This 176 is equal to 4 times the side of a square, because the perimeters are going to be equal. So 4a is equal to 176. From this, I can say that 4 4s are 16, 4 4s are 16. One of the sides of the square is 44, or all the sides of the square are 44 in length. I need to find out the difference between them, the difference of the areas between them. If I try to find out the area of a circle, I'm left with pi r square. The value of r is 28. So 22 over 7 multiplied by 28 into 28. So this becomes 7 4s are 28, and let me call it as 56 into 44. This I'm doing only for the ease of my calculation. Now talking about the area of square, we have the side as a, so this is 44 into 44. Simply a difference has to be calculated between these two values. So 44, or like 56 into 44 minus 44 into 44 is going to do the deal, is going to cut the deal for me. 45 when taken common, 56 minus 44 is going to be what? 12. So 44 into 12 is going to be my answer. 12 4s are 48, and 12 4s are 48 is 52. So 528 is going to be the difference in the areas, and this is the answer that I'm looking for. Okay. So this was the question. The question says that we have a triangle. The sides of the triangle have been given as A, B, and C. These are the vertices. AB is equal to 12, AC is equal to 15. Using Pythagoras theorem, I can say that BC is equal to 9. So we've been given that a square is inscribed such that one vertex coincides with the vertex of a triangle. What is the maximum possible area of the square? So we've already learned that the maximum possible area of a square, or the side of the square which is inscribed inside a triangle, is A into B whole upon A plus B. Let me go back to the place where I've written about it. This is the place where I've written about it. So the area stands for A plus AB whole upon A plus B whole square. So A stands here for the perpendicular and B stands here for the base. So the thing which I talked about the splitting up of A and B because of the touching of one vertex on the hypotenuse, this theory is invalid. The only theory which is valid is that A and B are basically the perpendicular and the base respectively. The perpendicular and the base, and once that perpendicular into base whole upon perpendicular plus base is done, is given a whole square. That is when you get the area of the square. Okay, so here the side comes like this. If I do a side square, a whole square on both sides, that is how I will get the area. So the sides that I have are perpendicular and base are 12 into 9 whole upon 12 plus 9 is 21. I need to do a whole square of this. 3 sevens are 21, 3 threes are 9, 36 over 7 whole square. The square of 36 is 1296 and the square of 7 is 49. So 1296 upon 49 is the answer that I am looking for. Okay, let's go ahead. The area of a square inscribed in a circle whose diagonal is 16 centimeters. Remember the formula? D square over 2, if I'm not wrong. Let's not use that. Let's use it in this manner, that we have an A, and the size of the diagonal would come out to be root 2a. The value of root 2a is equal to 16. The value of a is 16 over root 2. We need to find out the area of the square. The area of the square is nothing but a square, which would come as 256 over 2, which is equal to 128. Okay, so this was the answer that I was looking for. Well, this is a very interesting question that we have in front of us. AB and CD. Where is AB? This is AB. And CD. This is CD. These are diameters of a circle intersecting perpendicularly. If radius is 5 centimeters and PA is to PB, PA is to PB, no, sorry, PB is to PA is 2 is to 3, and CN is to ND is also 2 is to 3, then what is the length of SM? This is the length that we are concerned about, the length of SM. To find out the length of SM, and O is the center, if I draw this radius here, the value of radius is given to me. And if I get to know these sides of the small square which is being formed by MNOP, that is how I'll be able to crack this question. First of all, PA is to PB or CN is to ND, all of them are basically one single line, which is the diameter. The diameter is equal to 10. That means PA, that means AB is 10. AB is split into two portions with the help of PA is to PB. This is equal to 5. So it means 2 times, the thing is going on 2 times. So PA is equal to 6 centimeters and PB is equal to 4 centimeters. PB is equal to 4 centimeters. PA is equal to 6 centimeters. But in reality, if this is the center, that means OP is equal to 5 centimeters. If this is 5, this is 4, the entire thing is 10. That means OP is equal to 10. Sorry, OP is equal to 1. OP is equal to 1 centimeter. Similarly, if this OP is 1, then I can say, now let me check for the vertical thing. The vertical thing says CN is to ND is again 2 is to 3. That means this is 4 is to 6. 4 and 6. If this is 4 and this entire story is 6, the thing at the bottom is 5. The thing we are left behind with is 1. If this is 1, the opposite side becomes 1, this side becomes 1. Now it is clear from this triangle. Triangle ONS. I'll be applying the Pythagoras theorem here. OS square is equal to ON square plus NS square. ON square plus NS square. So once we are at that position where OS square is equal to ON square plus NS square, do I know the value of ON? The answer is yes, it is 1 square. Do I know the value of ns? No, we don't know the value of ns yet, because ns is equal to nm plus sm. Sm is something which we need to find out, so it's going to be 1 plus x. I am assuming that sm is equal to x for a while. Okay, this whole thing, whole square. What is the value of os square? Os square is nothing but the radius. The radius is 5, so it becomes 25. 25 minus 1 becomes 24, being equal to 1 plus x whole square. So if I take an under root on the other side, it is 6 4 or 2 root 6 is equal to 1 plus x. So the value of x is going to be 2 root 6 minus 1. The value of x is going to be 2 root 6 minus 1. And this is the answer that I'm looking for. Got it? Let's move ahead. Now, we'll be talking about regular polygons, about their angles, their diagonals, their sides. Sum of all the interior angles. I've already taught this in mensuration 2D. You can see that, or you can work here as well. Sum of all the interior angles is n minus 1 into 180. Sum of each interior angle is n minus 2 by n into 180. Each exterior angle is 360 by n. We will be using this formula extensively. Okay, this is a shortcut to reach the number of sides. This is a shortcut to reach the point where it asks you what polygon are we dealing with. So it's extensive in nature. Okay, it's very, very extensive in nature. Talking about number of diagonals is n into n minus 3 whole by 2. N into n minus 3 whole by 2. This is the side. Talking about the perimeter is n into, like, the number of sides into length of one side. Okay, so the only ones which we'll be using are these 4 formulas, and the one we'll be extensively using is the each exterior angle formula. Okay, also, if let's say that we have an angle here and this is part of a polygon, so this would become the internal angle, and this on the outside would become an external angle. Okay, internal angle and external angle. One thing which is very important is that internal angle plus external angle both lie on a common line, which gives them 180 degrees as the common, 180 degrees as their sum. Okay, we'll be using this as well a lot. Moving forward, A1 and A2 are two regular polygons. The sum of all interior angles of A1 is 1080. 1080 is sum of all the interior angles. Let me quickly pick up the formula. So this is equal to n minus 2 into 180. The 0 is gone with 0. This is 18 ones, this is 18 sixes. So the value of n comes out as 8. So the number of sides that is in the first polygon A1, that n comes out to be 8. Each interior angle of A2 exceeds its exterior angle by 32. Each interior angle of A2 exceeds its exterior angle. Let's assume that this is the polygon we are talking about. This is the interior angle and this is the exterior angle. Interior angle exceeds the exterior angle plus 32. The interior angle plus the exterior angle is 180 degrees. We talked about it. If I use this, twice of exterior angle plus 32 degrees is equal to 180 degrees. This comes out as 148 degrees. That is twice of exterior angle. So the value of exterior angle comes out to be 74 degrees. Okay, the value of the exterior angle comes out to be 74 degrees. Now, if I have the exterior angle as 74 degrees, I can say, is there something which we are missing out on? It's not 32, it's 132. It's 132. When 132 goes to the other side, the 100 is gone, the 32 would make a 48. This is not 148. This is simply 24 degrees. How did I catch the mistake? The reason I caught the mistake was that the exterior angle should have been divisible, or the exterior angle value should have divided should have divided 360 very easily. So this is 24 degrees. So if I need to find out here from here each exterior angle, if I need to find out each exterior angle, what do I have to do? I have to do 360 upon 24 degrees. This would give me the total number of sides. See, I'll tell you what. Each exterior angle, 24 degrees is the answer. So 24 degrees is equal to 360 degrees over n. So the value of n is 360 over 24. 12 2s are 24. 12 3s are 36. So the value of n comes out to be 15. What is this n? This is A2, the number of sides of polygon A2. We have A1, we have A2. So 15 plus 8 is 23, and this is the answer that we are dealing with. Okay, good enough. Let's move on. The sum of all interior angles of a polygon is 1080. What is the number of sides? We have already done the question in the last slide. 1080 is equal to n minus 2 whole into 180 degrees. The 0 and the 0 is gone. 18 ones are 18 six are. The value of n comes out to be 8. Okay, and this is what we were aiming for. Moving forward, talking about regular hexagons and their areas. See, I'll first draw a regular hexagon. This is a regular hexagon. This is the center point. If you make the center touch all the vertices, you would very beautifully see 6 equilateral triangles. And we know that root 3 by 4 s square or root 3 by 4 a square is the area of an equilateral triangle. Yes. So if you multiply this thing with 6, you would get the area of a regular hexagon. Got it? Let's move on. ACE to AEF. Let's first draw it, okay? Let's first draw it. This is a regular hexagon. It might be seeming a little irregular. We have A, B, C, D, E, F. We're talking about ACE, ACE. I'll just quickly if you see very closely, this is taking away half of the entire area. This is almost taking away half of the entire area. What about AEF? Talking about AEF. AEF. This is taking away 1/3 of the area. So I think 3:1 should be the answer. But let me figure out a way to explain the same. So yeah, what we are able to see from here is that the number of triangles being involved, all of them are getting cut into half. So when I talk about triangle ACE, you can see that the first one, the second one, the third one, fourth one, fifth one, and sixth one, all the triangles, all the 6 triangles or the 6 equilateral triangles are being cut in half. So essentially we are getting the area of 3 triangles with us. When we talk about ACE, talking about triangle AEF, talking about triangle AEF. In triangle AEF, there are 2 triangles which are being cut off in 2 portions, which is half. So I'll get the area of one triangle. So we need to find out the ratio of ACE whole upon AEF. The area would be 3 triangles over 1 triangle. The answer would come out to be 3:1. All right, let's move on. A regular hexagon is inscribed in a circle. Okay. What is the ratio of the area of the circle to that of its portion not covered by the hexagon? This is an extremely interesting question. Let's draw a circle quickly. This is a circle. A regular hexagon is inscribed in a circle, inside a circle. Okay. So I'll use a different pen to draw a hexagon. Right. So this is the center point. This is the side of the triangle which we are going to draw, the first equilateral triangle. Subsequently, we'll be drawing all the 6 equilateral triangles. We can declare that the radius of the circle is equal to the side of the equilateral triangle that we are dealing with. Okay. So this is the one that we are dealing with. What is the ratio of the area of the circle to that of its portion not covered by the hexagon? When I talk about the area of a circle is nothing but pi r square. I need to have a ratio between this pi r square is to the area of the circle to that of its portion which is not covered by the hexagon. From the area of the circle, pi r square, I will have to remove the area of the hexagon, which is root 3 by 4 r square into 6. That is the portion which is left behind. Now, this is the tricky part that I need to take care of. I'll take r square common from here. I would be left with pi minus 3 by 2 pi minus 3 root 3 by 2. Pi minus 3 root 3 by 2 is to pi r square. R square and r square would get cancelled away, right? This would come out as 2 pi whole upon 2 pi minus 3 root 3. Do we have this somewhere? Yes, we have it here in the first example or in the first option itself. What did I actually do? The only thing which I discovered was that the radius is equal to the side of the hexagon. Once that was declared and once that was found out, we moved to a point where that area, the area of the circle, from that we had to remove the area of the hexagon. We did that and everything else came along and everything else was only mathematical based. The concept situation ended here. Okay, the concept situation ended here. Moving forward. Okay, so there's a general formula of finding out the area of regular polygons, which is n by 4. N means the number of sides it has. S means the length of side. Okay, this is n means the number, S means the length of side, cot 180 by n. So we have different figures, and all of them, there is one very strong point over here, that the polygons should be regular in nature. Okay, they should be equilateral. When I say equilateral triangle, it means a triangle which has all the sides equal. So similarly, regular polygons would have all the sides of equal length. Got it? So we can use this formula for any upcoming questions. Now, in this figure, PQRS is a quadrilateral where QR is 18 and PS is 9. Find the area of P, Q, R and S. Okay. This question has appeared once in the exam and it left everybody in a very bad situation because nobody knew how to actually solve it. Nobody knew actually how to solve it because in this situation you had to do an extended drawing. The extended drawing is such that 150 degrees, 60 degrees, and 60 degrees. This is a polygon of four sides, right? This is a polygon of four sides. This, which means that all the internal angles are going to be 360 degrees. The sum would be 360 degrees. So 60 plus 60, 120. This is 270, and a 90 degree is pending here. When I try to extend it, this is not the way to extend it. I'll extend it in a more fashionable way. If I try to extend it like this, I get a triangle. This is 150, this is 30. When this is 30, this is also 90. When this is 90, and this is going to be 60. So now I have converted this very difficult looking figure into a triangle, with which is an equilateral triangle. Right, into a triangle which is an equilateral triangle. Now what else can be done? Let me see. The equilateral triangle is of side 18. So first of all, if I need to find out the area of this weird figure, let's call it F. If I need to find out the area of F, I need to first find out the area of the entire entire triangle, and then subtract the small triangle out of it. I'll try to do that as well. Just give me a moment. First of all, let me try to find out the area of the big triangle. The big triangle has a side of 18. So root 3 by 4 into 18 square. This is the area that we're talking about. This would come out as 81 root 3. 2 would create 9 and 9 twice. So this is 81 root 3, which is the area of the full triangle. Now talking about the smaller triangle which got created here. The smaller triangle is of this shape. It's a right angle triangle with a 90 degree. I'm talking about the new triangle which I created. It's a 90 degree thing with 90, with 9 centimeters as its height. With 9 centimeters as its height. And then talking about 30 degree here, talking about 60 degree here. So cot is 9. I'll talk about tan. 9 over x. 9 over x is tan 60. Tan 60 stands for root 3. When I talk about root 3, this becomes 9 over root 3, which ultimately is 9 by 3 root 3. This converts itself into 3 root 3. Okay, this converts itself into 3 root 3. Got it? So I have this side available. Now applying half into base into height, which will find out the area of this triangle. Half into 9 into 3 root 3. This would give me 9. This is 27 upon 2 root 3 minus 81 root 3. This is the bigger triangle. This is the smaller triangle. 27 by 2 root 3 is the smaller triangle. 81 root 3 minus 27 by 2 root 3 is the answer that I'm looking at. This is 2 ones are 2. This is 162. And I have a 27 here. I would get a 5 here. And a 15 minus 2. 15 minus 2 is 13. So 135 by 2 root 3. This is the final answer. Okay, this is the area of P, Q, R, and S. Okay, 135 root 3 by 2. The only difficult part, the only and only difficult part we could find here was the creation of this extra triangle. The creation of this extra triangle. This was the most difficult part. And this was a very, very good question which came in the exam. Right? Let's move forward. In the given figure, ABCDEF is a regular hexagon of side 12. ABCDEF is a regular hexagon of side 12. PQ and R are the midpoints of the sides AB, CD, and EF respectively. What is the area of PQ and R? Let me first find out the area of the hexagon. Root 3 by 4 into 12 into 12. Okay, root 3 by 4 a square multiplied by 6. Okay, so this would give me 4 3s are 12 and 12 6 is 72, 72 3s are is what? 12 6 is 72, 72 3s are is 216. So 216 root 3 is the area of the entire hexagon. Now let me draw a center to it and let me make my complete triangles here. Right. As now I can see that each and every triangle would have a Thales theorem inside it. It would have a Thales theorem inside it. And how would that apply? If I use a division tactic, and the division tactic is such that these are 4 small equilateral triangles. Similarly here, this is one equilateral triangle. This is one equilateral triangle. If I draw this, they would become 4. These are again 4 equilateral triangles. These are again 2 of them. Again 2 and 4, right? And if I draw this, so I hope you're able to see the dotted drawings which I have created. What is the area of triangle PQR is what has been asked from me. One thing is certain, that the area of triangle PQR is half of the area, or shall be distributed into number of triangles. Let's say these green lines are the big triangles, and if I find out the answer for one, no, we won't be able to do that. Let us count the number of triangles that we have over here. Okay, I'll do that with a different colored pen. This is the simplest way of taking things forward. Okay, I'll count the number of triangles starting from here. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23, and there is definitely a triangle which is being missed, and 23, and this is 24. So there are 24 triangles here. This means each and every small triangle that I'm talking about is 216 root 3 upon 24. This is the area of one triangle. Now I just need to count the triangles which are shaded in P, Q, and R. That would come by counting 1 2 3 4, yeah, 5 6 7 8 9. So there are 9 triangles, 9 small triangles which need to be found out. You can always take a pen and paper and draw things, break them down into the easiest possible ways, and you will be able to achieve a point here. 8 ones are 8, 8 twos are 16, 8 sevens are 56. This becomes 81 root 3. Okay, so this is the answer, and this is the area of the triangle PQR. Right, let's move forward. Now talking about circles, right? Talking about circles. Circle is nothing but a locus of points when a line segment is rotated about itself. Okay, so the boundary is called the circumference. We know the circumference, we know the area, we know the area of the semicircle, we know the perimeter of the semicircle. These things are not to be done. These things are not to be, like, they can be memorized, but I believe the ones who are studying with me, if they don't know it, no problem at all, please read them thoroughly. Okay, moving forward. Simple. The sum of the radii of two circles is 91, and the difference between their areas is 2002 meters square. What is the radius of the larger circle? I'll do r plus r is 91. The difference between their areas, pi, taking pi as common, 22 over 7 multiplied by capital R square minus small r square. This is equal to 2002. This is 11 2s are 22. This is 11 1s are 11. I get 90. I get 11 8s are 88 and 2. Then 2 would get 2 9s are 18. 2 1s are 2. So I get capital R square minus small r square as 91 into 7. Then talking about capital R plus small r. Capital R plus small r. No, there is a better way of doing it. Just wait. The better way of doing it is splitting it into r square minus r square as r plus r, capital R plus small r, and capital R minus small r. This is 91 into 7. We know that capital R plus small r is 91. So both of them would get cancelled off, and I would be left with capital R minus small r being equal to 7, using the bigger one as capital R plus small r as 91. When I add both these equations, I get 2 times of capital R being equal to 98, or capital R being directly as 49. Okay, so this is the radius of the larger circle in question. Good enough? Let's go ahead. Two circles with diameters. Yeah. Two circles with diameters 50 centimeters and 58 centimeters intersect each other at points A and B such that the length of the common chord is 40 centimeters. Find the distance between the centers of these two circles. One is 50 and the other is 58. Find the distance between the centers of these two circles. Okay, let me draw it first. This is the big one. This is 58. 58 over 2 is 29. So this is 29. Let me clean it up a little. Yeah. So this is 29. What do we have here? We have here as 25. We have here 25. The length of the common chord. This is the common chord in question. The length of the common chord is 40. Now I need to find out the distance. If I draw a perpendicular, a straight line, this becomes 20. When this becomes 20, I'll change the pen color. I have 20 and 25. So 5, 4 and 3. This would naturally become 15. I'm quickly using the Pythagoras theorem here. So this would naturally become 15, 20. This is 5, 4 and 3. So in a triangle where you have the ratio of 5, 4 is to 3, you need to find out the common point. The common point in all the three would be 5. So you multiply 3 with 5, which gives you 15. So this distance is definitely 15. Talking further, that we have a 20 available with us and we have a 29 here. So 29 square is nothing but 481 and 2 9s are 18, 18 2s are 36. 841. So 841 is the square of 29 and the square of 20 is 400. The gap between the two is 441, which once taken under root would give me 21. So this is 21. So my answer is 21 plus 15, which is 36. Okay. So my answer is 21 plus 15, which is 36. I know this question was done in a lot of haste, but this was done in sort of a exam-like situation. We did nothing. We just drew a common point. We just drew a common line, which was touching both the radiuses or connecting both the centers. Once both the centers were connected, the common chord automatically got bisected. The bisection created a 20 and a 20 pair. It got cut into two portions. Once those two portions were available to me, I simply applied the Pythagoras theorem. And luckily, I could find the Pythagorean triplets as well of 3, 4, 5, and 29, 20, and 21. Okay, so this is how it usually works. Now, talking about, so we are now moving towards the arc length and the sector areas of circles. So what happens is, this is the center of the circle. I'll use the darker pen. This is the center of the circle. When we get two radii to completely touch the circumference of the circle, there is a portion of the circle, or there is a portion of the circumference which is lesser in length, and there is a portion of the circumference which is longer in length or more in length. So the smaller arc, this is basically called the arc of the circle. So the smaller arc is called the minor sector or the minor arc, and the bigger arc is basically called the major arc. But when we talk about the area under consideration, this entire area under consideration, at that time it is called a sector. Okay, that time it is called a sector. But when you produce a horizontal line, or you make a triangle along with the two radii, and the portion which is left below, or the smaller portion that is left into consideration, is basically the minor segment, and the portion which is left above is the major segment. To find out the area of the minor segment or that of the major segment, you need to keep into consideration that after finding out the area of the minor sector, you have to remove the area of the triangle which was found by the two radii and one chord. Okay, you have to remove the area of the triangle which was formed by the two radii and one chord. Got it? Let's move forward. We'll be now talking about the basic formulas. The length of the arc is theta upon 360 into 2 pi r. Theta is the angle which the arc is making with the center. Similarly, the area of the sector is theta upon 360 into pi r square. The only thing that you need to remember is theta upon 360. This basically creates the portion of the circle which needs to be understood. Okay, then there are different segment areas. I will not introduce segment areas right away. We will come to segment areas in the upcoming questions. Okay, what is the length of the arc of a circle whose radius is 35 centimeters and arc subtends an angle of 36 degrees at the center? 36 degrees is equal to theta. The formula is theta over 360 into 2 pi r. Theta is 36. 360 goes there. 2 into 22 over 7 into r, which is 35. This is 10. This is 7, 5. This is 5 to 0. So the length of the arc that we are looking for is 22 centimeters. Okay, the length of the arc that we are looking for is 22 centimeters. Moving ahead, the radius of a circle is 18 centimeters. The angle made by a chord AB at the center of the circle is this. What is the length of this chord? See the beauty of this circle. We have a circle here. Just wait a second. Let me draw a better circle first. Okay, we have a circle here. In this circle, I've found the center. The radius is 18. This is 18. This is also 18. Angle made by the chord AB. This is AB. This is the chord. This is the angle made at the center is 60 degrees. In this particular triangle, this is an isosceles triangle, and in an isosceles triangle, the two sides are equal. This means the opposite angles would be equal. Using angle sum property, I can say that the total angles inside here, inside this triangle of AOB is 180. Out of 180, I know 60 already. 120 are left and they both are also equal. This means both the angles are 60 degree each. When I have all the 60-degree angles in a triangle, it means it is an equilateral triangle. That gives me the length of the chord. The length of the chord is going to be equal to the radius, which is 18 centimeters. Right? Let's move forward. Now talking about a few chord properties. After solving a few chord-based and sector-based problems, not probably like chord-based problems, but yes, sector-based and segment-based problems, I think we are now at the point where we can talk about chords and their relationship with the line which comes from the center, be it the radius or be it the bisector of the chord. So what happens is, as soon as we create a chord which is AB here, in this case the chord is AB, and as soon as we have the chord, then a line from the center, whenever it would hit the chord in a perpendicular manner, whenever it would hit the chord in a perpendicular manner, it would bisect the chord and also make an 90-degree angle. So AC is equal to BC or AC is equal to CB. Okay? And this forms a right angle triangle, and this allows us to use Pythagoras theorem. So every time you have to find out the length of the chord, then half of the length of the chord is available to you, and you have the radius and you have the distance from the center till the chord. So this relationship starts to build up, and this is what really helps you when we have concentric circles and one chord of the larger circle becomes a tangent of the smaller circle. At that moment, the chord length is equal to 2 root capital R square minus small r square. Capital R is the radius of the bigger circle and small r is the radius of the smaller circle. All right, moving forward, we'll do the question straight away. In a circle, a 10 centimeter long chord is at a distance of 12 centimeters from the center. That means this small chord, which is 10 centimeters long, it is 12 centimeters away from the center. The center is O, the chord is AB, and the place at which it meets the chord is M. What is the length of the diameter? If this is the center, then here comes the radius into play. What do I need to find? I need to find out the length of the diameter. That means 2 times of R will do my work very well. 2 times of R will do my work very well. So I have R in the equation, and as I've told you that the line starting from the center till the chord bisects the chord. The chord's full length was 10. This half length would be 5. So according to the triplets law that we have 13, 12 and 5. This becomes our triplet. So this gives me the radius as 13 and the diameter as 13 into 2, which is 26 centimeters. Okay, so 26 centimeters is my answer. Moving forward, a chord MN is 40 centimeters long and lies 15 centimeters away from the center. Okay, a chord is 40 centimeters long and it lies 15 centimeters away from the center. This longer chord and 15 centimeters away from the center. This is O, this is M, this is A, this is B, and chord MN. Okay, I think we need to do a name change or nomenclature change, MN, and let's call this point A, OA, and it is 15 centimeters away. So this portion which is left behind is 20, because it's 20, 20, 20 on both sides. This is basically the perpendicular bisector. What is the radius of the circle? Here we would apply the Pythagoras theorem and find out OB. OB square is equal to OA square plus AN square. OA square plus AN square. OA square is 15 square. We have 3, 4 and 5 into the equation. We have 3 and 4 here. A product of 5 is pending and that product is going to be 25 centimeters. Okay. The ones who have been with me, they know that there is a triplet of 25, 20, and 15, as there is a triplet of 5, 4, and 3. Anything you can multiply with this triplet and create your own triplet. Let's assume we multiplied 7 with it. So it's going to be a 35, a 28, and 21. This could become a triplet, but the source triplet shall remain the same, 3, 4, 5 or 5, 4, 3, whatever suits you well. Moving forward, now in a circle, the perpendicular drawn from the center to a chord bisects it. Okay, C1 has also gotten bisected. Okay, C1 has also gotten bisected, and C2 has also gotten bisected. Okay, when two chords lie either on the opposite sides, no matter where they lie, no matter where they lie on different directions or they lie on the same side, they would definitely get bisected. And ultimately we'll be using the Pythagoras theorem, because every time we draw a line from the center to the chord, it gives a 90-degree, and this gives us a lot of room to play with the radius, to play with the distance, to play with half of the length of the chord as well. Okay, so this is not really, like, you need not know it right now. We will be drawing images, and from that you can derive them. It's better to derive a few results than to learn all the formulas available. Okay, it's better to derive a few results than to focus on all the formulas. Moving forward, PQ and RS are two parallel chords of a circle whose radius is 10. PQ and RS lie on opposite sides of the center. This is the center. This is one side. PQ is 12 and RS is 16. So RS would be closer to the center. The chord that is longer, that is going to be closer to the center. If I have PQ here and I have RS here, PQ is 12, RS is 16. The radius that I'm talking about is 10. Okay, the radius that I'm talking about is 10. Now I need to find out the distance between the chords. We have to do nothing here. Okay, it's very simple, because you just have to apply the 290-degree angles. We have this half side to be 6. If this half side is 6, this full side or this other height would become 8. This half side is 8. This side is 10. So this means this side would become 6. So 8 plus 6 is 14, and 14 is my answer, which is the distance between the two chords. Okay, we just had two right angle triangles and we took outputs from it. Simple. Moving forward, two chords lie on the same side. This is center O. This is where one lies. One is 5 and the other is 11. 11 one would be closer. Okay, so CD, and then we have AB. AB is at 5, CD is at 11, and they are 3 centimeters apart. They are 3 centimeters apart. Find the diameter of the circle. So first of all, I would call this as x, which is the distance, and from there I have my radius. Okay, I have my radius. Similarly, from here I have my radius. This is 5. This means this is 5 over 2. This is 11. This means it is 11 over 2. Okay, 11 over 2. Now I need to find out the diameter of the circle, or simply r. For that, I think it will be better if we could find out the value of x first, and then we could move to r. Okay, the value of x first and then we could move to r. Talking about the smaller triangle over here. Okay, when I say small triangle, I'm talking about the one which is here. When I talk about the large triangle, I'll be talking about the one which is here. So r square is equal to 121 by 4 plus x square. The other one is r square being equal to 25 by 4 plus x plus 3, x plus 3 whole square. So you could remove the r, or you could replace the value of r from both sides. So I would have 121 by 4, 121 by 4 minus 25 by 4 being equal to x square plus 9 plus 6x minus x square. Okay, so the x square and the x square would get cancelled. I would have 9 should also go to the other side. Let me first deal with this. If 21 is gone and 21, there would be a 4 less, 95. I'll have 96 upon 4. That is what I'll get. 96 upon 4. 96 upon 4 is 4 2s are 8, 4 4s are 16. It's 24 minus 9 being equal to 6x. 24 minus 9 would create 15. Yeah, 15 upon 6. This is the value of x that I would get. Once I have the value of x available with me, which is 15 over 6, let me cancel it out. 3 and 5. So this is 5 by 2. I would take it back to the first equation where I need to find out the radius. The radius square is 121 over 4 plus 5 by 2. 5 by 2 converted would be 25 by 4. Now this would become 146 upon 4, right? It would become 146 upon 4. This is 2 2s are 2 and 2 7s are 14. This is 73 by 2. 73 by 2. So the value would be r being equal to root 73 by 2 multiplied by 2 would give me the diameter. It would give me the diameter. Okay, might be looking very, very tricky, but trust me, it's doable. Okay, moving forward, the distance between two parallel chords is 6. Okay, between two parallel chords of length 6 centimeters each in a circle of diameter 10. This is 6, this is another 6. Now talking about here, the diameter is 10, that means the radius is 5. This is 6 in length. This is 6 in length. The 6 would get split in into two parts, which is 3 and 3. So I have a triangle with 3, 5 and x. So this x would automatically become 4 because we just learned about the triplets. If it is 4 on the upside, there is definitely 4 on the downside as well. So the diameter, I need to find the distance between the two parallel chords. So it's going to be 4 plus 4, which is going to be 8, right? Moving forward, AB is equal to this, and they are parallel chords on the same side of the center. Parallel chords on the same side of the center. This is AB. This is AB. And this is CD. This is AB. This is CD. Right? Same side of the center. And if the distance between them is 2 centimeters, distance between them is 2 centimeters, one of them is 4, like half portion is 4, and the other has a half portion of 3. Okay, then the radius of the circle, this is something which we need to find out. Okay, the radius are going to be the same. We have two triangles. I'm talking about the smaller triangle right now. I'm talking about the smaller triangle right now. So talking about the smaller triangle, r square is equal to 16 plus x square. Similarly, in the other one, r square would be equal to 9 plus 9 plus x plus 2 whole square, right? I need to find out the radius. I'll equate r together. From that, I'll get 16 plus x square is equal to 9 plus x plus 2 whole square. I'll quickly open x plus 2 whole square as x square plus 4 plus 4x plus 9. This is equal to x square plus 16. The x square and the x square would get cancelled out. 9 plus 4 is 13. 13, when it goes to the other side, it becomes 3. 3 by 4 is the value of x. Once I put that back, I get 16 plus 9 by 16. And if I give it a root, that would be the value of the radius we are talking about. 256 plus 9, 256 plus 9 is 265. So 265 by 16 in a full under root would give me 265 by 4. Root 265 by 4 is the value of the radius that I am looking for. Right? Moving on. Now, there can be situations in which the common chord is there when the circles are intersecting not at one point but at 2 points. That is the situation when common chords occur. When two circles intersect, they do so at exactly 2 points. The line joining these 2 points is basically called the common chord. The line joining the center of the two circles is perpendicular bisector to the common chord. This stays the same. Okay, the common chord also gets bisected in a perpendicular fashion. If the radii are different, using Pythagoras theorem, we need to separate both the triangles, and that is how we work it about. Okay, moving forward, when radii are equal, I don't think we really should be doing this. Let us remember this thing only. That the length or the distance between the centers is equal to, in the root, 4 times small r square, which is the radii, the equal radii, minus OP square. OP is the common chord, the length of the common chord. Okay, this is something I think which we should remember. It's okay, we can remember this, right? Okay, moving forward. Now, two circles intersect at P and Q. So this is P and the other side is Q. Their diameters are 30 and 26. 30 and 26. So let's call this 30. 30 by 2 is 15. And let's call this 13 because 26 over 2 is 13. If the length of the common chord PQ is 24, this is the common chord in question. The length is 24. I need to find out the distance between the centers. See, this is a common chord, so it's definitely going to get cut at, like going to get bisected at 12, and there is a 90-degree angle which comes into play. Once that comes into play, 3 4s are 12, 3 5s are 16, 3 3s are 9. 9 is this distance that we are talking about. It's very important for you to learn Pythagorean triplets, else these questions are going to become very difficult for you. This is the length of 9. Further coming to this side, I see 12 and 13. So in that table, 12, 5 and 13. So this length would be equal to 5 centimeters. This length is already has been declared out, which is 9 centimeter. So the distance between the centers is 9 plus 5, which is 14 centimeters. Okay, the distance between the centers is 9 plus 5, which is 14 centimeters. Moving ahead, two equal circles of radius 8 centimeters each intersect in such a manner that they pass through each other's center. Okay, they pass through each other's center. I need to find the length of the common chord. See, the length of the common chord, if we are considering only one triangle, the one which is here above, we can see that this is also 8, this is also 8 and this is also 8. This becomes an equilateral triangle, and this dotted line becomes the height. This dotted line becomes the height. So what does this height represent? This height is nothing but the height of an equilateral triangle. How much is that? Height of the equilateral triangle is nothing but root 3 by 2 times the side, or root 3 by 2a. This means this is root 3 by 2 into 8, or simply 4 root 3. Now this 4 root 3, this 4 root 3 here is this length only. I need to find out the other length as well, so as to complete the common chord. So 4 root 3 when multiplied by 2, because the common chord gets divided, gets bisected by the lines joining the centers. So 4 root 3 multiplied by 2 becomes 8 root 3, and this is the answer that I am looking for. Okay, moving forward. Now, in a radius of 3 centimeters, two chords of length 2 and 3 centimeter lie on the same side of a diameter. Okay, we already have a center here. This is center O. There is a there's a chord whose length is 3 centimeters. Whose length is 3 centimeters, and there's a chord whose length is 2 centimeters. The radius of the circle perhaps has been shown to be 3 centimeters. Okay, so we are automatically forming an equilateral triangle here. Further ahead, here also we are forming a triangle which is isosceles in nature, because I have 3 here and another 3 here. What is the perpendicular distance between the chords? Okay, very interesting question. This is definitely going to take some time. Okay, this is the first perpendicular. This is the first perpendicular, and going further ahead, this is the second perpendicular. Okay, so we just have to find out the value of x that we have over here, right? In the first triangle, I can say that 3 by 2, or let's say the height that we are looking at, the value of height square plus 9 by 4, which is 3 by 2 whole square, is equal to 9. The 9 would go to the other side. It would become 9 3 by 4, or 9 4 is 36. 36 minus 9 is 27. 27 by 4. This would become the value of h square. This h square is this height that we are talking about. Okay, this is h square. So once I have h square with me, now I will go to the bigger side. The bigger size says that 9, which is the square of the radius, is equal to 4 plus, in the bracket, 27 by 4, or simply like 27 by 4. This is the value of h square. This is not h, or root 27 upon 4 plus x whole square. Root 27 upon 4 plus x whole square. This is equal to 9. Okay, this goes to the other side. It becomes 5. 5 is equal to 27 upon 4. There is some point which is missing. H plus x, 9, and 2. This is not 2. This is supposed to be 1. This is not 2 square. It is supposed to be 1 square. Okay, so it's going to be 1. When 1 goes to the other side, it becomes 8. Yeah, now it seems fine. A square plus b square plus 2ab, plus 2 times the 2 would go away. How much would it become? 3 root 3. 3 root 3x, right? what is the distance between the chords? I need to find out the value of x. This is turning out to be really difficult, huh? It's okay, not really difficult, but really beautiful. 4 8 is the 32. 32, this would become 5 by 4. Would go to the other side, and let's call it here. It's minus 5 by 4, so it will become, the quadratic equation will become x square plus 3 root 3x minus 5 by 4. This would also translate to 4x square plus 12 root 3x minus 5. Okay, minus 5. So b square minus 4ac, we can find out the determinant, and then we can find out the value. So I've almost brought you to the last point, and I'm pretty sure that you'll be able to go forward ahead as well. Okay. Now, talking about the angles subtended by chords, if two equal chords are subtending angles at the center of the circle, then both the angles are also going to be same. So the property says that equal chords subtend equal angles at the center. Okay, angle subtended by the diameter is always 90 degrees. Okay, if we have a circle and we are sitting at a diameter and we choose a point and we try to form an angle over here, this angle is always going to be 90 degrees. Okay, good enough. Let's move forward. This is also the same story, nothing much to change here, right? So we'll be talking about a few of the properties of the circle, and these properties are universally true, and most of the things that we are going to learn over here have been asked in the exam maximum number of times. By maximum number of times is that you can see such questions coming in almost in every exam. In every exam, you will find one question, or at least 2 to 3% of the exam always consists of the same questions which we are going to talk about further on. Okay, these are the properties of the circle when a chord is subtended anywhere in the circle. Okay, so when a chord subtends angles both at center and points of the circle, then the angle at the center is twice the angle at any point subtended by the same chord. When I say that, I mean to say that, when I say this, I mean to say that if I have a chord that is called AD, or if I have a chord which is called, yeah, this is AB, this chord is AB, and if angle ACB, C is any point on the circle, and that angle is theta, then at the center, which is AOB, or angle O simply, so that angle is going to be twice of the angle theta which is subtended on the outside. Okay, twice of the angle that is subtended outside. But if the chord has a point on its minor segment, let's say this is point D on the minor segment, and I join these 2 points, then this property comes into play, which says that the opposite angles are supplementary in nature, or the opposite angles are, they sum up to 180 degrees. This property comes from a kind of a quadrilateral which is called a cyclic quadrilateral. Okay, the property of cyclic quadrilateral says that the opposite angles sum up to 180 degrees. So this is when that sort of a property comes into play. Going back, the angle of the center is, at the center, is twice the angle at any point on the circle subtended by the same chord. Got that? Equal chords subtend equal angles at the center and are equidistant from the center. This point is made clear by this, that if AB and PQ are equal chords, then they would subtend equal angles at the center. That means angle AOB would be equal to angle POQ. Angle AOB would be equal to angle POQ, right? So equal chords subtend equal angles at the center and are equidistant from the center. It also means that OL is going to be equal to OM. I've already written that, right? Going back, all angles subtended or all angles in the same segment of the circle are equal. See, this is a chord which is AD. There are 2 points, let's say one is B and the other one is C. The angle subtended by the point B against the chord is angle ABD, and the angle subtended by point C on the chord AD is angle ACD. So both of them are going to be equal because they are lying in the same segment of the circle. Okay, both of the angles would be same because they are lying in the same segment of the circle. So that is something which you need to take care of, right? Now going back, this is also done. Angles in a semicircle by diameter is always 90 degrees. If let's say you have a small circle here and you create a diameter over here, so any point on the circle, when you join it to the other ends of the diameter, let's say this is x, so angle AXB is always going to be equal to 90 degrees for sure. Okay, angle AXB is always going to be 90 degrees. Good enough. If a chord's angle bisector passes through the center, the triangle formed is isosceles. Let me try to create that over here. If a chord's angle bisector, this is a chord, this is a chord that I have created. Now let me have a better circle for this matter. Yep, this circle is definitely better. If a chord's angle bisector passes through the center, this is the chord, this is chord AB, and the chord's angle is somewhere here. If the angle bisector of this chord, this is the angle that has been created, right? So I'll now draw the angle bisector. What does the angle bisector look like? It looks like this. If this angle bisector passes through the center of the chord, if this angle bisector passes through the center, then the triangle formed is isosceles. Okay, um, because of a because of similarities, the triangle would be formed, which the triangle which would be formed would be an isosceles triangle. Okay, should I tell you about the similarities? Yes, I also think so. See, this angle 1 would be equal to angle 2, that is for sure. Then this line, the angle bisector, let's call it XL. This line XL is going to be common to both of the triangles. Then any point, any line which is drawn from the center to the chord bisects the chord. That would also leave that these two lines are equal. So once that situation occurs, you have two triangles which are similar in nature. That means, or you have two triangles which are congruent in nature. That means XA and XB congruent by the property of CP/CT, which is congruent parts of congruent triangles. That would declare that XA is equal to XB, and this is equal to an isosceles triangle. Okay, and this is equal to an isosceles triangle. So this is what we were completely looking for. We've done all the properties of the circle, lines inside it, chords inside it. Okay, now we'll be solving the questions. In a circle with center O, AD is a diameter and AC is a chord. Okay, this is point A. This isn't point A. AD. AD is the diameter and AC is a chord. Point B is on AC such that OB is equal to 7. Now, this line OB would be perpendicular to the chord, right? Because any line from the center to the chord bisects the chord is also perpendicular to the chord. Angle OBA. Angle OBA. No, it is not going towards the center. Let me put it somewhere else and let me not consider them to be at 90 degrees. Let me remove this clause that they are at 90 degrees. Let me put this into consideration that angle OBA is equal to 60 degrees. Now, if angle DOC, this angle is also equal to 60 degrees, DOC, this also is equal to 60 degrees, then what is the length of BC? Okay, it's a very, very interesting question. Just let's try to figure out what can be done over here. If this is 60, yeah. So the first point that I feel is necessary is that we connect CD together. Once that is connected, we can see that OC and OD are the same. OC and OD are the same because they are the radii. If this is 60, the other two angles sum up to 120. That means the other two angles are also going to be 60 degrees each. The other two angles are also going to be 60 degrees each. Got it? So what further needs to be done? Now, if this is 60 and this is the diameter, the entire angle DCA would be equal to 90 degrees, right? 60 degrees is already something we've gotten. So this is going to be 30 degrees. Once this is 30 degrees, the next step is that 60 degree and angle CBO, this angle, they form a linear pair. This is 60, the entire linear pair is of 180 degrees. That means this is going to be 120 degrees because they are angles which are opposite, which are neighbors of each other on the same line. On a straight line, any angle is going to sum up to 180 degrees. So 120 plus 60 is 180 degrees. Now, this angle has been left behind. This is going to be 30 degrees. The only thing that we know of is that OB is 7 and BC needs to be found out. So talking only about this triangle, I'll just redraw the triangle here. We have B here, we have O here, and we have C here. Okay. We have B here, O, B, C. Okay. So this is 30. This is also 30. And this entire situation is 120. Okay. This entire situation is 120. We already have the length of OB as 7. The question is, what is the length of BC? This angle O is 30 degrees. This angle C is also 30 degrees. So when you have equal angles which are opposite to equal sides, which are opposite to sides, then the sides also become equal. So if this is 7, angle side BC would also come out to be 7. So this answers our question that the length of BC is equal to 7 centimeters, right? The length of BC is equal to 7 centimeters. Moving ahead, AB is a chord of a circle with center O. Let's call this AB. P is a point on the circle and angle APB is equal to 122 degrees. What is the value of angle OAB? This is O, this is the center of the circle, and this has been asked to us. We have learned in this property that any angle subtended on a segment, on a point in the segment is going to be half of the angle subtended at the center, or the angle at the center is going to be twice of the angle subtended at any point on the segment. If 122 is equal to theta, angle APB is 122, then this is going to be twice of theta. Is that correct? Twice of theta. In such a situation, when you see that the angle subtended by a point against the chord is 122 degrees, okay, it is an obtuse angle triangle. This means that a small point is being missed, and I'll tell you what that point is. the angle is obtuse in nature. That means it cannot be accommodated on this side of the segment. It cannot be accommodated in the major segment. It has to be accommodated in the minor segment. So this point P would be in the minor segment. Firstly, that's possible, right? Now this looks like an obtuse angle. The angle obtuse, which is 122 degrees, is over here. 122 degrees is over here. Now, following the properties, the first property is that of a cyclic quadrilateral. That, let's call this X. That quadrilateral PAXB is a cyclic quadrilateral. That means angle AXB plus angle APB is equal to 180 degrees, right? So if AXB and APB both together are equal to 180 degrees, then APB using 122 would go on the other side, and it would give me a 58 degree angle. This would give me a 58 degree angle. Angle AXB would be a 58 degree angle, right? Now, angle AXB, second point is angle AXB multiplied by 2 would become angle AOB. This is the property that we've already seen, right? This is the property that we've already seen. So 2 times of 58 is going to be angle AOB, which is 116. So this angle comes out to be 116 degrees. Now in this triangle, in triangle AOB, this is an isosceles triangle. Why? Because these are two radii. That means angle A and angle B of this small triangle would be equal. If one angle is 116, then the other two angle would be 180 minus 116. The other two angles sum would be 180 minus 116, which is going to be 64 degrees. This would be 64 degrees. Now, if both the angles are equal and their sum is 64 degrees, then one of the angle or both the angles would split into two equal angles, which are going to be 32 degrees each. So, angle OAB that has been asked in the question is 32 degrees, and this is the answer that I was looking for. Okay, moving on. AB is the diameter of a circle. C and D lie on either side of AB. Angle CAB is 52 degrees and angle ABD is 47 degrees, right? Find angle CAD and angle CBD. Okay, no problem. There's a small point missing over here. Find angle CAD minus CBD. Okay, CAD minus CBD. We need to find out the difference between CAD and CBD. The first property that I'm going to use here is semicircle angle. The first property that I'm going to use here is semicircle angle. So this is a semicircle. AB is a diameter. It means any point on the semicircle would have a 90 degree. Similarly, when I talk about things under it, that time as well, there would be a 90 degree over here. So using the angle sum property, I can find out this angle and this angle. If this angle is 52, this angle is going to be 38 degrees. Okay, then this entire story would be 180 degrees. Similarly, this entire story is also going to be 180 degrees. 180 and 180. So this is 47, this is 38. If this is 47, then this would become 32 or 33. Let me see. This would become 3 and then 40. Yeah. So this is 43 and 47. Right? 5 would go there. Yeah. 43 and 47. right? So now I have the measurement of complete angle CAD and complete measurement of angle CBD. So angle CAD minus angle CBD is something which I am looking for. So CAD is 52 plus 43, which is 95 degrees, minus CBD. This is 85 degrees. So 95 degrees minus 85 degrees is 10 degrees. And this is the final answer. Okay, let's move on. Now, in a circle, AB and CD are chords intersecting at P. This is AB and this is CD. They're intersecting at P. There is a possibility that when we start putting in the numbers, at that time you find faults with it. Like here, AB is equal to 15 and PB is equal to 9. If PB is 9, that means that AB or AP is equal to 6, right? But this half is a bigger half. Okay, this half is a bigger half. So I will have to change the nomenclature. Yeah. So I would call this A. PB is equal to 9. So PB comes out as 9 here and AP comes out as 6 here. So AP and PB. Similarly, PC. PC is very short, it is 3, and PD is a little long. So I'll call this CP and I'll call this as D. Okay. So the value of CP here is 3 and the value of PD is X, which we need to find out. Okay, which the value of X is PD, which we need to find out. This property would be taught in the upcoming 4-5 slides, but I'll teach you the property here itself. Whenever two chords are intersecting at a common point, whenever two chords are intersecting at a common point, at that time, what you have to do is there is a property which comes into play, that AP into PB is equal to CP into PD. AP into PB is equal to CP into PD, right? So what you will have to do here is AP is 6, PB is 9, CP is 3, and PD is X. So from here, 3 ones are 3, 3 2s are 6, 9 2s are 18. So the value of X comes out as 18 centimeters. Okay, moving forward. Okay, a chord of a circle is equal to the radius. This is radius 1, this is radius, and this is also radius. It's equal to the radius. The angle subtended by this chord at any point on the minor arc. Okay, so this is 60. We are talking about an equilateral triangle here because all the sides are equal. If all the sides are equal, then all the angles would also be equal. And using angle sum property, let's call this AB here and call this O here. Using angle sum property, all the angles are equal to 180. So 3 angles, 180 divided by 3 is 60. So each angle is 60. Now the angle subtended by this chord at any point on the minor arc. This is the major arc and this is the minor arc. It's saying any point, let's assume this is a point X on the minor arc, and you need to tell what is going to be the measure of this angle here. Angle AXB needs to be found out. For that, what I'll do, I will assume a point on the major arc and call it M. Okay, I'll call that point M. So AMB, I'm talking about AMB. Angle AMB is going to be half of angle AOB. It's going to be half of angle AOB. Angle AOB is 60, so 60 upon 2 is 30. That means angle AMB is equal to 30 degrees in nature. We've got the measurement 30 degrees. Further on, talking about angle AXB, angle AXB plus angle AMB together would form 180 degrees. Why? Because they form a cyclic quadrilateral. So AXB is equal to 180 degrees minus angle AMB, which is 30 degrees. So this would come out as 150 degrees. So 150 degrees is my answer. Okay, got that? Moving forward. Now, I have already taught you about the intersecting chords problem here, and I'll revisit the same concept over here as well. If two chords AB and CD intersect at point E inside the circle, this is P, this is given P over here, so you may change anything, okay? You may change it to E. So AE is to EB is equal to CE into ED, okay? So these multiplication signs are something which you must remember. Further, if there is an external intersection, let's call it at point P. At that point, PA into PB is equal to PC into PD. PC into PD. One very important property what I would like to teach you over here is that PD is a secant. PD is a secant. A point lying outside the circle, which when touches the circle at the first point and touches the circle at the second point, when it is creating a chord inside the circle and it is a point on the outside of the circle, that is called a secant. Okay. Also, there is no direct formula of determining the length of DC. There is no direct formula of determining the length of DC. So for that very purpose, what you have to do is you must know the length of PC and you must know the length of PD. That is the only way to find out the length of DC. Here in the external chord formula, PA into PB is equal to PC into PD. Then there is an option of there being a chord and there being a chord. I'll teach you here itself. Then there is a problem that there is a chord here and then there is a line joining from the center. Let's call it X. Let's call it O, and this is A, this is B. The value of X square is going to be BA into BO. This is another property which you must remember. The same property would come up next, so I'll tell you about it over there. Now, chords AB and CD intersect at E. AE is equal to 12. AE is equal to 12. BE is equal to 20.25. So 20.25 is here. 12 is here. This is AE is to BE. AE is to BE. Also, CE is 3 times of DE. So this is bigger. CE is 3 times of DE. If I call this X, if I call this DE as X, this would automatically become 3X. Now we need to find the value of 3 times of X. I need to find out the value of 3 times of X. What would happen now? What would happen now? Now we would be thinking about 3x multiplied by x is equal to 12 into 20.25. This is the same property which we picked up from here. This is the same property which we picked up from here. So it becomes 3x square being equal to 12 into 2025 upon 100. 25 8 is 200 and 25 1 is 25. 25 4 this is 4, this is 3. The 3 gets cancelled with 3. I get the value of x square as 81. So the value of x comes out as 9. In the question, they've asked me the value of 3 times x, which is going to be equal to 27. Okay, 27 is the value that I was looking for. Moving forward, the diameter of a circle PQ is perpendicular to the chord RS. This is PQ. I'm perpendicular to the chord RS. If RS is equal to 16 and T is the point where they meet, okay, if RS is equal to 16 and T is the point where they meet, so QT is equal to 4. QT is equal to 4, and the question is, what is the diameter of the circle? So firstly, this is a diameter of a circle, and this is RS is a chord. Any line from the center to the chord will bisect the chord. Okay, any perpendicular line, it has already been declared that this is perpendicular. That means it is bisecting the chord. That means RT is 8 and TS is also 8. If I consider PT, entire PT, to be equal to x, I can say that 8 into 8 is equal to x into 4, right? This becomes 4 to the 8, and I get the value of x as 16 units. I call the value of x as equal to 16 units. So once that value is 16 units, what do I have to do? If the value of x is equal to 16 units, then I can say that the entire length of PQ, which is the diameter, is 16 plus 4, because 4 is the shorter point, QT, right? 4 is the shorter point, so 16 plus 4 is 20 centimeters, right? So this is 20 centimeters, and this is the answer that I was looking for. Moving forward, in the figure, chord XY and PQ intersect externally at point L. The value of PQ is 10 and the value of XY is X, and they intersect at PA, and they intersect such that PA into PB is PC into PD. Okay, they've just talked about this. There is no mention of PA. We will follow as per the figure tells us. Okay, we'll follow as per the figure tells us. The figure says that any external intersections would lead to Ly into Lx being equal to Lq into Lp. Ly into Lx is equal to Lq into Lp. Okay, so I have all the figures over here. Ly is 4, Lx is 4 plus x, Lq is 6, and Lp is 10 plus 6, which is equal to 16. This is 4 1s are 4, this is 4 4s are 16, this is 4 6 are 24. So when I get 24 over here, I get x plus 4 here, and the value of x is equal to 20 centimeters. The value of x comes out to be 20 centimeters, right? Now, there are a few theorems which you must know. There are a few theorems which you must know. The theorems are secant angle theorem. Okay, secant angle theorem. If you get PQ, which is the diameter of the circle, and there is a point T on the outside, and T is forming a secant by touching the circle at R and P and touching the circle at S and Q, then the angle formed at the center of the secant is equal to 90 minus y by 2. 90 minus y by 2, and y by 2 is the angle which is opposite to it, diametrically opposite to it. Okay, then talking about tangent from an external point. From an external point, if we draw a tangent PA and we also draw a tangent PB, then the length of tangent PA is going to be the length of tangent PB. So from any point outside the circle, if we draw a tangent at the circle, if we draw two tangents at the circle, they are going to be equal in length. Talking about secant tangent theorem, when we have a secant CA and we have a tangent CD, then CD square is equal to CB into CA. This secant tangent theorem I showed you over here. Okay, this is a secant tangent problem, which is x square is equal to BA into BO. Okay, uh wait a second, this BO is not here, this BO is actually here, this BO is not here, this BO is actually here. Okay, I've corrected this, BA into BO, right? We were here, CD square is equal to CB into CA. Now alternate segment theorem says that CAB is equal to APB, CAB is equal to APB. We'll come to the question once, and then we'll be able to get it. Okay, tangent chord is equal to opposite segment. These are simpler questions. In a circle, chords PR and QS meet at point T. Chords PR and QS. This is PR. This is QS. They meet at point T, right? They meet at point T. PQ is a diameter. Okay, we should have seen this before. Let me quickly redraw it. This is P, this is Q. The figure seems to be just a little skewed. Yeah. This is point T. And we are sitting at PQ is the diameter. Angle ROS. Angle ROS is equal to 42 degrees. Then what is the measure of angle PTQ? We need to find out what is the measure of angle PTQ. Now, if this is the radius, this is the radius. We need to find out the measure of this angle, angle SOR. If we get the measure of angle SOR, then we'll be easily in a position to find out the measurement of angle PTQ. Okay, the measurement of angle PTQ. By virtue of similarity, angle ROP is 42, and by the same virtue of similarity, angle SOQ would also be equal to 42 degrees. So we have two angles which are equal to 42 degrees in a linear pair. In an entire linear pair, we actually don't have a linear pair, we have a linear triplet over here. So angle SOR plus 42 plus 42 would make 180 degrees. It would make 180 degrees. This 84 would go to the other side and it would create angle SOR. Angle SOR is equal to 180 minus 84, which is equal to 96 degrees. So I have the measurement of angle SOR as 96 degrees. So this 96 degrees, I'll go back to the formula. The formula said that angle X is equal to 90 minus Y by 2. So angle T is equal to 90 minus angle SOR upon 2. So this is 90 minus 96 by 2. 96 is going to be nothing but 48. 48 and 90 minus 48. 40. 42. Yeah. So this would give me the angle 42. Okay. So the value of angle T is also going to be 42. In the alternate segment theorem, which we were talking about, it talked about the same thing. Okay. It talked about the same thing. Alternate segment rule, tangent chord, opposite segment. So this is the same thing which we are talking about here. Moving forward, point A and point B are on a circle with center O. P and PB, this is point A and this is point B. PA and PB are tangent from external point P. This is PA, this is PB. They are from an external point P. If angle APB, if angle APB is 42, then find angle OAB. Find angle OAB. Right? To find out the length of OAB, let me draw this straight line. Let me draw this straight line. So once these two lines are joined, I have to find out the value, the measurement of angle OAB. This is x. If this is x, by virtue of this being an isosceles triangle, because there are two radii over here, so this is also going to be x. And this is what we are going to look out for. Talking about PAOB, we know that angle A and angle B are 90 degrees each because they are tangents. So 90, so any quadrilateral has 180 degree as its angle sum. Okay. So if I say no, any quadrilateral has its angle sum as 360 degrees. So at 360 degrees, I can say that 360 degrees is equal to 42 plus angle O plus angle A plus angle B. 42 plus angle O plus angle A plus angle B. So angle A plus angle B are 180. 90 plus 90. 90 plus 90 would go there. It will create 180 here. So 180 is equal to 42 plus angle O. 42 would go to the other side and it will create a 138 degree. So angle O is 138. So angle AOB is equal to 138 degrees. Talking only about this circle, talking only about this triangle, in triangle AOB, if angle O is 138 degrees, then angle X and angle X would also be there. Using angle sum property, I know that 138 degrees plus 2 times of angle X is equal to 180 degrees. When 138 goes to the other side, it creates 42. Then the value of X would be 42 upon 2. 42 upon 2 is going to be 21 degrees. So the value of angle X is going to be 21 degrees. Right? Let's move forward. Okay. So in a figure, X, Y, Z is a secant, ZT is a tangent. If TZ is equal to 12, YZ is equal to 8, then find the value of XY. So we've already learned this, that the value of 12 square is going to be 8 into X. 12 square is nothing but 144. 144 is equal to 8 into, no, this is not 8 into X. This is going to be 8 into X plus 8. 8 into X plus 8. So this is going to be 8 ones are, 8 ones are, then 8 eights are 64. So the value of X comes out to be 18 minus 8, which is 10. Okay. So 10 is the answer that I was looking for. So we were at this question. The question says that a tangent is drawn to a circle with radius 8 from a point 17 centimeters from the center. This is O. This is, let's call this A, let's call this B. What is the length of the tangent? They need to know what is the length of AB. A tangent always drops a perpendicular against the radius at the point of contact. So the point of contact is B. So it is dropping definitely a 90-degree angle. So using Pythagoras theorem, I can say that 17 square is equal to tangent square plus 8 square. 8 square goes to the other side. 17 plus 8 is 25. 17 minus 8 is 9. So 25 into 9 is 225, and 225 square root is 15. So the value of t, or the length of the tangent, comes out to be 15 centimeters. Good enough? Let's go ahead. Okay, so AB is a chord of the circle and AOC is the diameter. AB is the chord of a circle and AOC is the diameter. If AT is the tangent to the circle at point A, then angle BAT needs to be found out. Okay, so I'll quickly first draw, I'll connect them, and then I would say that this is a 90-degree angle, right? This is a 90-degree angle because it is lying in a semicircle. Further, this also entirely is a 90-degree angle because this angle has been made by a tangent. So this is a 90-degree angle as well. Now this 90-degree and the other 90-degree. Now talking about angle BAT, what can be done is, well, there's a point which I completely missed out, which says that angle ACB 65 degrees. If this is 65 degrees, angle BAC would become 25 degrees, because 65 plus 25 makes 90. So 90 plus 90 makes 180. That completes the interior angle sum. So if this is 25, whatever is left behind is 65 degrees, and that is the answer that I was looking for. So yes, we are at the topic of tangents. So there are common tangents whenever we have more than one circle. When we have two circles, there are multiple common tangents. There are two kinds of tangents. The first one being a direct common tangent, and the second one being a transverse common tangent. In the direct common tangent, what happens is it does not intersect the line joining the centers. This AB over here, this is the line which is joining the centers of the two circles. So direct common tangent does not intersect the line joining the centers. And then comes the point transverse common tangent. Transverse common tangents look something like this. Okay, they look something like this. So they are called transverse common tangents, and they intersect the line which joins the centers. The number and type of tangent depends on the distance and what is the size of the circles. So first one being the direct common tangent. The direct common tangents are two over here, PQ and ST. PQ and ST. The formula for that would be d square, that is the distance between them, d square minus capital R square, which is the radius of the bigger circle, minus small r square, which is the radius of the small circle. So you have to learn this formula. Okay, you have to learn this formula. Moving on, if the circles are touching externally, okay, there is one point of contact where the circles are touching, and we are talking about direct common tangents. So the length of the direct common tangent is going to be 2 root RR, 2 root capital R small r. Okay. Secondly, if the radii are equal, as we can see, this is also R, and this capital R is equal to small r. So in such a case, the direct common tangent length is equal to the distance between the centers. That means PQ is equal to AB. PQ is the DCT, which is a direct common tangent, and AB is the distance. So both the lengths are equal. Talking about transverse common tangents, which is TCT. Okay, transverse common tangent is TCT. So in TCT, it would be crossing the line which is joining them. So the formula would be d square minus capital R plus small r whole square. Okay, minus this minus sign would remain, and this sign would turn into plus. The same formula in direct common tangent, this sign was minus, and here this sign is plus. Okay, let's move forward. Two circles of diameter 2 centimeters and 5.6 centimeters are such that the distance between their centers is this. What is the length of the common tangent to the circles that does not intersect the line joining the centers? When it says does not intersect, it actually means it is a direct common tangent, and the formula we'll be using is d square minus capital R minus small r whole square and a root with that. Okay, two circles of diameters 2 centimeters and 5.6 centimeters. If we have diameters, that means 5.6 upon 2 is 2.8, and 2 upon 2 is 1. The distance we are talking about is 8.2. So I'll be using these terms, using these values and putting it back to the formula. D square means 8.2 square minus capital R minus small r, or 2.8 minus 1, which is 1.8, and this entire thing would go in a root. This would also have a square on it. So I'll be employing the identity a square minus b square, which means a plus b, that is 10, and a minus b, which is 6.4. Taking a root of the situation, 6.4 into 10 is 64, root 64 is 8. So 8 is my answer. Okay, 8 is my answer. Good. Moving on. Two identical circles of radius 10 centimeters each have a DCT of 26. These are two identical circles, and they, first of all, these are two identical circles, but they don't have the same distance. Okay, the distance is not the same. Why? Because whenever we saw the case of identical circles over here, which in which radii are equal, there used to be a bigger distance between the two circles. So right now what I can see here is 10 into 10, sorry, 10 plus 10 is 20, and 26 is greater than 20. That means these are two circles which have a good amount of distance between them, and this total distance is 26. These are the radii, which are 10 each, and now they are asking me what is the length of the transverse common tangent. The formula for transverse common tangent is d square minus r plus r whole square, this whole thing in under root. The d which we think if we don't have, we definitely have the d, because 26 is the length of the tangent, and it is also equal to the length of the distances between them, which is also equal to the distance between the two circles. So d square, this is 26 square, minus capital R square, minus r plus r. R plus r is 10 plus 10, which is 20. So minus 20 square, and there would be a root over here. 26 plus 20 is 46, and 26 minus 20 is 6. This whole thing would go in root. When I'll take 2 outside, I would get 2 root 69 as my answer. Okay, 2 root 69 is going to be my answer. Moving on. If two circles of different radii touch either externally, what is the maximum number of common tangents that can be drawn to the circle? So this is one common tangent which I have drawn right now. This is the second common tangent that I have drawn right now. These are direct common tangents. And then there is a transverse common tangent. This is the transverse common tangent, and these two are, this is DCT1, this is DCT2. So the answer to this question is 3. Okay, there are 3 tangents that can be drawn to these along with these circles, right? Moving forward, talking about concentric circles. What do we mean by concentric circles? Concentric circles mean that they have a common center. Okay, they have a common center, and one is bigger than the other. Okay, because if both of them are same, then you won't be able to differentiate between the circles. So one is bigger than the other. Talking about the angle that comes in the center when two circles are basically touching each other. When two circles are touching each other and there is a common tangent that's coming in, so this triangle that is formed over here, I'll tell you a little bit about it. From this point, let's call this point P. PA and PC are two tangents which are drawn to circle A. Let's call this circle O, and let's call this circle Q. To circle O, two tangents are drawn from point P, which are PA and PC. Further, from point P, two tangents are drawn which are PC and PB. So Q is the circle here, and PA and PB and PC, and these are equal points. Why do I say they are equal? Because they are tangents. Tangents from one point to a circle are definitely going to be equal. If PA is equal to PC and PC is equal to PB, that means we get a situation where AP is equal to PB and it is equal to PC. This situation comes up when we have a right angle triangle. When we have a right angle triangle and a line from the vertex of 90 degree goes and bisects the hypotenuse, then at that time we get three lines which are equal, or which are equal to the circumradius, which are equal to the circumradius. What would be the circumradius? A circle would be drawn like this. Okay, this would be equal to the circumradius. So when all three of them are equal, then this can be declared that angle ACB is equal to 90 degrees. Okay, angle ACB is equal to 90 degrees. So the length of tangent in such questions would be capital R square minus small r square in root. Then the length of the chord would be 2 times of the capital R square minus small r square. Okay, in such situations. So here what we have is that the radii of two concentric circles are 12 and 13. So these are two concentric circles, one being this one and the other one being the bigger one. The concentric circles, the radius is 12 and 13, and AB is the diameter of the bigger circle, what I can see here. BD is tangent to a smaller circle touching it at D. Find the length of AD. Okay, we need to find out the length of AD. The full length of AB has been given as 26 centimeters. So a point which is on any of the segments of the circle, and it is a semicircle of sorts. So this is a semicircle that we're talking about. So automatically angle ACB is equal to 90 degrees. AO is equal to OB, which is 13. So entire length of AB is equal to 26 centimeters. So we have a 26 over here. Then we need to find out the value of BD. Okay, we also have a line which is joining a line. See, OB, the value of OB only. Okay, the value of OB is 13. The value of OD is 12, which is given in the question because it's the radius of the smaller circle. So 13 and 12. 13 square minus 12 square is 13 plus 12, which is 25. And 13 minus 12 is 1. So root 25 is 5. So the value of BD is equal to 5. If the value of BD is 5, the value of DC is also 5. Right? Because they have been bisected by these chords. Right? They have been bisected by these chords. Now, talking about this point, we need to find out the value of AC. If we use the midpoint theorem, we can say that OD upon AC is equal to 1 by 2 using the midpoint theorem, because there are two right angles. We have two lengths which are same. We also have two angles which are common. Angle B is equal to angle B. So I can say that this is a similar triangle. So in similar triangle, this proportionality theorem or midpoint theorem can be used. If OD is equal to 12, then AC needs to be found out. So the value of AC comes out as 24. 12 into 2, which is equal to 24. So the value of AC has come out as 24. Now we'll be talking about the small triangle where AD needs to be found out. So AD square is equal to 24 square plus 5 square. 24 square plus 5 square. So I think this is 576 plus 25. This is going to be 601. So root 601 is going to be the answer. Okay, so the value of AD is root 601. Moving forward, two circles touch each other internally if the radii are 3 centimeters and 4 centimeters. See, this is equal to 3 centimeters, and everything which is ahead of it is also equal to 3 centimeters because it becomes the diameter. So if the radius of the bigger circle is 4 centimeters, then I can say if this from starting from 0 till this is 3 and 1 more centimeter ahead, we would get 4. So this is O and this is O dash. The value of O dash, or the length of O dash, is 4 centimeters. Talking about the entire length starting from A, and let's take this to B. So starting from A till B, we have a full length of 6 centimeters, and we have already marked this as the 4th centimeter. So that means only 2 centimeters is pending. So the length of O dash B is equal to 2 centimeters, right? The value of O dash B is equal to 2 centimeters. Now, what is the length of the biggest chord of the circle? The biggest chord of the circle would be this one, the one which I am drawing here. This would be the biggest chord of the circle. Now I need to find out, and it lies outside the inner circle. So this is clear. So for that, this is a 90-degree angle, and from here I would touch this line. This line which I have touched is nothing but 4 centimeters. So I need to find out the value of, let's call this KB, KO square, KO dash square basically. KO dash square is equal to OB square plus KB square. The value of OB is equal to 2. The value of OB is equal to 2. So this is going to be 4, and plus KB square. KB square is something which I need to find out. This whole situation is going to be equal to KO square. KO square is nothing but 16. So 16 minus 4 is 12. 12 is equal to KB square, and root 12 is nothing but 2 root 3, which is equal to KB. So 2 root 3 is something which we need to find out, right? Let's move forward. Two circles touch each other externally at point P, and AB is a direct common tangent. Okay, they touch each other externally at point P, and AB is a direct common tangent which touches the circle at A and B respectively. Then what is the measure of angle APB? We've already done this. The measure is going to be 90 degree. The reason would be this, that this is a point which is, let's call it P dash. So 2 equal lines here and 2 equal lines here. This setup becomes a setup where we are talking about a circumcenter of a right angle triangle. That is why angle APB is equal to 90 degrees. Moving forward, now we have very typical questions which come up. You can read about them. The main point which I'll be talking about is the cyclic quadrilateral. In cyclic quadrilateral, the opposite sides add up to 180 degrees, right? The opposite sides add up to 180 degrees, and a very special relation comes up which says that if the diagonals bisect each other, then AB into BC, which is these two adjacent sides, they get multiplied, and CD into DA, these two sides get multiplied. Okay, so this is how it usually works. And also this, you can read about it, but trust me, very few times, hardly once in a blue moon, this such kind of a question has come. You can read about it over here. Now, AB is a chord of a circle with center O. This is O, and let's call this point O. And C lies on the circle on the minor sector. This is the minor sector. If angle ABO is 40 degrees, what is the value of angle ACB? If this is 40, by the virtue of both the sides being radii and them being equal, and this being an isosceles triangle, I can also this angle as 40 degrees. If 40 plus 40 is 80, the full triangle is 180 degrees. That means this big side, or this big angle, would be 100 degrees. If this is 100 degrees, and I land a point on the other major segment, or on the major side, or on the major arc, so 100, this would become 50, which is half of the angle which is subtended at the center. So this is going to be 50 degrees, and let's call it X, and calling ACBX a cyclic quadrilateral. The opposite sides are equal to 180, or the sum of the opposite sides are equal to 180. So 50 plus angle ACB is going to be 180 degrees. So 50 would go to the other side and we would get 130 degrees as here. Okay, 130 degrees as this place. Okay, let's move forward. In a cyclic quadrilateral ABCD, the diagonal AC bisects diagonal BD. So we are at the same situation where I told you the diagonals would bisect, then AB into BC would be equal to CD into DA. Okay, all the sides are given here. AB into BC, 16.5 into X, that we need to find out, is equal to AD into CD. Yeah, 19.8 into 11. We won't have to consider the points because upon 10 and upon 10 would get cancelled out. I'll quickly cancel things out as much as I can. This would be 15. 11 15s are 165. So the value of X is nothing but 198 upon 15. So if I put it under test, 15 ones are 15, I get 48, 15 threes are 45, and 13.2. So 13.2 centimeter is going to be the length of side BC. I've done nothing. I've just done AB into BC is equal to CD into DA. Okay, this is it. Right? This is it. Moving on, it asks me EFGH. EFGH is a cyclic quadrilateral. FGH is 57 degrees. What is the value of angle HEF? This is X. So we already know that X plus 57 degrees is going to be 180 degrees. So when I take this one to the other side, I get the value as 123. The value of angle X is going to be 123 degrees. Right? Moving forward, two equal circles of radius 6 intersect such that they pass through the center of each other. So these two are the centers. This is 6 and this is 6. This is 6 and this is also going to be 6. We need to find out the length of the common chord. Let's call the common chord as BC, and this one being A and this one being D. So ABDC. If I join these two, they are already passing through each other's center. So they are doing nothing but touching their own periphery. So that means triangle ABD comes out to be an equilateral triangle. Why? Because AB is 6, BD is 6, and AD is also 6. This comes out to be an equilateral triangle. Let's call it BX over here, which is the height of the equilateral triangle. The height of an equilateral triangle, is nothing but root 3 by 2 times the side. And we just need to find out double the height of this, because BX into 2 would become BC. So double of the height would be my answer. So root 3 times the side of the triangle. The side of the triangle is 6 over here. So 6 root 3 is the answer that I am looking at. Okay, 6 root 3 is the answer of the triangle, or if is the length of the common chord that I'm looking for. Okay, so this brings us to the end of geometry. If you have any questions coming up, do let me know about it in the comment section, right?